come join us?
People at the back, please come forward and see if you can plug any gaps. The volunteers at the back can also
Come on, I see the spirit now. People are coming forward to just form a single chain. I appreciate it really.
6 or 7 I think.
6 or 7. The experienced folks have actually formed the longest chain here. I think youth is falling behind. Come on, let's do it.
Girl power.
Come on, Ludo, let's do it.
Girl power.
Yeah, yes. Awesome. Awesome. I think we'll do it what we have here. So let's put up the decibel challenge.
So this is called an Energizer for a reason. We're like waking you all up.
Okay. So we have the decibel meter here. Okay. Last one is to hit 50. So let's shout A for society and let's start it to hit 50. Is that okay? On the count of 1, 2, 3, okay? A for society. Shout A for society after 1, 2, 3. Okay. AI for society should be the one which will get us to 50. Okay? Alright. 1, 2, 3. Oh! That's the spirit. Now let's start it for 75. Okay, we already reached 74. Let's do it 100. Okay? Okay. Okay, let's wait. Okay, so 1, 2, 3. No, we'll not done there. Come on, let's give it another time. Try, okay? Maximize. Okay, this thing we are cheating, we are not cheating, okay? They're making it better results. Technical folks are we.
One more time.
So one more time. 1, 2, 3. We still did it better now. Okay. One syllable. Manama. Okay. Only one syllable word is we. Okay, let's try that. Okay. Naveen. We are ready. Come here. Okay, fine. So, our voice should go to Naveen's laptop. Okay. Wire under it. Okay. So, guys, let's try once more. This is the last time. Okay, I'll not make this out again. So, let's target 100, but let's be happy with whatever we achieve, honestly. But our word for now is we. Okay? 1.
As loud as everyone can.
V. W-E-V. Okay? 1, 2, 3. Good work. Thank you all of you. Thank you.
All right. Now, I was telling you because Saiti was telling me that no, we easily hit 100, we go to 120 as well. But I'm glad we didn't do that. All right. That was a great Energizer. Thank you, Saiti. Thank you, everyone on stage. Thank you for that. We're running slightly late today, so let's keep it very crisp. May I request everybody to settle down? Please, very quickly. Volunteers, please help everybody settle down and close the doors. Volunteers, please ensure that the doors are closed, otherwise the ACs will not be effective. Please ensure that all the doors are closed. Volunteers, please ensure that all the doors are closed and everybody is settled in. All right now, so without further ado, again, once again introduction, myself, this is Praveen Chandrahas. I'm secretaries of Swecha, been with Swecha for around 17 years now. Some of you have seen me yesterday. But again, very warm welcome to day 2. Day 1 was quite exhilarating for me. What do you think? Was it good? Good. Okay, I'm not going to ask to get to 100 decibels now. But I hope it was fantastic. We have sent you a couple of messages. Most of you would have received messages on your phones for an updated schedule and a social media post blast that we are all going to do as well. Please do check your messages, mails. You would have received what to do, what is activity as well. Now, who do we have to begin with? A person, who needs no introduction, but again, please allow me to introduce Dr. Jaideep Ganguly. Dr. Jaideep Ganguly, not a physician, because we have a lot of other doctors as well today. He's done his PhD from MIT, and then now he is the Vice President of Engineering at Salesforce. Sir, I won't take too much of your time. Please do. Thank you.
Thank you, everybody. Good morning and welcome to this talk, and thank you for coming and attending. I hope to do justice to your time and make it interesting. We are going to cover 50 plus years of work in 20 minutes, so we'll be flying by decades in minutes actually. But I want to leave with you, there's so much of hype and talk about AI, some of it is good, some of it is not so good, that I wanted to take the opportunity to walk you through from the very early days, how it all started, because I happened to be there at MIT with, when all of these things were happening with Minsky and Papert and everybody else. And since then, what we are doing today is very, very different. And my first observation would be that I would urge you to consider that we don't know what intelligence is. So before we say something is artificial, we need to know what is the real stuff. If you talk to neurologists, and I am not a physician, I have deep interest in these subjects, so I study the brain. As time passes, my knowledge is skin deep, but I'll talk to you about how the brain functions for you to understand how our neural nets do today, to let you decide for yourself how the brain works, how neural nets work, how LLMs work. There's a lot of excitement because we've done some amazing stuff, and that should tell you the future years are definitely in this space. But we don't know exactly what that path is, that I want to caution you. But this is the most exciting area because the fields of neuroscience, quantum computing, machine learning are eventually going to converge, as you will see. So without more, so let me start with this, the first slide. Now where do I point? Yeah, if you can show in the next slide. This doesn't seem to work. Okay. Yeah, it's working, sorry. Yeah. So, the mid-80s to almost the end of 2000, almost, was all the era of what I call knowledge-based systems, logic. Somebody would put in the rules by hand, craft it, and the machine will get smarter and smarter, and eventually it will behave like a doctor, it will behave like everything, like the humans would not be needed. There was the 5th generation project of Japan, many of you may know this. None of this really happened. So there were projects at almost any university, everybody was working in this space. And they did produce some remarkable systems. For example, some of you would know the IBM's Watson. I personally was fascinated by Maxima. I don't know how many of you know, because whenever I struggled with math, I would go to Maxima and ask it to solve that problem for me. So whether it's Bessel functions or anything, it sort of did expand it and simplify solutions of partial differential equations. So it was a lazy man's way of solving math problem. And this technology, ability to deal with symbols, reason, primarily through two mechanisms, forward chaining and backward chaining. Forward chaining was very much prevalent in Carnegie Mellon. They came up with languages like OXPy. MIT came up with Lisp as language for symbol processing. We used to call it my friends used to call it lots of irritating single parentheses, because Lisp was famous for its first brackets. And then there were people in Europe mostly were into propositional logic, like Olmerer and others, who like to believe that logic, first order predicate calculus will solve everything, and that gave rise to the languages like Prolog. And for almost 2 decades, people thought this was AI, and it is not today. So all of us who did our PhDs in this era, and there were so many of them, we are pretty much obsolete, because none of this really is out there. Now, around way back, 1959, Arthur Samuel was given, he was basically a mathematician at Bell Labs who came up with this idea of machine learning. And his idea was very simple. You put some data, put some model, and it will sort of crunch it and produce some answers, and effectively the machine will learn. That's what machine learning is, and linear regression and other forms of algorithms like Vapnik support vector machines, a little bit more mathematical. They were all in this field, but they were basically, it was like a statistical approach, you would say. It's really not intelligence, if you ask me. It's some data you throw in, and you crunch some numbers, and eventually it comes up with the optimal model. So that was that era, and then the math behind, I want you to be patient and not sort of be irritated by these very simple equations. Machine learning is pretty much one equation. It is your some objective function, which is in this case is an error. Some model, the equation one is a model, a very simple linear model. You run some positive, what we call convex function, because it will always converge, and you keep on crunching and minimize, and eventually we will get an answer. And this is how the gradient descent, that as you start up with unknowns, theta 0, theta 1, which you don't know what they are, x1, x2, you keep observing, y1 you observe, you keep doing it. You go back to your school days when you fitted a line with a bunch of points. You minimize the error. It's very simple elementary arithmetic, and that's all that's working in neural nets. You'll see that later. Now, interestingly, and I'll always go back to the brain actually functions like that. It does backward propagation. But let's wait for that slide to see why that is not that simple. But there is obviously a way when we make decisions. If you look at the brain, by the way, is a very complicated thing. There's a prefrontal cortex, there is amygdala, there is hippocampus, it's a zoo, 80 billion cells. So each part of them actually function differently. And here we have a very, very simplistic model which says we are going to regress through this and find a model. So that's the beginning of the machine learning. And not everything is a number. Sometimes it's binary, yes and no. So there we tweak this a little bit to this formula, and for people like who are a little bit into mathematics, they immediately realize that we get to something called log likelihood to force the answer to between 0 and 1. So it's very elementary stuff really. That's all there is to it in the world of ML. Either of these two equations are working, whether it's neural networks, whether it is GPT, whether it is reinforcement learning, whatever you say, machine learning is only classification. Don't forget this one statement. ML is classification, classification, classification. When I say 10 words, what's the next word? It is one word out of the dictionary, which is typically 2,000 words that we use. So it's a classification. 2,000 classes, you pick one class. GPT, same story. Decision trees, same story. So ML is classification. ML is not intelligence. Okay? Now, let's proceed forward. This is the first part of our discussion. And we come into some very elementary concepts. Obviously, you have to do correct fitting. Some of the words are like overfitting, underfitting. Means that if the model is too simplistic, it will do an underfit. You're trying to fit a circle with maybe just a straight line. Obviously, it's an underfit. Overfit, you get it. You are trying to force a solution. Now, we don't know these parameters. We don't know how many features we need. So how do we know what to be fit? And that discussion will come back to this in the world of GPT and LLM and see how this has become such a huge problem. So the one thing that is now, at this point, you know that an elementary linear model with some kind of objective function that you want to minimize, you will run into one of these issues. Either it's an overfit or it's an underfit. What's an overfit? Well, you have a cubic function and you are trying to fit something which is an 8th order or 10th order. And you can do that because you have so much data. And the reverse is what? You have actually a parabola and you want to fit a straight line. The problem is you don't know. The machine doesn't know what that curve is. So, and this will become, I'm spending a minute here because you'll understand how this takes shapes in GPT. how that becomes a formidable problem in generative AI. Most of people are overwhelmed with generative AI, but that will come back to haunt you in the world of generative AI, this particular slide. Now, next is the last slide, which is mathematical. I promise you there's only one. That machine learning, I said, it's all about classification. So not everything is continuous. There are groups of things. So way back, Claude Shannon, everyone would know him. He came up with the concept of entropy. And what that really means is that if there is order in the system, entropy will be low. It's a thermodynamic concept, actually. It's kind of common sense. There's a lot of, like for example, if you don't know anything what's going to happen tomorrow, that means there is no probability of, you really can't say anything with any probability. That means there's a lot of entropy. It may rain, it may not rain, it may flood, it may not flood. So nothing is known. So there's total chaos. That concept is Shannon's entropy. It's typically used in something called a Pelong cube format. What the name is after this gentleman. Very simple concept, the Hilbert-Leibert divergence. That you pick a model and you see that formula, that you last line, and you see how it matches with your reality. See the divergence. If the divergence is 0, that means you got it right. If the divergence is huge, that means your model is not good enough, and you keep iterating. Why do you need this? It's unique in those classes of problems where it's classification. So we end phase 1 of, I talked about the decision tree. We talked about regression. So you now need to come up with decision trees. Because that's another, we call decision trees also as artificial intelligence. At least we used to claim that once upon a time. Now, many of you would have played with XGBoost. It's a beautiful algorithm, very simple one, works great. If it is like 10 or 12 lines of parameters and very simple code, less than a page, works wonderfully. And all it does, it does something like this. That if I'm tracking soccer games and I want to make sure that how do I structure them, the tree, do I group them by the teams when they play in the morning, or do I group them they play in the morning in the local, in the what they call home and away? How do we group them so that the information comes out very, very lucidly? And that's where we applied this entropy concept. The formulas that you saw there, you would like to come through these very elementary numbers and come up with an information gain, what they call, and see the one that is the highest information gain, you would want to organize your tree, your so-called tree that you see in Excel or anything, in this format. So classical AI stops here. It comes into using regression, some model, and classification. So that's the end of 20 years of work. And obviously there's a lot more, I think you get the sense. Then we move on to the world of neural nets, which will lead you to LLM. The neural nets, around 2000, when Hinton showed in the ImageNet conference the beauty of the CNN algorithm, how, and Hinton is actually credited to this gradient descent algorithm and the variations of that, and showed that the enormous capability of machines to recognize images. And it did a pretty good job. I mean, it could tell varieties of cats, varieties of dogs. And you will see later that while this was very nifty, it took enormous computing power to recognize. The amount of training that had to be done is mind-boggling. Now, but then that spawned a great interest in machine learning through neural nets. And today, for example, when you use Alexa or when you use Netflix, you will see all these neural nets making recommendations for you. So all of that is powered by this so-called deep net. This is interesting because by the time in the late 70s, 80s, it was completely discredited, initial, and then kind of came back. And now, all of you know this neural net stuff. I captured it in one slide, very elementary stuff. What you see on here on the sigma sign is that a bunch of inputs are coming in, and theta 0 to theta 1 are the weights. You multiply them and apply a function, and I'll come to why we have that function. The function is given below. It looks like a S-curve. There are 3 of them, sigmoid, hyperbolic, and rectified linear. So essentially it's a threshold. So when you multiply all those summations and you pass through that function, it crosses the threshold, then you get the next value. If it doesn't cross the threshold, it doesn't. and you propagate. So you have this incredibly complicated network, and again you do the gradient descent that I talked about earlier, and all of you are probably familiar with it. You don't even need to know, most of the software will do it for you, and you crunch backward, the weights will get adjusted, and that's your neural net. Now, does it converge? Nobody knows. Actually, in many cases, it doesn't. And why doesn't it converge? Because most of the time, the optimization, for those of you who are mathematicians, will immediately recognize it's a local maxima or local minima. So it's like saying, I went to see the to the Mount Everest, but I landed up in Nainital, and I didn't see any other peak higher than me, I can't say anything. So I concluded I'm at the highest peak, when you're not. So that's the problem of this approach. And people try to solve it, we'll talk about it a little. But I want to spend a few minutes to understand this slide and the next slide. So what you see here as the sigmoid function is the activation function in the brain, that once the threshold crosses, is fed into that function. If it crosses, only will it go to the next neuron, otherwise it is zero. And so, how do you know what the thetas are? You don't. You just throw in some random numbers, and then you run experiments to see what it produces. It's completely supervised. Does it give the answers that you see? And that's exactly how LLM works, by the way. If it doesn't, you start changing the weights again. How do you change the weights? When you change the weights, by the good old chain rule of differentiation. Remember that anything that I've talked in math here, you probably have done in grade 11. Probably earlier, I don't know, these days probably they teach it in class 2, I don't know, but given our competition. But this is the beginning of the math and pretty much all that is used. But here lies the problem. This is what the brain is. Now I have a deep interest in the brain, so I am not a physician, I know very little, so with that caveat, I will tell you how the brain works. What you look at the nucleus, that's a neuron. And neurons are connected to the next neurons by axons. In the axon, you see there's a junction between the two neurons. What you see is the synapse, which is blown up there. The synapse is the Greek word which means a gap. It is not a continuous connection. So first thing you should understand in neural nets is, if a signal is 1, and if it crosses the threshold, the next neuron thinks it's 1 multiplied by the weight. The next one goes on, so the signal will travel entirely. The only way you can flick on and off is a sigmoid function which simply says, is it going through or not? It's almost like a gate. It's not almost, it is a gate. That's not how the brain functions. The brain, the axon is, the brain, the neural, the first part, the axon is an electrical signal. The electrical signal that comes to the synapse stops at the electrical signal, because there is no connection, it cannot go forward. Understand the neural net and why LLM, all of this is coming from this. And if anybody is a neurologist here will immediately jump and say, will be excited at this. What happens when the electrical signal comes at the synapse? The synaptic junction sends a chemical message. The chemical message is produced by the electrical signals by 1,000 plus genes. There are 1,000 plus genes right there in the signal. How do these electrical signals proceed? The electrical signals start by what is called an action potential, because of the difference between sodium and potassium. Inside the neuron is potassium, outside is sodium. These sodium-potassium potential differences start the electrical signal. So anything that you see, anything that you do, anything that you hear, anything does is a result of this action potentials. The entire brain, this is the zuban of the brain, it only says action potentials. Now the problem is, when the action potential goes to the synapse, how that signal will go out is not a single signal, it's a signal there on the right bottom there, all those fields. The very interesting thing about the brain is that the code that goes out is a sequence of signals. All of the signals are of the same height, amplitude, but the packing of the signals are different. the amount of information that is flowing out is enormously complex. There are people doing research on that, and I'll tell you how these researches are done. So our model of neuron is an extraordinarily simplistic model where it simply says a signal comes in, it goes out, but that's not what it is. When you hear a piece of music, first of all, your brain, we are making a neural network the assumption that the neurons are uniform everywhere. That's not the case. The brain consists of distinct segments as what we know. The hippocampus, the hypothalamus, the amygdala, the prefrontal cortex. There are different parts of the brain. The brainstem is where all the chemical serotonin, dopamines are all generated from there. All of these things are used in the synapse to decide what kind of chemical signals are flowing. So you will immediately realize that this is a digital plus analog, whereas a neural network is completely digital. So neurologists will tell you what we have produced is more of a caricature, more of a toy, thinking that, oh, this is the brain. And neurologists don't even understand it, by the way. There are 80 billion neurons in the brain. 90% of the brain is water. 10% is actually used. Different parts of the brain are collaborating with different parts. So there is an objective function going on. We don't know. It's not that there's only one part of the brain that's doing the objective function. It's all over the place. We don't know which classes of neurons work together. The neurons differ. And now I think you will understand that the complexity and how this is different. There's a guy called Mridul Kasur at MIT who does this, he's an electrical engineer. He does a lot of, I've been following him for a long time. He does work on understanding this, and the way he does that, he has instruments on photoluminescence and high-speed, studies on mice cells. So different parts of the brain lights up. There are videos out there you can see. So that's how he's sort of back calculating and saying which portions are working where, what are they doing, and is there a mathematical representation of that, right? So obviously this is way too complicated. And by the way, even before you go to the next step, there are people like Roger Penrose who believe that it's not only these neurons and synapses, but actually consciousness and thinking is part of a lower level quantum processes in the brain's tubules, microtubules. So this is like quantum computing, and I don't even understand that, there's no way to tell it whether it's right or wrong. So obviously one part is that the brain doesn't work the way, like neural nets. Even this description, according to Roger Penrose, he thinks that there is at a quark level, something has happened, quantum entanglement. If you really have to read his book, I think the book came out in 1999, and it's a viewpoint where he draws concepts from Gödel's incompleteness theorem, quantum computing, quantum physics and brain, and there are people like Max Tegmark who don't believe in it. So I just don't know. I mean, I'm an engineer, this is way too far out. We are not even here. So now you are here. Okay, now let's continue. So what did the computer scientists do? Well, they did some hacks. We're good at hacks. We said we'll have RNNs. We are going to take the state from one to the other. Basically, all the weights will carry on to the next state. And then they realized, so this will be like you deal with sequences. Because earlier neural nets, I showed all the input coming together. Now it will come as sequences. But then we soon realized it doesn't converge. Many of you know, RNNs don't converge. They have the problem of vanishing gradients or zero gradients. And so this was given up. Then we did more hacks. We said, okay, there's a smart guy in Germany. He said, you will know, this works actually pretty well. LSTM, long short-term memory, that will have some gates. We introduced self-state and said we're going to tweak with the RNNs and force it to forget something and remember something and suit. And it worked for a limited, and for example, it's intuitive to you. If you say Ram met Sita, that makes sense. But Ram met Ram doesn't make sense, right? So I will force that through neural nets at a self state to force that whenever Ram meets Ram, no, that's not a valid sentence. So that kind of, basically common sense reasoning. But then also there's another branch of subject that popped up. We can't go into details of reinforcement learning. A very, very important part of machine learning is reinforcement learning. RL is how I believe the brain works. Now there's different views of thoughts. Imagine a baby. A baby looks at 3 cats and recognizes the next one is a cat. A machine has to be trained with a billion images of cats, a million images of cats for it to recognize. So obviously something is very different happening. And the very different is happening is obvious also from the fact that the brain is very slow. A brain works at max 200 cycles per second. Mine probably works much less, but anyway. And a computer runs at gigahertz. Just imagine. But a baby is able to say, a cat is a cat, within as soon as some neurons are developed in the head, very quickly. A computer, you keep feeding forever and it doesn't. Why is that? Because of the information content. The content that after the synapse what signal goes out is far more enriching information than what goes out of a neuron in a neural net. Remember, your brain is probably 1 kilo, 80 billion neurons in 1 kilo, which is less than 2% of your weight. Yet, it consumes 80% of what you eat, energy. Fascinating numbers. So, all the stuff that you eat, all the pizza, cokes that we eat is all going to fill the brain, basically, right? And that's because the content of information that is created is of so high order. Whereas computers are basically doing very simplistic calculations again and again at a very high speed. That's a big difference. So now, we did some hacks and that worked, but then I'll move to the last part because we have time constraint, because this is the part where you probably are most interested in. All of that suddenly gave rise to the world of GPT. In 2017, this Google guy came up with a paper which caught my attention in 2017 itself because of its attention, with the title. I thought this is a really weird title for a paper. So it grabbed my attention. So I read it a couple of times. And then I found that actually in 2014, Benjo and one of his students, Benjo from, I think, NYU, and Badano had produced an earlier paper, very similar in the context of translating languages, I think German, where they introduced this concept of, I'll come to that, but what did they try to solve? All of us know that this is the problem of machine learning language. We went to the bank and learned of his bank empty account, after which we went to the river bank and cried. Now, a machine will be completely flummoxed, right? This is the problem of language. And that's why we talked about neural nets, that's why we talked about LSTMs. None of these really work. And people who worked on classical languages like Barbara Liskop and before that Chomsky, both of them at MIT, they had a completely different approach to language. Suddenly the neural net guys came and said, LLM guys and came, we solved the problem. Did they? So let's look at that, because in these days, if you can't say GPT, you are not very smart, right? So we have to say GPT. So this is what GPT is. GPT introduced a few very interesting concepts. Simple concepts, elementary concepts. The concepts are, these are the last 3 or 4 slides. After that, you'll be a master of GPT and LLM. And you will see that this is now democratized. Everybody in the world can build these things. It's not just big companies with, all you need is a lot of server machines. You have to also, earlier we talked about neural nets being fed data, then we said one after the other. Here they introduced a concept that I will provide positional embedding. That means, where do these nodes out? Where do these words walk? So he went to the river bank. Every word he went to the river bank in a set of bits will also encode where that word exists in relation to the others. So it's actually a positional embedding. For the first time, they introduced that. They copied a concept from good old databases. Query times key must give the value. For anybody who's coming from the database world and a relational database will immediately recognize that query key value are nothing but database concepts. Query dot key must give me the value if I got them right. We'll see how that. Then they used a concept I'll talk about: attention, information prevention, and normalization and decoding. Very simple ideas. Let's see how this works or does not work. So first thing, the words that they come in now, they're coming serially. Words are not letters, words are embeddings. All of you know that. There's vector representations of some numbers. What we do, we create 3 arbitrary matrices, weights, neural nets, query, key, and value. What are the weightages of those? We don't know. Arbitrary. The idea is that if I do Q dot the input, whatever is coming in, it is a query representation of that same input. It's not the input, but the query representation. Bear with me for a second. I do that also for the key. Obviously, these are all wrong because your weights are wrong. You did the dot product, you got something, then you got Q and K. If you did a dot of those 2 matrix multiplications, you will get the value. Now, the value is also wrong, but hopefully they'll get trained. How will they get trained? So now, I have this embeddings coming in. I did the multiplication. And no, I don't do one representation Q, K, and V. I actually, V you don't create, V is generated. Q and K, I create 4, 8, multiple random matrices. Because you don't know what to start with, you create with multiple. So this is called multi-head attention. Why is it called attention? Query.key is the attention. How many of the Ks and Qs do you do? 8 of them. Why did they do 8? Because that's what the Google guys started with. There's no reason. You did that, and then there's a technique for collapsing them to make them linear. Now you've got 8 results. Intuitively, it makes a lot of sense. If I tell a sentence, it's very hot today in Hyderabad, and if I ask the same question to 8 people or 10 people, their reactions will be different in their mind. There will be 10 interpretations, some of them similar, some of them not. So the language assessment of this sentence cannot be led by just one query and key, and that's essentially the idea, that we'll have multiple of those. And there are some very elementary matrix multiplications and coalescing of these that will result in one final output multi-head attention. And what that attention is actually very simple. It is you can clearly see, it's almost like a masking, I'll give an example after this, but also they did another nifty thing. They said after this query.key, they would add back the original positional embeddings back to it again, because there's no mathematics behind it. Why? They just felt like. Because they would think they've lost the original positions of those words, what they meant. So while I have the intent captured, I'm again adding back the positional encodings, and then they do some normalizations, because this matrix has some are big numbers, some are small numbers. So you normalize by standard deviation and mean, and add a little bit below that 0.001, because sometimes if it goes to 0, it will blow up. So you will get a new matrix. So this is your multi-head attention matrix, elementary math, right? Now, if you did all this stuff, you would get a matrix like this. And if you stare at this matrix, when you play the Game of Thrones, you will see the diagonal is very high. Why? Because it's most relevant to itself. After the crunching of this KQ, when you do all this matrix, this is like the Sobel matrix in image recognition, FinTech rather. Here, you have the words which are mostly relevant will pop up and higher numbers, and that's your attention. So, for example, the word is pretty much 1 to itself, because the word is most relevant to itself. So when you say play the Game of Thrones, you will say the word the is not so important, so it's mostly 0. But when you say, some word like game, when you play the Game of Thrones, you will see correlation between game and thrones, if your query and key were trained properly. So that idea is out there. And then what you do, the rest is very simple. After you do this stuff, what you do is, you take the K, Q, and K from the decoding part of the story. Remember, this was the decoding part. We started off by saying the left part is decoding. Left part, that is decoding. Position and embedding, multi-head attention, then again added a normalization. Now you got the Qs and Ks, which is fantastic. And then you take it to the other side, and you're all done. You take it to the other side. Now you have to produce the next word. How do you do that? You simply mask the attention matrix to zeros of the words that you haven't seen yet. Repeat the same process. So basically what you do after that, you will crunch to this number. Okay, I'll just stop here and take some questions, but essentially right at that step, after you got the did the dot product and produced a value and did the same old stuff again here. And eventually at the last layer, you are still doing a softmax, which is meaning picking a word, a statistical most relevant word. And so you now see that there goes your intelligence. It's at the end of it, it's a statistical machine. And it picks up a word. So you feed Wikipedia, it reads one after the other the words. After reading 10 words, it predicts the next 11th word. As long as it gets it right, it continues. If not, it goes back and iterations and keeps on changing. This, by the way, at this point is billions and billions of parameters with so many neural nets all over the place. And so eventually they'll get it right. But now, here's the thing, the last slide of my talk is, So GPT does not replicate human cognition. First thing we should understand. It differs from human cognitive process. It's a statistical weight of one word with the other words. It's almost like saying, I am going to fit all the curves in the world with one parameterized equation. You know, and anything that you throw at me, any equation, parabola or whatever, circle, I'm going to take this one equation, which has all these weights, and it will give you the answer. So it is at best a weighted solution to that. Number two is that it will be prone to errors. What we love to say in the industry is hallucination. There is no hallucination, it's an error. It is statistical error coming out from picking a softmax. Remember, at this, then you understand, GPT doesn't understand what an African elephant is. It knows Africa, it knows elephant. It doesn't understand African elephant because the elephant is the softmax of the previous stage. It doesn't understand a Bengal tiger because it knows Bengal. It has seen many times Bengal and then tiger. So it will say Bengal tiger, but it has no notion what a Bengal tiger is. So, but it does jaw-dropping things. That you guys have seen it. And that's because, and nobody knows why. That's the beauty of it. Because statistical, basic statistics will tell you any overfitting will give you bad results. But what is very interesting in GPT is, as you fit more and more data, the results go up, then it goes down, then again goes up, and then again goes down. Why is this behavior happening? Nobody knows. So use GPT at your own peril, but I think you now know the opportunity is understanding the brain functions more, translating into neural networks which mimic the brain really, if you understand that, and add real computational processes, the convolutions that are happening inside the brain, the image processing that are happening. Realistic modeling of those things are what will shape the future with the computing power that is arriving at our doorstep. So this journey will continue, and it will be, we just don't know which way it will go. But hopefully, with this I'll stop, and I know I'm over time, but hopefully this was interesting for you. If there are any questions, I can try to squeeze in a few. Any questions? Okay, sure. Yeah, thank you. Water. Okay. No, so I think with this, I'll make it better. Sorry, go ahead. You had a question? Okay. So I think I have been able to explain to you that it is not a language model. It is a statistical grouping of words. And if it has seen many of such examples before, it is likely to parrot it. Think of it like your African grey parrot. It hears 10 words, it will say the 11th word, but it doesn't understand what it means. That is something you need to keep in mind. So, by the way, it's in my website. This talk is in my website and jganguly.github.io under ML. If you have any questions, you can reach out to me on my email. Okay? Thank you.
Sorry about the questions because we are running, behind schedule. Thank you, Dr. Jaydeep. That was quite a heady mix of mathematics, biology, quantum physics. Sir, Jaydeep, sir, you kept saying this is all elementary. That only served to remind me that I'm poor at all three subjects that you're touching upon. No, but thank you for this wonderful opening keynote. Might I now, volunteers, can I have the panels? Naveen, volunteers, can I have the panels arranged, please? Naveen? Yeah. All right, now we'll head into the first panel discussion. The panel discussion will be on open source and AI, the way forward. Again, open source needs no introduction as to why you're doing this panel discussion. But let me invite the panelists onto the stage. I'll start by inviting Mr. Nagarjun Malladi, Vice President, Tech Mahindra, a huge supporter of Swecha and open source software. Nagarjun Garu, Nag Malladi as we call him. Might I invite Rajendran Kaushik, Principal Architect, AWS. Thank you, Kaushik. Thank you for coming over here. Ranganathan, Ranga, I call him, co-founder, CTO at Everest Engineering. I would have been surprised if that reaction did not come. Right? Ramesh Loganathan, a person who needs no introduction, a huge advocate of open source, has been an influential figure in the startup ecosystem in Hyderabad, currently a professor at IIT Hyderabad and is involved with the CIE, Ramesh. Might I invite Amit Kumar? Amit Kumar is a senior director at Salesforce. Thank you, Amit, for coming over here. And to moderate the panel, might I invite Kaushik Katrapati, who heads data practice at DigiQuanta. DQ is one of the AI/ML partners for this conference. Kaushik brings in more than 18 years experience with working with data and other things. I have a small request to make to the panel, Kaushik and the others. Shall we see if we can close by around 11:40 because we have other speakers already lined up. We'll try and see if we can close by 11:40. I know we're supposed to get 1 hour. We'll see if we can close it in about 35-40 minutes. Okay? All right. Thank you everyone. Over to the panel.
Good morning, everyone. Good morning, Hyderabad. Very good morning. So now that we are on day 2, we have mostly covered the basics of what is AI, why are we doing it, and now we have seen how is it done. But now the concepts of, now that we have seen all those things, I would not like to go in detail about what exactly is the model, how can we do that. So on those topics, I would like to talk about why we are doing this, right? Like the Swecha's motto, the open source concept of Swecha and how it can be leveraged for the betterment of the society, right? So that's the motto of this entire conference. So that's what I would like to
Thanks, Kaushik. Good morning, everyone. First of all, I'm a firm believer of open source myself, personally. And even when I started my career, I remember developing frameworks. Even before the microservices world, I was building something similar to that and open source entirely. So, again, let's just take a simple stance of what open source is, right? It would simply mean a way of a developer or a contributor sharing their source of information or code or whatnot with limited or no licensing arrangement or whatnot. So basically, anyone can flexibly or freely use that source of information. It could be a code, it could be data, it could be anything for greater good. So if you really look at why open source is a popular topic now, if you look at why developers love it, our customers from Amazon or AWS, our customers love it. One, it accelerates innovation because you don't have to start from scratch. For example, today if you want to build a model, you don't really start from scratch. You have lots of pre-trained models available in several hubs and whatnot that you can actually take, fine-tune the model and then deploy. You take any project like, for example, you take Java, JDK, and many other things, right? You are able to take advantage of them and innovate faster too, right? And most important part is the trust. Because you exactly know what goes inside this particular source of information or a code or whatnot. And you'll be able to tune into your own enterprise or your own startup or even research purpose. Now, all of this flexibility also extends and supports you with cost. Because you don't have to pay licensing or whatnot because it's simply open source. You can actually take it, fork it, and then use the way you want to use at your disposal. Now, I think these are some of the benefits. Being a researcher, being a student, being an enterprise or a startup can greatly take advantages of and build on top of it. So, I mean, again, I'll not dive too much into what we are doing, but AWS have been proponent of open source, and perhaps I'll talk more on other concepts. I hope I answered it.
I would like to have a follow-up also. So, who decides whether a particular model is really open source? Is it like Azure? Is it like half open? Is it like only the model open? Is the data open? So, do we have any standards, or are we working towards any standards of making AI open source?
Good question. In fact, I wanted to touch this, and somehow I did, which is, if you look at especially open source and artificial intelligence or machine learning, right, there are two things to it. One is the model itself, like for example, your set of instructions that trains on your data and then infers on top of it, right? And the second is the data itself, like on what data it is trained on, whether that data is an enterprise data. For example, I can simply take the whole algorithm, which could be open source, and train using my enterprise data. Now that doesn't mean that the whole model can be utilized for all open source purposes. If you look at even today, I'll not name, but generally speaking, many companies, and the startups or anything, were doing many number of very interesting innovations or proof of concepts. But for them to go to production, the problem is the models, not only a source that needs to be open source or at least a license that makes sense to them. Most important thing is the model when it refers and gives the output, the data, whatever it has, shouldn't have any complex conflict or whatnot, right? So, to go back to your question on who can do this, I think obviously the contributor who has actually contributed to the open source should be transparent enough and say, okay, based on what data the data is trained and whatnot. So, I mean, again, from Amazon's standpoint, the models that we build usually come with something called, we identify our customers from using such models. For example, if you're using one of the models that Amazon, like for example, Titan text generator or whatnot, then if a customer is using those models and generating a result, and tomorrow, let's say for whatsoever reason there is a copyright issue, it is AWS that will identify customers and will depend on the customer. So I think these are emerging patterns in the industry, and I would also say it is with the contributors who should really evolve and come back and say, okay, this is where my data, this is where my data comes from, and this is my model, how it is trained, and they have to be open to it.
Okay, thank you very much. Okay. So the next question will be for Amit Kumar. So Amit, we see.
see this is a three-pronged problem. One is the algorithm, which now have a lot of variants available right now, the llama, the falcon, whatnot. And the second is data, which is again available, and if you don't, you could just scrape Wikipedia and get it, or a lot of other sources. It's barring enterprise that they're talking about. And third is compute. So that is where I see there's a gap. You can get data, you can get algo, but you cannot get the compute, because compute is limited to all these big orgs. And that reminds me of something like, I think one we were passing out to college university here called CT, so search of extraterrestrial elements, right? Where they use this public infra to run their algos. And then we did the same thing years later in terms of Bitcoin, where everyone is using their phone and harnessing those Bitcoins, right? I think that's something which we as individuals can do. But there's a good part of it also, the government is also serious about it. I was going through some of the government projects like Ashmi. That's something which is trying to provide a compute part as well as algo. Then you have different states or individuals also, like I was talking about Tamil Lama, then there's a Kannada Lama. So I see people and orgs are getting interested in this, and they're adding a compute factor to this. I'm seeing it's very positive direction. Again, it's for all of us to contribute to that. And Bitcoin is not the only shiny thing, this is the one.
Thank you very much. The next question is...
Kaushik, I want to add to that. Yeah.
Yes, please.
So two questions together. Like one is like why people are going open source. I think first thing on the AI aspect. I think one thing I am personally, again it's a strong statement, is that let us take all the companies, right, corporates. They are building up all this AI and like they're thinking like crazily going on dimensions. And if you see all the research comes from universities and then eventually come to like they don't have like resources or like the computing power, which comes from corporates. Now the merger at some point is coming up, and then they are like trying to produce models which are like right now like close to 361 billion kind of parameters. It's like really, really huge models, like really scary ones. The thing is, assume that the corporates hold on to itself, right? And few more corporations are holding on these stuff within themselves. I think it comes to a point where like right now nobody is realizing the perils of it, but sometimes like somebody wakes up and the government says like 3 weeks back, the European Union said like, hey, you know what? AI has like an act right now. That's the first time somebody came and said AI has an act. They worked on it for 3 years. They came with like absolutely beautiful tools. Like within the first version, it's like really good. So they're saying like, what are the sorts you're training up? You need to be very open about it. So they're like really good points. The point is that could have come any point. Now, assume that corporates are holding on everything within themselves. There is like a point where like they are having a commercial value, but some of these acts will just stop them from doing what they are doing. So there is like an obligation, which may be a reason why somebody is doing it. Like we don't know. Like that's one reason. The second one on the governing factors on like how to stop or like manage that, I think one of the aspects that I personally feel is there should be like a third party agency. Like for example, like let us think like all the countries are formed by themselves, and then like they're all sovereign states, they can do whatever they want, right? Like nobody's coming and telling them, oh, you can do this, you can't do this in AI, you can do this. But with AI it's very strong, right? See, assume that it's like again because there are students to understand it's very easy, like assume that it's a nuclear bomb that the countries are building. There is a treaty which says that you can't go and do these things, right? A very strong treaty which is blocking them. But that's at nation level, it's not at a privatization industry level. So what's stopping them is like maybe UN or like a group of countries coming together and stopping it. So eventually I think right now that it's not there, but there's a governance model that will come up which is equivalent to an UN for like AI, and that treaty like that's the first version of EU, but a lot of other countries should come out in a strong way that like it's managing the governance very strongly. Yeah.
That's very good. Again, we would like to revisit that point of governance. I have a follow-up question on that. But before going there, I would like to ask Mr. Ramesh Loganathan here regarding, we see a lot of these big corporates having collaborations with IIT Bombay, IIT Hyderabad, IITs, like doing a lot of AI research with a private and public partnership kind of a thing here. But the question here is, do we already have any collaborations between our premium educational institutes? We have so many educational institutes doing a lot of research work. Do they collaborate themselves, within themselves, in developing a larger data model? And what does it take to have that as a proof of concept for the larger private audience, private enterprises to come together and adopt that model in their work culture?
So, the academic institutions do a lot of work, and there are funding agencies, especially government these days, is asking for consortium proposals, right? A lot of consortium projects where they expect 2, 3, 4, 10, 15, 20 institutions to come together, right? And they're realizing that like, while each institution is very good and can do a lot of work by themselves, but if they don't bring the power of all institutions, the scale cannot happen. But it's very hard, very, very hard. I mean, I've been referred to Bashni. It's a project where, like, in its predecessor form earlier, the Indian Languages Technology Mission, or Technology FO, what's called, project, I think, had 10, 11 institutions, leading institutions, all the old IITs, IISc, Hyderabad, and such. 10, 11 top research institutions, language space, that engaged for almost 15, 16 years. A lot of research work came out. Zero solutions came out, right? And so then the ministry realized and then tried to do a few other things for a couple of years, and then in 2021 conceptualized this Bashni project, where now the project is supposed to get tangible solutions in the field. It's more than 2 years since it started, and still there's some solutions, but not as much and definitely not as fast as anybody would like, as the government would like. So these are institutions that are research institutions, very socially minded already, right? Academic institutions are social in nature, research institutions are social in nature. And academicians are social in nature, especially when they say no to kind of fancy industry jobs and then take up academics. They have a very strong social and societal mindset. But while the intent may be there, execution is very hard, right? How do you get multiple institutions to collaborate? Even government is able to do it only by making it a funding requirement. If it can happen, if we can figure out models where, so which is, there's a shared purpose, shared interest, which has to come a little bit more organic, right? When we talk about, I mean, we try to do this for international collaboration, but the same thing applies here for domestic collaboration. But the only thing in domestic collaboration is faculty know each other very well. So a lot of peer-to-peer collaboration happens, like two institutions collaborate because two professors know each other well, they take up a joint project. So that way we take differently, probably at least half our professors have projects that they're collaborating with others because of their own connections. And then there are others that do it because the funding mandate is that you have to be in a consortium project. But when they don't have a natural collaboration, what happens? Technically there are 10 institutions collaborating, but they're working on 10 very independent parts. So in effect, there's no collaboration. It's like, it seems like a collaboration, but they're just broken down into 10 independent parts, and so again defeats the purpose, right? The idea is that like sum of 10 parts should be much more than 10. Here at best it is 10.
What does it take from a governance or a government perspective, policy perspective? Does it help you to have more enforcement?
I think, see, we have this thing, right? If you have a battle cry, that aligns people, right? You can't say it's a funding requirement. Yes, there's a purpose why the funding needs consortium, because the belief is that it is that kind of scale. National quantum mission. There was a consultation meeting in Delhi, led by the Principal Scientific Advisor and the EDSC Secretary. Every research group in the country that's working in quantum, about 60 of them, were there in that room. 400 people in the room. You name it, and that institution had 2, 3 people from the institution in the room. Phenomenal meeting, and they're finding ways, they say quantum especially, it's not something we can do unless we align all our forces, completely aligned. They're finding it very hard. I mean, like, again, these are institutions like, I'm not from the space, I accompanied the professor who leads our quantum effort, and he knows many people. Like, everybody in the room, you at least 10, 15, 20% of the other people. They're that well known, whereas quantum world is not such a big world. They all know, and still not as much collaboration happens. I think what government could do, policy and financial models is one thing, but that is not enough. You have to create a battle cry, create a mission mode which everybody aligns to. They need to happen. That is very hard. I mean, that needs a strong leader, strong vision, identifying that and articulating in a way that it aligns everybody around it. It needs that. I mean, like, true open source is a community movement. If you want open source model research across institutions, the community has an aligned purpose. Random people don't come and just work together. People that believe in one purpose come together, right? So government, that's the hardest part, creating that purpose, which is a battle cry that gets everybody aligned together. That's the hard part. And you had a question on corporates. See, when corporates work with academicians, they also do pairwise projects, right? A company comes and works with one institution on one project or a set of projects. So it's a very commercial model, so there's nothing social in that. The companies want the IP, or they want the goodwill to hire people, right? They come for, they're mostly, the few companies that do it more social, like Intel does a lot of work in India around research where they don't take IT. And they invest a lot of time and effort. But few companies do it, most don't, which is okay. I think at the end of the academic institution, a company comes and funds a project, we value it very, very highly at Society because it's a real world problem with real world data, right? Real world perspective, real world domain knowledge coming in with funding. So we value it. We may or may not get research publication out of it, but it's a check for the reality check for the work we're doing, get a reality perspective to the work we're doing, and of course get funding that funds other research work that this professor does. So we're okay with that, but I don't think that's going to, see, corporates supporting open source has always been motivated. It's a proxy market war that they fight. So that's not a good thing, generally.
That is why we push open source is the future of AI.
No, AI itself, OpenAI came that way. Like you look at it, it is open source or is it open source? It's not,
No,
right?
not open
So, which is okay. I think you should be realistic about it. Open source, first off, open source is not free, right? Something can be open source and still for commercial use you need to pay. The very standard model, which is okay. Knowledge is open, but the commercial use is not open. Free is a different thing, right? Free and open source is a different form. That's not very common. And when a corporate supports open source, there is motivation, and that motivation is generally not good.
We understand that. So let's switch gears here, and then we see that okay, there is a lot of push for AI from the corporates, all the industry leaders, and everyone is pushing, saying that they are adopting AI within their organizations, and then they are saying we are enabling AI for their betterment of within the organizations. But with that comes a small insecurity for the developers that will their existing skills be obsolete, right? And how are enterprises going to cope up and educate and enlighten and upskill your resources? So I would like Nagarjuna to take a stab at this.
Yeah. Again, once again, a very good morning to everybody, all full of students, industry experts, and academia experts. A very, I would say, stimulating atmosphere. And thanks for the other panelists, which kind of set the platform. All the difficult questions are ours to frank with you. And as a connection to what Professor Ramesh had mentioned, and this question is positioned well. And again, I'm from Tech Mahindra, and to me, honestly, he started saying, I'm a practitioner of open source as well. As soon as I think that in 1998, if I'm not wrong, Netscape's code was available outside, and it was complained to me, it was a complaint from me till such time saying that the IBMs of the world, Microsofts of the world are spoiling us in terms of, they give a lot of things to you. If you piggyback on that, you don't learn, the creativity is going for a task there. So I was always complaining on that. So as a practitioner in the industry for the past 27 years in Tech Mahindra, we took the complete advantage of open source. Fortunately, Dr. Ramesh's comment on the corporates, if you look at the latest example, what we have done from our company's side, if you watched our press notes in the past 2 to 3 years, 2.5 years back, we kind of announced a AI platform for our customers and customers. And he's absolutely right. Unless it is commercialized, we are in the business of making profits. And my intention is to, as a business leader, my intention is to make it faster, better, cheaper, steadier, and larger. So these are like our parameters where my margin counts. So in line with it, what we have done is we kind of launched a platform called Gaia, G-A-I-A. It's like our AI platform. And interesting thing is it's all open source. We kind of partnered with Acumas, which is again an open source partner, and backed by Linux Foundation itself. The way Linux Foundation, I like them because personally, for example, if you look at the way blockchain is evolving, the way the support they are giving, like the way I think we answered in terms of consortiums, right? They back it up. So as a company, what we have done is we took the advantage of the open source, built a platform, and a reason why Ramesh's point on corporates will not really promote a lot on open source is in terms of the security, information security, right? For example, you are adapting somebody else's code. Many of the customers, especially pharma life sciences customers, where you have regulatory authorities and all, they don't appreciate it. Or even product making companies for that matter. I think Professor Jaideep was mentioning about Google, and we support them as well. But if you look at the confidentiality they maintain in terms of source code, it's appreciable. It has to be a combination. It can't everything be open source, everything be proprietary or enterprise driven. So we respect our customers' objectives. In somewhere we are getting opportunities to convince our customers saying how this joint collaboration is making sense for a commercial use. Again, going back to faster, cheaper, better, steadier and larger. We are achieving their commercial purposes. At the same time, we are giving a solution in faster time with better results, more productivity. That is working out. And this is happening for a while. I still remember, some of these facts are, you can Google search it. Apache, if I'm not wrong, it is most used web server, right? About 60 to 70% adoption. And if you look at projects also, most of the IT projects, if you look at the statistics, 66% are abandoned projects. 66 to 70% are abandoned. What do you do with that code? Give it to public, right? So they will take it forward and then finish it off. And coming back to the skill angle, thanks to a lot of the open source movement happening for a while, forget about the people who are working in Tech Mahindra, all the students who are sitting here. Thanks to that open source movement, we call it as MOOC, right? Massive Open Online Courses. Even Stanford courses are available to you. Pick it up. Like the concept, knowledge was available. Dr. Ramesh was mentioning about it. Knowledge was available. A real problem with AI, professor's session, Dr. Jaydeep's session in the morning, if I tell to the students that among the 8 to 9 slides he presented, 80% is coded, they get the motivation, right? If, for example, if I have to code all those, algorithm matrices and all that, they feel it's very complex and difficult. No, it's not. 80% is coded. We pick it up from there and take it forward. That's what MOOC is telling. From a student community, who are our future units? Basically, they also should learn about it in our individual dignity that they can get to the table, right? If I think in a productive way, how to utilize open source right from their college days, using MOOCs, practicing, understanding all open source platform, coming to a company like us, end of the day, you may be basically owning an idea to build a product which India would like to get in. So services versus product, right? Your revenues will be non-linear. So that's what, in my opinion, it's positioned well. AI, the problems are around data and compute. I think we touched base upon it, and Amit also spoke about it from Salesforce angle, and we also spoke from Amazon angle. Data is proprietary, data and compute. If we solve the problem in terms of crowdsourcing on an open source way, I think we are positioned well for this wave also. It is not new to India, right? We've been solving these issues for a while. In my opinion, open AI, collectively, I'm sure we will definitely make it happen, in my opinion.
Thank you, Nagarjun. Yes, please.
So I think if you look at it, like say all the academic knowledge by and large is published, right? One level of open knowledge. So even academic knowledge, like if somebody were to license, they have to, we have licensing terms and such. The paper may be public, but IP may still be owned. Open source, what is out there, like any of the open source projects, it's like public knowledge, right? Like you said, it's available, a group of people for whatever reasons went and created, and you could use it, leverage it the way you want to leverage. And then commercially using it is the next level, right? Even if it is an open source, sometimes it comes with license terms. So it's okay. Everybody has their own motivation to do, some want to build the same thing commercially, some want to build just for fun, build it as an open source. But once the knowledge is available, it's up to anybody like Nag rightly said, for a project, they will choose what's available out there, right? It could be a paper that they take and build, it could be an existing framework that they use, it could be a commercial product. At the end of the day, they have something that they need to build. Now, where a platform like this can help, right, very significantly help is the social problems. Social problems, like if we're trying to create low resource languages, the work that all these Swecha started, it's going to be very hard for any commercially driven initiatives to fund it, because there are not enough commercial returns. But the social returns are huge. I think those are places where probably open source is the only way, community-led open source is the only way to do it, which may result in IP that could be commercialized maybe, once it is done. But the initial funding, nobody's going to come and pump money like OpenAI got to build for low resource languages, which most Indian languages are low resource, digital low resource languages. And the others like public health or any of those areas, agri, you've been talking about agri, Swecha has been talking about. Those are areas where commercial forces will not come and fund because it's very hard to figure out a model. So I think open source community-led is a place where those are places where it's absolutely necessary. Because nothing else will come, and governments find it very hard. They're trying to do many things, but they're finding it very hard. The results that Swecha has already got in the last few months, I think it's a strong indicator. I think keep that momentum on. We will solve for the nation what Bashini is finding it very hard. As a community, it can be solved.
Yes, Ranga. Actually, you have answered my next question. How can we push for start AI adoption? That's my next question. So Rangnath, please, if you can also
Sure. Yeah.
share
So
your view.
I think I'll start with the answer and then I extend it here because both are very well connected. First thing is like let us take the point of industrial revolution, right? Like when it happened, I think one of the things, just think, right? Like when machines all came, people are like actually drilling railway lanes, right? And then suddenly machines came and everyone was scared like, okay, my job is gone. Then suddenly all these machines came and they bigger tunnels and then like suddenly a lot of hardware came up, infrastructure came up. The world became a lot better place, right? And that time there was like a lot of scariness around all these things like happening. The second thing is like there's like simple example, right? There is this 1984 the great manure thing where like the phosphate used to put a lot of manure on the New York streets and then they used to put a lot of remove all of them and when cars came in it removed and then the whole problem was over. So like always the betterment happened. I think from an industry perspective, as a student or like people who are thinking like, okay, what will happen to this, right? Like first thing, when people approach us with a problem statement saying that, hey, we want to build this, the approach is similar to what we are doing with, like again, the progression on AI. It's same as like when IoT came in, a lot of devices came in. Then being contextual to this open source, no like industrial projects are based out of like Raspberry Pis or Arduinos or like equivalent open source hardware systems. But what was very good was all these things helped in prototyping things that helped build things on that stage. Like the smartwatch that you are wearing is far, far more advanced, but it was built on one of these open source wearables. Eventually they just commercialized it and made it a lot more powerful and then like adopted to it. But for prototyping it, this open source thing made it a lot more possible. So all the things that you're doing like checks on like your health, on everything on the smartwatch, is just happening because of that open source thing that happened on like the IoT stuff. But right now, if you take on like the growth of AI, we are taking the same path, like somebody just made it open source. Again, it's like this open source thing in AI is a bit arguable because like what are these open sourcing? Are they open sourcing the model? Are they open sourcing the data on which they trained it? Or like both of them together? Nobody's doing all of them together. So there is some commercial angle, but still like if it is used in a particular way, the adoption of this will be like having these machines together, we are doing a journey together. But also like at some point, till now, like human intelligence has been like a lot more advanced than like machine intelligence. So it's very rare like where they were like in specific tasks they were doing it, which we call like a narrow based task or narrow intelligence. But on like general intelligence, people are like always like right now are afraid that it will overtake us and what will happen after that. Like so there is like recursive relearning and those kind of things which scares us, but still the evolution happens. Nobody's going to stop the red button. As I said, like once we come back to governance, there are like points in which we need to discuss, which will make that happen in a, like a better way.
That is fantastic. So Amit, if you can, I would like to understand what are the open source contributions from your perspective from like Salesforce or like whatever your companies are doing for open source contributions. I would like to, for our audience to know more about, details more about that.
This is in, in companies interest open source a lot of this stuff because they get a market traction, they get the community with support and the innovation, what it does upon innovation happens very fast the moment you open source. For example, I know that Salesforce open source Flip, this is for image to text, the text to image, and then there's XGen, which is LLM model. So, and then you see examples, this is not limited to Salesforce, Meta has Llama 2 also, and now this week I think Elon Musk announced that Grok also will be open source. So what's happening that you are getting a lot of these models which is telling you how to do that. And the great news for the audience here is that you figure where to use that, what problem I should solve with that. I think that's an opportunity, and that way you'll get the skill, and then you'll get a use case.
Yes, please. So, I think from AWS, I think we've been one of the most open and when it comes to open source, nurturing of the whole open source ecosystem and also embracing open source technologies. If you even take technologies from relational databases or whatnot, what we have done is we have taken the simplicity of open source and added our expertise in managing the infrastructure. If you look at some of our offerings, greatly embraces open source, like for example take Postgres, MySQL and whatnot. We took all those open source technology and put like our expertise on top of it to give a highly scalable and also kind of affordable infrastructure for anyone to innovate on top of it. Now, that's from the compute and general perspective. Now, I'll talk two perspectives on our contributions. Now, when it comes to Amazon or AWS, we've been actively contributing to projects like Babelfish. Even if you look at AML like MXNet and whatnot, we've been actively contributing. So much so, like even the father of Java, who is James Gosling, is actually part of Amazon, AWS, and who is working on projects like Greengrass, which is into IoT space and everything. So we've been developing several, for example, free real-time operating system when it comes to IoT world, and Babelfish for like database world, and MXNet and Kubernetes and whatnot, right? We've been actively contributing. Now, when it comes to the execution or use of such tools and techniques, right? So in AI, when it comes to that, so we have an initiative called Registry of Open Data on AWS, which is called RODA. Now, in RODA, you can actually, we host a lot of open source data, For example, UK Biobank some time ago released 100,000 whole genome sequencing data. And we are the hosting partners. Like, we took the whole data and we hosted on us and then hosted on the RODA platform and then shared it. Likewise, if you go to RODA, there are like number of data sets that are available for anyone to freely use and build any model on top of it. Now, when it comes to the AI models, and again, we've been building hubs. Like, for example, we have something called SageMaker Jumpstart, which basically provides a platform to host all these pre-trained models that you could see in Hugging Face. Like, for example, like Amit mentioned, Llama models, and several other pre-trained models are available, which you can actually easily deploy and train. Now, what it means for you as a student or perhaps from the community is, take all those pre-created data set or pre-trained model and start. You don't have to start from scratch. You can easily build on top of AWS. In fact, we also give credits for some of these use cases. And one such initiative I can tell from healthcare perspective is AWS Health Initiative, where we give funds to some of our customers who does solve the equitable problem and whatnot. Like, there are many funds that we have set aside. Even recently we announced something for Generative AI. Like, we set aside $100 million fund to support our customers and partners and everyone to innovate on AI space. So yeah.
That was really educational. I would like to close this session with one last question. The main motto, or like what the initiative of this event is, to see if we can make Hyderabad the capital of AI. I would like to take each one of your inputs and see how we can make, or what are the potential challenges, what is the road for Hyderabad to be AI capital.
I can start probably. Yeah. So I think I was from Hyderabad. I'm from JNTU, like, so a lot of things. I'm from Hyderabad, so a lot of things together with Hyderabad. But having said that, I think one city becoming a capital of like the whole AI thing is going to be like a crazy power, like superpower, like to somebody. But what I think I can suggest is like governments relatively, like again, like as I said, like somebody took an AI act from Germany or Europe or other places is good. But like from India, we can become like pioneers, like in starting the governance model and then acting on it. I think nobody, as far as I know, has like a serious model there, where like Hyderabad comes and says, you know what, like we are forming this consortium, and then this is going to be like the first one of like the first version of the draft, and that will put like spot in the map in India, like far ahead of other cities. Yeah.
I think there have been many attempts in the last 6-7 years, right, to put Hyderabad on the national AI map, and it's okay, some success has happened, but I think what can really, we need to think much bigger. It's not an incremental. I think the initiative that's being taken up now through the Swecha efforts, right, to create a very large platform. When it's a platform, talking about its most broadest form, which is people, processes, systems, right, volunteers, energy, the battle cry. There's a battle cry here, right? I mean, like if you could get the Telugu ASR created, right? And I think there's an opportunity to see, like yesterday, 2,000 people in the room, right? Yesterday, all day, and more than 1,000 people here today, second day. I think if we rally around this and amplify what Swecha has already started, right? And say like, we create, and they're all social problems, by the way, right? We talk about agri or morning varieties of problems in public health. These are all social problems where this is the only way to do it almost. Either government should do it or community should do it. And government has its own priorities, like, so they'll pick what is the most important thing at that point. And so community can do this. And I feel if we amplify this, like say what the success that's been got in the last 6 months with the Telugu language, like I think, I forget if it was Kiran or right, Praveen that was saying, Hugging Face for India, right? Create like models that's built by community, lot of models available, right? Whether it could be used for social purposes, it could be used for commercial purposes, right? But the models get created, for which the data has to get compiled first, right? And labeled and data sets. I feel we should take this up in a mission mode, rally all forces, right? Whatever support from companies available, get other communities, academic institutions, significantly amplify and accelerate. And if we can get, like the many initiatives, like there is the AI for Bharat, there is Bharat GPT, many initiatives, I don't believe they're going as fast as, like given the forces behind it, the people, the thinking, and the funds, it's going nowhere nearly as fast as they could. So this could be an opportunity to show that it's possible as a community to do it. I feel that's going to put us on the national map, nothing else. That will put us on the national map.
I thought he would take, but somehow Ramesh's points are very resonating to what I'm thinking actually. The sense of urgency is even, I feel that actually. It is not as if we are getting ready as Hyderabad Inc. for a .com or a .net or a SAP boom or something like that. If you look at the slide back, there are only two, Anurag University and Meta. Why? Why? That is the issue actually. For example, when we show to other customers, we show a slide full of customers who are our partners who enabled our growth, right? As even they do it, Amazon or a Salesforce. But that is only two right now. And it is being driven by Swecha. It's like we talked about it, shared purpose and shared vision. That's what he used a few minutes back. Honestly speaking, the industry is right, $150 billion market. It is going to grow something like 1.8 trillion with a 36.4% CAGR. How much of it you take is up to you as Hyderabad. Right now, in my opinion, he is absolutely right. Sense of urgency is not there. Why am I telling? As Hyderabad, we can do. If you look at the COVID situation, earlier it was like a 5 to 6 years to invent a molecule and a vaccine. March 23rd is the date in 2020, lockdown is announced. January, we have a vaccine in hand. That means as a team we can do it. As a team we can do it, but we are not doing it is a problem, in my opinion. But really greatly appreciate the kind of efforts the Swecha kind of organizations are doing for ganging everybody together. It is not anymore a luxury or a nice thing. It's a must-to-have thing going forward. In my opinion, the educational institution should come for the supply side. At the end of the day, if I do AI or a machine learning or a federated AI, supplies from universities, supplies from colleges, and there is a variation. In my opinion, the universities have a shared problem right now. I think somewhere, one of you mentioned it about it, right? The compute angle. You had a great model. How do you deploy? How many institutions in Hyderabad today are positioned to really deploy a machine learning model? And at the same time, we are positioned. For example, Mahindra University, for example, IIIT. And why are we not collaborating? And why are we not forming a consortium with a shared vision of making Hyderabad as a jewel in AI? That's what needs to be done in my opinion. And now you are telling all this. I've been telling this for so many folks in so many forums, but some action is what I'm expecting. He kind of hit the nail on its head actually. Sense of urgency is the most important thing. Trust me, market will make the money. Amazons of the world, Googles of the world, Salesforce of the world, Tech Mahindras of the world will make money for sure. That $1.8 trillion money will be made. Is it Hyderabad? Is it Chennai? Is it Bangalore? Is it Pune? Is it Mumbai? Is it Noida? Is a question. It is our share to get it back. And count on my support on anything that we do in Hyderabad actually. That's what I reflect. Thanks for the platform you already said.
So just to condense your thoughts, right? I mean, I agree to all the points, and what I believe is three P's. I think one is purpose, and then partnerships, and finally policies in that order. I think what made Swecha and other initiatives possible was purpose. I think there was a clear-cut definition of what anyone wanted to achieve. I think, let's say, to go back to your question on Hyderabad, I think Hyderabad should have that purpose or a vision narrated, following which we should have partnerships. This is where all these universities and private, public firms can actually come together and work towards that greater good. And like he really quoted a very good anecdote about COVID success, right? I mean, it is possible. And finally, policy. Trust me, I think policy sometimes is an enabler, sometimes is a blocker, but truly, in my opinion, I think the right policies at the right time will enable the whole ecosystem. So I would say
you solve these three, I'm sure we can realize that potential of being placed.
These gentlemen, they cover almost everything. I'll just talk about two concrete things. One is specifically collectively lean on professors to share this knowledge. And we have this untapped pool of people who have done that hands-on. So connecting the students with the mentors in industry, I think that will go a long way in solving this problem. And secondly, creating one great example. Think of it, Abu Dhabi came with Falcon, it's 180 billion parameters AI model. Why can't India do that, or why can't Hyderabad do that? So set one shining example of something like that and then connect these two ends. That's probably.
Thank you very much, panel. We have really good insights from all of you. So we'll give a big applaud for the entire panel for sharing your thoughts, sharing your resources. And I would hope the audience here will take great inputs from this. The policymakers, the startup owners, the educational institutes, everyone will make a big push for having a greater open source AI initiative here at Hyderabad. It can be a model, it can be a inspiration story for the rest of the world to pick it up from here. Thank you all.
No, thanks to Kaushik for asking soft and nice questions. I thought he would ask a question to us saying, can you code for one of the slides, Professor Jayadep? Thanks for being so nice. Again, a great moderation. Thank you so much.
Over to you, Praveen.
Thank you, everyone. I think the key takeaway for me is the purpose. And I think we're all driven by the purpose of here. Thank you for taking your time out. All the panelists, moderator Kaushik, another Kaushik, Ranga, Ramesh. Thank you, everyone. Thank you so much. Again. People, updated schedule has been sent over a WhatsApp message to all of you. If it hasn't reached you, please, take a screenshot, take a photo or something. But this is the schedule right now. We are running 20 minutes behind schedule. So without, further breaks, we'll go to the next one. We're almost ready for that. There are talks starting right now. There are talks starting in the JN Seminar Hall, which is in the first floor. There are some talks that are starting in the Golden Jubilee Hall of the EC department, and a panel session which is starting in the event center of J-Hub. But here, we have a very distinguished person, a very renowned person, Dr. Pratik Desai. Pratik Desai is the founder and the CEO of Kisan.ai, the seasoned entrepreneur and computer scientist.
Can I add my slides?
Again, sorry for that. And he's a computer scientist, founder CEO of Kisan.ai, and it's quite late in the night for him, and he has kindly agreed to stay up for us, and we have requested him for a brief talk. Over to Dr. Pratik Desai.
Okay, awesome. Thank you, everyone. I'm Pratik Desai, founder and CEO of Kisan AI. I hope you guys can hear me. Just let me know if I'm audible, so I can continue the presentation. Naveen, can you confirm? Okay, and you can see my slides. Okay, perfect. Oh, okay, perfect. So, Thank you, Swecha, and the team for inviting me for the presentation. I hope you guys are having a good time. And the topic for me today is about using AI in the Indian agriculture ecosystem and how we have been working to bring AI, the latest technology, in hands of the farmer. Uh, and our goal is to divide this knowledge gap that has been kind of widely the reason behind how the agriculture in India is kind of traditionally the one of the, the backward in terms of digitization. Uh, so just start with my own journey. So I grew up in agrarian family. Generations I remember we were in agriculture, and I grew up on farm, helped my father, and knew the first hand all the problems that farmer faces, and very much aware of what's going on. But then I moved to US for my master's. My father took one of the biggest risks in his life, taking a loan to send me to US, and then I've been working in doing my higher education. I work on solving sensors, robotics, and then move to the AI/ML to solve the knowledge extraction problem. And after that, I moved to Silicon Valley, and in Valley, I have been part of multiple startups, the founder or founding member, and we did develop some amazing technology. Like, so one of the problems that we tried to solve was using real-time analytics on social media. Then we also worked on building wearables. This was pre-Apple Watch, and our objective was bringing intelligence inside the wearable devices. And the last startup was in automotive. Again, my role was to build the AI-based intelligence system for the cars, just like how Tesla has over their updates and data analytics. We built something for the regular cars. The company got acquired, and at the same time, I realized that it's time for me to start working for to my roots, like the people I'm associated with. And there was a time in 2019 I decided to start a company called Titori in India, and the objective was to build AIML application, high-tech tools that goes directly inside the hand of farmers, so farmer can access the technology and take benefits of what's going on. And our journey has been more than exciting from the day we started. But we also had many great learnings from where we started and where we are right now. So, uh, when we started, the objective was the first objective, the first problem we tried to solve was the plots, the farmland plots are not geolocated or digitized. So the only way farmer can find out where the boundaries are, he goes to like collector's office or some regional office, government a worker will give them like a printout. It will have plots, and it will say, okay, this printout, this is your plot. It was not digitized. So we started with working on digitizing plot for the Gujarat state, and using machine learning, computer vision, satellite images, we did plot 1.2 crore farmlands. And then we are running a startup, so it's always important to find also product market fit and understand your demographics. So even though we built some advanced high tech tool, the farmer had really not everyday use for it, and we also understand like the position of our farmer. So that was our first learning, that if you build something high tech, but if your if farmers cannot pay, you cannot continue like running a startup. So we started learning, even though we were building something in terms of advanced technology, we had to bring farmer on board. So we created this digital marketplace where our goal was to help farmer create their online shops and give them mandi prices, price prediction, and let them sell directly to consumers. And through that, our goal and objective was to start giving them the advanced technology that's possible. Now, this is the time we also started collecting a lot of agriculture data around different commodities, the markets, and something that's going to be helpful to us in the future. Uh, Next thing we worked on is helping farmer to create automated label and packaging. Now, like why? Like to understand the problem. If today a farmer wants to sell something online or Facebook Marketplace or somewhere else, they do not have access to graphic designers or like some advanced labeling mechanism. So they will end up printing something on like paper with the name, and this is not something that's going to stand out in front of consumers. Now, uh, how can we solve it? Like farmers cannot afford to hire a graphic designer. So this is the similar time the stable diffusion image generation model dropped in. This was August, and within a month we generated more than 50,000 images with different prompts, and created a tool where farmers just select turmeric, like or any commodity name, their name, price, and we'll generate like a really nice looking labels for them. They can print it out, and this is something very helpful because like these are the small tools that end up helping farmers to the day-to-day life. Now, our learning from this one was that even though we are helping them out, there is still something that missing. That is, these tools are created by tech folks for tech people, not for the farmers, because they require education. You need to explain them how to use it. Which, in sense, it's not very simple. There's like a literacy and language gap, and it need to be very intuitive. So next as we did, we use again a diffusion model with ink painting and background removal application, and created something where farmer can take a picture of whatever they're trying to sell, automatically replace the background, and create like a something very professional looking. And when we did this one, we tried to create application which started becoming very simple. So they take a picture, select what they want to do, and they will create a picture. And this create like the professional looking image, then they can start sharing in the WhatsApp group or wherever they're trying to sell. So through all out, what we learned from our experimentation with building AI applications, that the farmers has a really huge literacy and language barrier. Like, and for India, where we have so many languages, and most of the farming and agriculture happening in the rural area, this is very prevalent. Also, the education cost is very high. Like explaining farmer, because their day-to-day life, they are doing their like job. Their job is not to remember all the filters and tools and settings in the app. Now this time we also realized that like this trained farmers are using WhatsApp and Instagram and everything very well. Like nobody went to teach them, but they still started using it, and like they're sending millions of messages on WhatsApp every day. So I think it was like a realization was that it's a problem in the people who are creating things for farmers. It's not the farmer themselves, because everything we see today around built for farmers are not very farmer friendly in a sense. And the existing mechanism for them to access the knowledge, for example, we're not expecting farmer to go on Google and read 20 blogs, right, in English. There are many institutes in India and around, like, like different region, who generate a lot of knowledge. This knowledge kind of stays to the institute. We are not expecting farmer again to travel 150 kilometers to find out and read these booklets and to figure out what is the best way to, what is the like a latest method to grow rice, or what is the latest variety. And so what farmer end up relying to is the local expert. They are not expert, but like local vendors who are trying to sell something, which kind of put them in this situation where they are subjected to exploitation. Those advices are biased. Meanwhile, we do have a lot of knowledge and research, everything generated to be served to farmer. So we saw this big knowledge gap from the knowledge that they produce to the person like farmer who's supposed to consume it. And we also saw that's like a two-way accessibility problem. It's not just the farmers. The knowledge that can produce is also unstructured. It's not designed to be digested by automated tools. It's very fragmented, and the for the knowledge generation to the acquisition cost of farmer to reach to the farmer is also very high. And not just the farmer, people like extension workers or supports or sales, whoever is trying to kind of bring this knowledge to the ground, is the whole system is broken. So this was the chance where we already had a lot of knowledge that we have collected from different sources which we are using to on our platform. So we saw the opportunity that we can use this knowledge, use the ever like the generative AI technologies and the models are getting cheaper every day. So we realized that like if we can build something that can bridge this knowledge gap between farmer and the knowledge that producing organization, we can solve one of the biggest problem. because now farmers can reach out and get access to all type of knowledge from the seeds to the equipments, the fertilizers, pesticides, finance and loan. Meanwhile, they can just talk in their own language and something very simple into the interface. So this is what Kisan AI is. When we launched Kisan AI last March, and our objective was to create something very simple, intuitive, just a one button, select your language, and then you can start talking in your own language. And we were building knowledge base. We are even today we are like continuously adding and getting more information. The goal is to all the data, knowledge, diversify information from practices to like climate resilient agriculture to organic farming. We would like to deliver them in a way where they can talk to the AI through the voice. And this is what the Kisan AI we launched last March. And surprisingly, because we were always focused on AI, but when we launched, we found out that we were not just uh, uh, like not just agriculture. We were like one of the first vernacular voice-based assistant built using generative AI, and which was supporting many languages. Because if you remember, the OpenAI and Bard and all started having this voice-based conversation very recently. But like we did it in March, we received a really great response because very first time farmer realized that they have the power of the entire internet in their hands and they do not have to read. They can just talk to it and it will reply. They can go back and forth. They can ask like multiple questions. It's not like a call center. They have to wait for 5 hours and then you don't know the person on the other side. It's like the knowledgeable person, like what's trying, like, and it will not take them like 15 minutes, 30 minutes to find out the right answer. The answer is there. We started seeing getting requests at the middle of the night where someone is just like in India and farms the power come at the night time. So most of the times farmers are actually watering their farm at the night time. So we started seeing it at the night time. People are calling and asking questions about that thing. So we realized that we have like built something which is really valuable, and by expanding the knowledge that we have, we can actually solve many problems related to agriculture and rural economy. But we are focused on agriculture. There are many other problems and many other organizations trying to solve this thing, but we want to solve the agri problem. Now, there were many other things that we realized that like the Gen AI is still expensive. So if we keep running the show and keep serving more and more farmers, like we have already reached 110K farmers without any marketing. It's still like spreading. People who find out, use it. People they come back with the feedback, say like, hey, there's this thing missing. Can you add equipment data? Can you add finance data? So we ourselves are keep expanding the knowledge that we have, but we also realize that like using the latest models, which are really huge in size, and if we go and try to serve millions of farmers, then it end up becoming expensive. And because we haven't even figured out the business model, like remember, like we have to at one day being a startup have to generate revenue, so we cannot keep running it. So we started actually doing research on the language model side, like if we can reduce the size of the model from using open source like a model, something like a Llama 2, we can actually reduce the cost of inference. And similarly, we also realized that one of the biggest asks from the farmer was detecting disease and pests. So we started ourselves working on training, like fine tuning models, so we can actually reduce the cost of inference while keep serving the more demographic and try to bridge this knowledge gap. While we launched, we really got like really huge response, not just farmer, but everyone around, like many media houses kind of checked it out, they published about it, and I think that also helped us to kind of reach to more folks. And we also started seeing many success stories, like for example, one farmer from Chhattisgarh, um, he was growing geranium, which is like mostly get used by perfume companies, and then there's a lot of agri waste. And the farmer has to sometimes pay for to get rid of this agri waste. So this Lokesh, he was interested. He was like curious about what he can do. So he started asking questions and figuring out what he can do with the agri waste. Then he found out like there are some chemical composition he can use, and using that he actually created air freshener, and then like he registered his company, he became agripreneur. Now he's incubated, and so moral of the story is like, now with the AI, so many things like this research of how to use agri waste into air perfume was there always, but it was not accessible to farmer. And there are many stories that can be created, like we are collecting, but it looks like, with this AI and how progressive farmers who are always looking to find a new way of like using better practices, building something from agri waste, or like improving or increasing the yield, better way of using pesticides. They all have now answers. They can go and like have conversation with AI to find it out. And now this time we also realize that while we are building it for farmers, there are like thousands of agribusinesses who directly serve farmers, and they also have the same problem. They have their proprietary knowledge. That knowledge also needs to be served. Like all the equipment companies, tractor companies, pesticide companies, India or around the world, who have proprietary knowledge about their product, and they also struggle to take this knowledge back to the farmer, because farmer, let's say for example, someone is growing cotton and interested in finding out like what is the product from company XYZ that you can use for whitefly, if that's one of the common pests, then he will not have, like, he will go to the nearest shopkeeper and ask, and he will sell whatever is best he knows, or what is available in the stock. But now that same farmer can actually talk to the that company's chatbot, and then the company will suggest like this is the latest product that you can use for whitefly and cotton. This is available in your area, and that is what we are building as like a startup, an agri-co-pilot platform, which helps every businesses to take their advisories, manual, how to use this product, how to use a tractor or the new connectors or like extension product, and serving them through different type of channels and APIs. And uh, that, uh, you know, and like this is about like the model that we are building. Like when we started working on the model, we also we were not like a racing to release and create a model. We knew the problem. Our problem was always to create cheaper inference with the more knowledge base. So we were already collecting huge amount of data. We had 400,000 different conversations that farmers can dig through our platform. We knew what kind of question they ask. So we did curation on top of it, and using the and fine-tuning sun-million parameter model. This model was created on Llama 2, Open Hathi, which is based on Llama 2, and we name it Denu because Denu as a calm Denu, kind of symbol for agriculture, at least in Indian subcontinent. And also, if you look at the naming conversation happening with the models like Llama or Dolphin, we also realize like Denu would suit in that category of naming models from the animal's name. And then we last month also trained a vision model. The objective for the model is to not just detect pests and diseases for most commonly done crops, but also start having conversations. So a farmer can take a picture and then they can ask about what's going on, what's wrong with it, what can I use. So this is like very early stage for the vision model, and our goal is to kind of cover all major crops and the diseases, so we can create like a cheaper version that can be used by every farmers, because the current APIs with CNN models are very expensive, and we want to create something that is simple to use, just like our Kisan AI app, and then add multimodal capability to that, and always stay on and focus on the agriculture, because like we cannot there are many things that people can try, and which is like the purpose for the general purpose model, maybe like the AGI, but our goal is to solve the agriculture related problems, because that's very near to my heart, and what we have been working for a long time. So when we released, we also realized that not just we were first to release the co-pilot, vernacular co-pilot, we were also like one of the pioneer in building agricultural LLMs. So I'll just play this one in terms of like how the Dhenu model, which is a bilingual, because we train on Open Hathi, which is a bilingual Hindi and English, and you can see like the knowledge that we have trained on is basically very specific to location for like India practices. So if you can ask and select the state, and it will provide you practices or like advisory based on the location, not just very general purpose answer. And still like right now the first version we trained had like a 300,000 instruction because it's instruction train model. But next one we are like collecting around million different instruction. So it's going to be like a really huge data set, and I hope that like when we have the latest version, we'll able to actually make it much more better in terms of the knowledge that it can like embed. Because the fine tuning method, there are two things that you can do. Either you can try to embed some knowledge, and you can also embed the style, and the style would be like what kind of question that usually originate from farmers and how you actually reply to them. This is the small clip I would like to play for the vision model. So the vision model, like you can see, select like the farmer can take a picture, select an image. Now the earlier models which were based on CNN, they will just kind of take a picture and tell you what percentage they think this particular disease is, right? So that is anyway basically will be kind of identified by the model. But then the other additional thing that a farmer can do, like right now this is in English, but like when we actually kind of implement on production, we will be able to do this thing in all other languages that we support. But they can start just having conversation about what's going on, if is there a disease present, what kind of, can you name it, how to take care of it, and all those kind of questions they can ask. So basically you are having a conversation as an like expert, and not just detecting a thing and then relying on reading again. Like like today in traditional method, you detect a disease and you take the name, go to the shopkeeper or ask someone or call center, and then they will tell you something, right? Now you are over here just in the chatbot, you are actually having this conversation. So uh, our goal is to kind of, right now we train the vision model for just 3 crop with 10,000 images, but we will be expanding this to more than like 80,000 images, 80 crops, and see if we can actually create something which is very remarkable and solve problem on the ground. I'll be quick in terms of summarizing the presentation, so maybe you can take some questions. So ultimately, if you look at it, what we try to be, we want to be like the knowledge superhighway. So there has been always like the gap between the information advisory get produced by institute and experts and between the farmers on the ground. And we want to be that the conduit to deliver this knowledge. And at one point on like longer roadmap, we also want to be someone who trained the base agriculture model and the base platform, and create some an unbiased platform that can be like the farmer's companion for everything they want to do like every day, like the single app farmer when he wakes up he want to rely on, and that's what we actually want to be. And That'll be all from my side. Thank you. And if love to see if there's any question. Okay, that'll be fine. Yes. Okay, thank you.
Check, check. Volume please. Offline lo తీసుకుంటాను. So I think of course we are running late of time, but still I'll call up quickly Dr. Paparao garu.
He's a general physician at Citizen Hospital. Dr. Paparao Garu, a distinguished physician based in India, who has over 30 years of experience specializing in thyroid disorders, lung diseases, and chronic conditions like hypertension, diabetes, and obesity. Serving as a senior consultant in internal medicine at Citizens Specialty Hospital in Hyderabad, he is skilled in critical care procedures such as intubation, temporary pacemaker insertion, central venous catheter placement, and ventilator management. We welcome you, sir.
Thank you very much. I thank the organizers at the outset. Unlike earlier talks, my talk is going to be a very grandmother story. So I try to be on time, but stories could take some time. Our journey started like this long ago. There's some problem with that. Yeah. So we believe on what's called evidence-based. Now we practice on the existing data from the various cohort studies and randomized control trials, and the meta-analysis of randomized control trials is presumed to be the highest order of evidence. So now we practice more of evidence-based medicine. So artificial intelligence and precision medicine. Yeah, better. It's on and so it is a scientific discipline pertaining to the research studies, projects, applications that aim at supporting decision-based medical tasks through knowledge, data, intense computer-based solutions that ultimately support and improve the performance of human caregivers, care providers. So ultimately it should help the doctor to make a better decisions. This is how the timeline of artificial intelligence in health. So whatever that happened earlier, now it is discovery and development of new drugs, preclinical research, personalized healthcare, and many more. And the latest data processing is genomic sequencing database, AI in electronic health records, natural language, and the robotic assisted surgeries, and so on, as you see quite often. So there are many components of precision medicine: precision diagnosis, precision treatment, precision therapeutics, the drugs, precision prognosis, precision monitoring, as well as understanding the disease and precision prevention. So it needs actually what is called AI augmented systems. We are physicians, we don't do these systems, we just database scientists, data scientists do that. We just comprehend or correlate with them to get this design and development, evaluate and validate, diffuse and scale, monitor and maintain. That's how a AI system works. So currently AI is applied almost everywhere. You can see from wearables like bands, gadgets like Aura rings. So in nutrition, in disease diagnosis, in new development of new drugs and so on, imaging in particular. So precision medicine combines individual data on genes, biomarkers, physiological and behavioral data. Understand? This is important to understand this. Biomarkers, genes, behavioral data and physiological data. It makes a lot of data to understand to make a precision of a single individual. So if there is an excess gene, can be trisomy, an excess branch of gene that comes into causing a disease, should be able to cut it. Or you cut it here and attach there, that's how some of these goes. So it will be very precise, and precision is the key word. For example, I tell one drug. I think I am audible to all, right? So one drug that's called Zolgensma, which is the costliest medicine on the planet. That in Indian terms it costs around 18 crores, just one injection. There's a disease called SMA, spinal muscular atrophy, and caused by a lack of functional SMN1 gene. So you just give this particular injection intravenous, and this goes and makes it functional. The lack of function causes the disease, and SM1 gene, it makes it functional. It goes and precisely touches the particular gene which is dormant and makes it functional. That's how the art precision medicine works. And another example is statin. We all know hypercholesterol. What is high cholesterol? So when there is high cholesterol, doctors usually prescribe what is called statin. That's like atorvastatin, rosuvastatin, and simvastatin, etc. So there is a big trial in which they found a particular gene, sequence, which is there in about 5% of individuals on Earth. So this causes statin resistance. Statin doesn't work if you have such type of genetic pattern. So what you need to do, you need to take an alternative drug like PCSK9 inhibitor. So if you know the genetic pattern, you can precisely avoid the drug, you can precisely, prescribe the drug. So in diagnostics, it is used in diagnostics to increase the efficiency, and deep learning is helping in prevention of errors, diagnosis, improvement, and it helps detecting lung cancer, assessing risk of sudden cardiac death by, some of the AI models can detect 72-hour sudden cardiac death even before. So by the time he reaches emergency, if the possibility of sudden cardiac death is high, you know how to triage him, where to send him to the intensive care, and what are the measures to take. So classifying a skin lesion, there has been a model compared to a qualified dermatologist who gains knowledge over years and has to specialize and decades of experience. A AI model, what is called DCNN, deep learning, deep convolutional, neural networking. This is the AI system that can detect as good as 29 dermatologists who are experienced in learned and practicing. This is what AI can do in medical practice. So finding indicators of diabetic retinopathy, I think it is there in the domain for a very long time, and Google has taken it up. And in cardiology, AI uses prediction of cardiovascular disease and acute coronary syndromes or heart failure much better than a qualified and experienced cardiologist. If you just feed all the information of the chambers, thickness, and measurement of the heart, it can give you better prediction than any of the existing, electrocardiogram or ECG, echo, and so on put together. It can give a better opinion. So anyway, it is also in the precision of disease stratification. It works in many ways in cardiology. So it also works for heart failure. Prevention cardiology, for example, I tell a live example. My grandfather was a smoker. He died of heart attack at 52. And my father was a smoker. He had heart attack at 52. He stopped smoking. He was fine then. And looking at this, I did not smoke. Recently, I got my gene studies done, which is showing the cigarette smoking will greatly affect your cardiac health. That's why coronary artery disease. Since I avoided and I did not have a problem. This is a low example how AI can make preventive cardiology scores. And pulmonary medicine, there is a gray area what's called pulmonary function test. AI can augment this. And tumors also, potential improvement in early diagnosis of lung tumor. Lung tumors are some tumors before stage 3 is difficult to diagnose. When it is 10 millimeters or 8 millimeters, if you diagnose it's already stage 3, if you can make it when it is less than 1 millimeter, which AI can do. It also, it uses all these, your behavioral data as I told, like smoking, like genetic study, age, your, all the tissue data and multiple omics, all these put together, you can easily stratify and diagnose early as well as, you can make treatment plans. And in radiotherapy, this is one area that has greatly improved by AI. Radiotherapy is one, when I was a student, if there is a lung tumor, if radiotherapy was given whole lung, used to get fibrosed. Later came the linear, linear accelerators, which precisely bombards the tumor and also the normal lung tissue before the tumor and after the tumor gets affected. Now there is a recent AI model. This is picture has shattered. This is the latest ethos, which is AI-based machinery. Doesn't affect any normal tissue. It precisely recognizes the cancer cells and bombards the cancer cells. Similarly, other areas. So endocrinology, continuous blood glucose monitoring. If you can just put a patch anywhere in the body, it recognizes the blood sugar levels every 15 minutes for over 15 days so far. Still, people are trying to make it 1 month. Okay. If you can show to the patient, definitely patient is going to improve his, lifestyle changes and going to make benefits. And further endocrinology, it was for, there is this model I cannot understand, but there is what's called hidden layer, which, output prediction is the phenotypes, biomarkers, and overall survival it can assess, and so on. So in nephrology is one of the ever increasing disease process where increasing in diabetic rapid increase in the incidence of diabetes is increasing the kidney failures, renal diseases. So AI can, for instance, has proven useful in understanding the decline of glomerular filtration rate. Once diabetes is diagnosed to have diabetes, unless it is under control, microvascular disease like nephropathy, neuropathy, or retinopathy can be progressive. So this progression can be caused, can be understood, the decline of glomerular filtration rate by AI in many kidney diseases and establishing the risk of progressive disease in IgA nephropathy and diabetic related nephropathy. Similarly, it can also in kidney transplant patients can predict the graft rejection, how far the graft can survive and how far the new kidney can survive and function. And also you can optimize the immunosuppressive therapy, depends upon the risk of rejection of the kidney transplant. In gastroenterologists, again, at many places you can use it. In neurology, there is what is called AI model called Empatica. And this received an FDA approval in 2018. This also works by neuronal nerve network, etc. And this can predict possibility of generalized epilepsy much before the actual onset of seizures. So you can be alert, you can alert the, AI can alert the patient, alert the relatives as well as the physician to take measures before and prevent the seizures. So various stages. So retinopathy retinopathy, there is what is called RCNN algorithm. You can understand it better. You can predict the disease or retinal disease much earlier than an ophthalmologist who is a trained ophthalmologist through AI, through this AI system called RCNN. Yeah. So in emergency room, the popularity of robotic assisted surgery is, we all know that many advertisements on robotic surgeries, knee replacements and cardiac surgery, etc., on beating heart surgery, open heart surgery, minimally invasive surgeries, all these use AI as its, it directs how to go about, and robotic assisted surgery have led to fewer surgery related complications, less tissue destruction, precise understanding. And similarly, in the emergency department, you can try predicting likelihood of cardiac arrest in a case of sepsis, that is severe infection. It can predict the likelihood of cardiac arrest. So you know where to send the patient to an intensive care. You have to do all the required measurements. So drug discovery is another area that it used to take very long time. Recently we have seen in COVID. Usually it takes about 5 to 10 years to come to finalize a vaccine, but this time it just happened in 18 to 21 months, because mostly people they attribute it to the AI related assistance, where you can cut short most of the stages. Similarly, in a drug discovery, normally you have many models. You have to identify where the drug is required, and then you should keep searching for animal models, for preclinical, for human beings, for normal human beings, and then sick human beings, and then stage 1, stage 2, stage 3, stage 4 trials, and then comes out to the market. So it bypasses so many of these stages. So these are the various stages in drug discovery. Find the biomarkers and identify the target molecule, and then you can clinically precisely. So I'll tell you one example. There is what is called, an apple is famous for what is called an apple a day keeps the doctor away. When you eat an apple, what happens? It goes to the stomach and then to the duodenum. In the duodenum, the L cells of the duodenum secretes a peptide called gastrointestinal peptide. Because apple increases the blood sugar, it goes and stimulates the beta cells of the pancreas to produce insulin. Similarly, if the blood sugar levels is low, the same peptides will go and stimulates the alpha cells of the pancreas to raise the blood sugar level. And thus a balance happens. And in between, from the intestine to the pancreas, there is an enzyme called DPP4 enzyme. It is going to neutralize almost 90% of the peptides. So precisely you have an area where to work, you have a target. If you can cut the effect of DPP4 enzyme, produce an DPP4 inhibitor, so that the naturally innate gastrointestinal peptides will go and improve the effect of the, this is called incretin effect. That's how apple is famous for a long time. So that's how identifying the target molecule, discover the effective drug, find biomarkers, you will make much easier, much earlier, much better than the conventional drug discovery. So there are certain rights in the precision medicine. Certain rights to the patient. Patients need to be part of precision medicine for achieving its potential to the fullest, because you are using the patient's data. Patients need to understand assurance of data privacy. Data privacy is very important for a patient, because as I told earlier, one model where statin doesn't work, we have to give a PCSK9 inhibitor. Statin costs about 3,500 rupees per year, whereas PCSK9 costs 350,000 per year. So if your insurance company knows this data, nobody will give an insurance policy. So you should have a complete assurance to the patient of data privacy. and owner and utilization of the genetic information is patient itself, and understanding the informed consent and to voice their preferences, sharing genomic and other information. So it's important that patients express their preferences and requirements while they are assured of their data security. So physician also has certain rights in precision medicine, medical curricular reform, specialist training, ongoing physician training, and additional courses on genetics, understanding the genomes, and and so on. So introducing more CMEs, more courses in that, because this is not a part of curriculum so far. So it's important. AI had many medical applications. So this is one area where actually in the liver, the pathology of medical imaging is very, very important. I am into a project with the IIT to identify the liver tumors as early as possible. When they are about 9 to 10 millimeters, the prognosis is poor, and already they try to go out of the liver, and if you can precisely make when it is less than 3 millimeters, you can make a better complete cure, and almost 99%. So I am into this project with AI based, and you can have many applications like this in day-to-day practice. Similarly, you can have a endoscopy, which is AI directed. You can have a radiology, CT, MRI, ultrasound, which is AI directed. It can make more precision, more precise diagnostic tools. And of course, these are not my area. Normally these AI systems are produced by data scientists, and we usually collaborate with them. We give all our requirements to them and patient point of view, and then they make the models which should work for us. So in surgery also, robotic surgery. You see, this is the surgical instrument, end instrument. It can go to a very narrow place and can move 360 degrees where a human hand cannot reach. So it can stitch, it can cut, so tissue damage is very, very little, recovery is very fast, and the pain and post-op complications are very, very less with robotic surgery because of the high precision. So similarly, preoperative planning, if you feed all the data, like what exactly you are going to cut, you give all the measurements to the robot, it can make a preoperative planning, intraoperative guidance. It guides you, go this way, cut this, do this. Ultimately, it gives you assistant. It doesn't cut. It gives you signal to cut. And the surgical robotics, it requires precision, robustness, real time, and safety. All these are being practiced already. So future of medical practice with AI, we are practicing last decade, current decade is this, with all the biodata and the available evidence-based medicine, but next decade is going to be robotics, AI, augmented reality, and then differentiation via intelligent solutions for evidence outcome-based health, focused on preventive care and individualized care in particular. So health trends, technology, remote patient monitoring. You just put a chip in front of his chest. You can see all the data wherever you are, and you can monitor the patient, alert the patient to go, and a lot of telehealth after COVID is happening. So all that what we need is that data to interpret, and how AI will strengthen the future of healthcare. This is what is important. Ultimately, the end user is the patient, saves the doctor's time, improves the precision of diagnosis, prediction, and planning, and drugs, and as well as the prognostic monitoring and so on. So more personalized solutions in medication and treatment plan. And better understanding of human biology as you start practicing. It works much, much better and makes more accurate. So there are certain drawbacks like black box bias. If you do in certain people like South Asian Indians, it doesn't work for everybody. You have to make a model like by itself. Overfitting, data leakage is another thing which I have already told. And acquisition of data, privacy and security, quality of data, particularly the physiological data. If you know somebody's genetic data, what drugs work, what drugs doesn't work, you know. So you use your medication according to the genetic data. At the same time, physiological data. If somebody has more in high sympathetic outcomes, somebody secretes more adrenaline. If you have all that data, you can give a sympathetic blocker if the sympathetic secretion is high, and so on. There are so many things like that. So you normally we give beta blockers if there is sympathetic hypersecretion. Some people have very type A personality; they are anxious for everything. So indicating that they need sympathetic stimulation, and then we should give beta blocker to curtail all the sympathetic effects. And then finally, the ethical issues, privacy, safety, accountability, and regulation is another important thing. So unless, these are the future promising AI-based automation, new job creation, if you start practicing AI and understanding AI, an opportunity to build advanced AI capabilities, emergence of general AI to create synthetic systems as sophisticated as the human being, the formulation of AI regulatory framework. So far we are listening computerized, for everything computerized tea, computerized drawing, computerized haircut, computerized cleaning. But AI should not go like that. So there should be a proper regulatory framework for that. And the barriers being absence of interoperability, regulation implications, moral and ethical implications, concerns about the privacy, as well as the shortage of relevant and sufficient talent at this point of time. So globally, their precision medicine has initiated at so many places. So some initiatives have built new cohorts from scratch. Most initiatives have leveraged on the existing data from the biobanks, of course. And most of the initiatives predict that their findings will help improve people's health and update the latest knowledge in general and in particular for that personalized patient. So, ladies and gentlemen, in summary, advances in AI have the potential to transform many aspects of healthcare, enabling a future that's more personalized, more precise, more predictive, and more portable. And globally, AI could become a key tool for improving health equity around the world. We need investment into upskilling a healthcare workforce and future leaders that are digitally enabled and understand, embrace, than being, intimidated by potential of AI-augmented healthcare system. So one should understand the future requirement and gear up. If you are a doctor and if you adopt practicing AI, you will have an edge in future, and your patient will get better precision medicine, precision diagnosis, precision investigation, and finally the outcomes will be much better. So far we don't have much data on how AI works in a group of people, so it is only individualized here. Thank you very much for your patience with me. Yeah. So I'll be happy if you have any questions. Yeah.
Hospitals holds lot of data sets. How much they are investing in developing AI tools? Are they putting any efforts in collaborating with the IT industry?
There are now, most of the hospitals are using health systems to stratify, to give appointments, to change appointments, to give time slots. and these are up to that only, not per se interpreting the personal data of the patient and put together. There is some recent during COVID, there is what is called Arogya Setu, which intelligently can tell you what is your risk if you are there around. Similarly, there is prediction when they are traveling from one place to other place, there is a prediction of possibility of these people, infected people, how many people are traveling. Similarly, with similar AI systems, China can curtail a lot of, can contain the COVID transmission. So far it is not much utilized, and the database is more personalized, and there are no clear guidelines or ethical issues that prevents at this point. It has to come out in a big way. So far it is commercially used only.
Okay, so thank you.
Any other questions?
As of now, all the hospitals or hospital research-oriented institutions need the Indian-based data consent will not be all, diagnosed data. Maybe outlet of the, problem of the patient is going to make it open. Then we can have a broad view. What are the geographical areas? What are the areas specially? And what might be the symptoms dominating in that particular area? Maybe possible to bring out some of the solutions.
Definitely, it is possible, sir. We have to study in terms of AI with specific disease and groups of in-specific to this area, and how to prevent and how to precisely diagnose and treat. So it needs, that's what I told you, there is no epidemiological studies so far, and there are only case cohort studies and case present. So there is no epidemiological studies so far on AI-based understanding to put into the society. That's where we are.
What the point is, concerned to the individual patient's data related to Aadhaar link or some link data should be there. Then only it is possible to pick up the patient.
Yeah, of course there is data already, but the data is very primitive data. We need more genetic data, which is lacking. We need more physiological data, which is lacking. Biophysical profile, which is lacking. So if we can gear up our systems to get all the data and try to put into a model, then it is going to work.
It has to bring up the common platform, I think.
That's the future of medical practice.
Thank you, sir.
Thank you, sir. So somebody is asking what goes for doctors' practice in future. The future we cannot predict. If we know, with 100 rupees I can get 1 lakh, I could have invested in Infosys. Whatever, it improves. If you start practicing, if a doctor starts practicing AI, he is going to improve the precision, he is going to make better things for his patient, and he is going to be ahead of, and he is going to make difference in his own career. So, adopting AI in practice is important. Yes, please. Gentlemen.
Good afternoon, sir. It is suitable for all members, like middle class or cost.
Can you be little loud?
It is suitable for all of them, sir, like AI, medical.
Yeah. Is it useful for all the general public? To understand the disease model is important. Okay. As I told, I spoke one of those statin related. In general public, if that particular genetic pattern, as we know, if you come to me with high cholesterol, I don't know your genetic data. If I know your genetic data, if you have that particular statin resistance, I will not give statin to you. I will give some other drug. Okay. Definitely, if you have data, it's going to be useful for every individual patient. All that we need is the private, personalized data of the patient, genetic data, biophysical data, etc.
Thank you.
Like his question is, will the AI tools reduce the cost to the patient, or will it be affordable by all the people?
So, the AI-based Zolgesma is about 18 crores at this point of time. So it is not that as anything is expensive initially, but when you take up at a society level, looking at the benefit of overall society, gradually this knowledge will be useful to develop a newer model which can be useful in general at a large to the public. So you have to start somewhere. So keeping in society, we can start and make models. Thank you very much for all of you for patiently listening.
Thank you so much, sir. I think we, the techies, have got a lot of problem statements as well from the presentation. So maybe you have to think on, low-cost solutions as well. We will also, come up with this, being developers of different sectors. Thank you so much, sir, for your time. So quickly, I'll call up, before lunch, we'll have a talk from Dr. Somadatta Karak. She is a scientist in CCMB. So she is a science communicator and is working towards making science accessible to all. She is leading science communication and outreach projects that connects active science research and researchers of India with communities around them. She worked towards creating educational content for students and educators. She has also deconstructed science and technology for policymakers and public. Over to you, ma'am.
Thank you very much. Thank you. Good afternoon, everyone. And I'm probably the only outlier in the lineup of speakers that Swecha has invited, but thank you, Swecha, for inviting me. I'm not a techie by any means. And I also use very little of AI tools, so that's the disclaimer right at the outset. But what I am is, let me start my talk with who I am and what I do. I'm trained as a biologist, and I studied biology because I just wanted to understand myself, my own self-being, and also the living world around me. And biology and sciences was my way to do that, and I really found joy and curiosity through sciences. And I deeply feel for spreading that joy and curiosity among people, and that has shaped a lot of things that I do today. At the same time, as I was doing my higher education in biology, I also saw starkly how inequity of information exists in our society and also in any other society, in human society overall. And that is another thing that has inspired me to work in science communication. So I'm a science communicator. I mean, my designation is that of a senior scientist for the parlance of a government system. I work with a CSIR lab, the Center for Cellular and Molecular Biology. But as a science communicator, which is what my job is, my job as a science communicator is to make science more accessible to people. And most of the people that I work with are non-experts. So of course, and why would non-experts want to know about science? They want to know about it for education, and that's the reality of India. Science is something that most people associate only as education. It's a double-edged sword. On one hand, while it is education, I get access to a lot of young people, but then the notion that people have around education is also a little problematic, which I'll come to a little later in the talk. People also want to know about science because, like me, it also helps them make sense of the world around them. So it helps them find joy and curiosity. They want to be better informed, and when I say information, in my experience, I have seen a lot of people want to be better informed about health choices. And that could be around the latest understanding of our bodies, our medical technologies, or it could be even things like, the 5G is coming out, and is that going to impact our lives? Then the later points that I have here are more for people who are into the system. Like there are tech businesses, technology-oriented businesses who want to understand what's happening at the cutting edge of science because they can keep themselves at the forefront of the field. And there are policymakers who are also interested in science. And this list that you see here is by no means exhaustive. It is highly, highly influenced by the kind of stakeholders that I and my colleagues have to work with at CCMB. So this schematic, which I've taken from this paper, is, I mean, I really like this semantic because it talks about science communication in a very layered fashion. Science communication is not one thing that you have done for once and it is going to work. You need to really cater it for the audience that you're working with, and you need to also do it in a stepwise fashion. So the outer layers of this onion are basically information that you're giving to people. And you can give information by as many means as you can think of, as many sensory systems you have those many different ways of reaching out to people. But as you keep coming to the center of this onion, you're basically going to see that the conversations are going to get more targeted, and the ideal aim that science communicators or those who want to engage with public on science is that we want to make public equal stakeholders in decision making of what kind of science should the country be doing, what kinds of technologies we should be investing in, and what kinds of aims we want to have out of those. So that's what are the basically different layers of science communication or public engagement we expect to see in science. And to be able to do this, there are two broad areas that one needs to work on. One is the content generation, which is the broad aspect that most people are going to be given access to. And then also platform development, because where do you get these people to talk about science? Are these going to be physical spaces where they all come together, such as the conference, or multiple other spaces? Or are these going to be virtual medium, or anything else that probably I'm not able to even think about today? So developing content and developing platforms are two key areas that a science communicator needs to really invest in. Now, who wants to know about science? And again, this list is not exhaustive, but really influenced by my own experience, is scientists themselves want to understand what's happening in the big wide field of science, and that necessarily does not mean that a biologist wants to know only about biology. A biologist wants to know about physicists' work as well as vice versa and all of it. There are students who want to understand what's happening in the field because they associate their career developments with it. There are educators who want to help their students and hence want to understand what's happening in science. Citizenry, who just want to understand because they're taxpayers, they're funding the work that's happening here. However, in India, that sense is much lacking. I mean, there's a lot of trust that our citizenry puts on the scientific ecosystem, and maybe the citizenry needs to be more proactive about being accountable for what's happening in the ecosystem. Tech businesses, investors, they want to understand the science better. Investors I will particularly put here because AI, for example, it's the buzzword, right? Like everything is AI, AI, AI. And then the investors are completely clueless see what exactly is the big thing about it, and or how much of it is just hot gas. And investors are, I mean, it's something that I've seen really appreciate science communication and policymakers. And how do they get really access to these information? And traditionally, science journals, these are academic journals, and mostly available to the scientific community only for multiple of reasons. It might be behind a paywall, which you get access to only through institutional handles, or the language of writing a paper is very dense, very technical, and not accessible really to everyone. Popular science books try to bridge that barrier and is written in a more laymannish way, and that does not dumb down the science, but rather uses a language, asks questions that a non-expert would really relate with. Newspapers are another great source of science communication, and now in newspapers, there are two kinds of things that happen. Traditionally, scientists used to write in newspapers talking about their own work or what's generally happening in the bigger ecosystem. Then, now, there's a breed of journalists called as science journalists, and they want to understand science better so that they can cover science better. As well as at the same time, the science research institutes themselves have started investing a lot in sending more informed press notes to these newspapers. Social media is another great way. Twitter especially is a place where a lot of science-related discussion happens, and has become a very easy way for the journalists to stay connected with the scientists and ask questions right away there for them. Then there are trusted websites where people put trust in certain organizations. They feel that these organizations will have answers to the questions that they have, and they follow those websites. And in-person interactions, which are the most difficult because they're just most resource intensive. You need to have the expert who is going to do it for you. So these can range from expert talks to hands-on activities or exhibitions. So why do people enjoy certain content? And I'm asking this for every one of you to think about, because that's at the core of science communication. Generally, people think of science as something really difficult. Why should I invest thinking about science? Especially for those who are not already excited about science. So people find certain things, content, exciting for them if it is relatable to them, if it is empowering to them. It is simplified, but it does not dumb down. People don't want to think, you just don't think I'm capable of understanding this, and hence you are just simplifying it so much that it is making me feel bad about myself. And no matter what, the content has to add value to their lives. So you can do those only if you understand their own context, their lives, the questions that they generally relate with. And I'll just go back this one slide, because here we have certain examples that I think will help you understand what I mean by context. So up there, there's a group of girls who are talking about antimicrobial resistance. But then they're using comics that they have made to explain it to their own peers. So it's not like they are just listening to people, they are also making sense of it in their own way, in their own community. How are they seeing a problem like antimicrobial resistance play out in their own communities, and talk about it to others who are there. Or down here, where I've used a lot of art in explaining questions of science to people, because science discussions have traditionally been only text-based. And what problem that creates is that the country as a whole is not very literate. Their relationship with text is that of a fear. And hence, visuals really help break it down and make it more accessible to many of the people. And visuals is something that I have played with. I'm not a visual artist, but I've worked with a lot of visual artists. But the same thing can be done with many other sensory arts as well that you can think of. Another example in the center where you see those paper swans hanging and a lot of people crowding is actually a group of mathematicians who are talking about math in a public space. This is a picture from the Hyderabad.Experts of this year. And what I really found interesting was that math is something that people are even more scared of than science. And this was a group of people which was constantly crowded. And that was simply because they were using paper origami to explain geometry. And they were able to infuse art and fun and address questions. Geometry is something that's everything around you has geometry. So they were able to relate all these different things together to get a popularity like that. So these are some of the tools that we science communicators use regularly. But at the same time, there are many problems in the field. And some that I have related with are that there are not too many science communicators, not too many trained science communicators, not too many positions that employ science communicators. There are not many organizations which are invested in the cause. And at the same time, the number of people that you want to reach out to, they're all different in their own sense. They're all different demography, the places where they live, to the languages that they speak, the kind of questions that they relate with, and this diversity is so enormous that content creation and platform development itself is a humongous amount of work. And without dedication of investment into it, that becomes really difficult to go ahead from there. And effective SciComm is something, the tools to even measure what is effective SciComm are pretty much lacking. One of the dream tools is that can you measure behavior change because of the science communication that you have done? And such tools for a mass scale is not existent today. And for smaller scales, there are tools, of course, because social science does that all the time. But to be able to see such a change is enormously difficult, and hence that also deters a lot of people to get into this business. And because these are difficult questions, I think these are where AI should start helping in. And I'm going to just run through these big, broad questions of science communication and just let you all think, all of you in this room are much more equipped with the tools of AI. If you can think of solutions that can help in any of these. And these three questions, I've marked them in actually increasing order of complexity. The easiest is, can we make better content? Next is, can we fight misinformation better? The third is, can we create communities of people who are empowered with tools of science so that they can make better informed decisions? Let me take you start with the first question. Can AI make better content? And by better, I mean more inclusive content, more engaging content. And by more inclusive, one of the questions that, for example, I have often been challenged with is, what language do you use for science communication? And in my line of work, it has been predominantly English, and at that, very urban English. And I think everyone in the room will not need any explanation to understand that that does not work for most of the country. And given the lack of number of people working in this, it has just not moved beyond this very much. But at the same time, of course, there are smaller initiatives who do work at the grassroots in other languages. But we just need a bigger movement of creating more science-inspired content in various different languages. At the same time, it should be even more engaging. Most of the cases that I know today are people who are trained in sciences, people who are working as scientists, also doing science communication, which means that we look at science in a certain way, and that's how we are portraying science, and that often does not connect with how non-scientists look at science. And that's where students who are not trained to be scientists, but you're trained to be content makers, you're trained to be technologists, you could be anybody. I think AI tools should enable them to also make content. It could be text, it could be visuals, it could be audio, it could be also installations. And as of today, except for the installations, there are tools for all of these. And unlike you who talk about Llama and this model, that model, for me, these are all products, okay? That I just go to these platforms, I feed in some questions, and I get content out of it. And they've become really that well that for someone like me who does not need any tech knowledge is able to utilize them already. For installations, of course, these are much more physically intensive things, but AI tools today can also give you inspirations of what kinds of installations that you can think of, but at the end of the day, you still need people who are good with hands to make those for you. Now let's say that, let me just tell you how humans create Science, and then I'll come to if AI has to replace humans, what all things it needs to do. So as a human, as a science communicator, when I want to create something, first thing for me is to come across something interesting, something which is worth telling. Then I have to find its validity by going through scientific papers, talking to experts, contextualizing the study from a critical lens, because I have to also use my own sense to take away nonsense from sense, and then create content for my target audience in a style that will resonate with them. Now let's say AI has to, and this is a very simplistic model I've put here. One, it should know which scientific journals it should be accessing, because scientific journals today itself is an industry where there's a lot of fake journals. But let's say that can be done. Then it has to know how to read academic papers. And as of today, what I understand is that, tools are able to read it, but not able to quantify things. And I'll come to the details of that also. So one, it needs to know which journals it should look at. Two, read those and understand those academic papers. Then also know which experts it should reach out to validate the claims of those papers. Identify contexts appropriate for the target population, and then create content for them accordingly. And what's the current status today? Science journals are already using AI tools to make social media content based on the abstract, largely abstract of the paper. What it means is the content generally is of that of a celebratory nature. I mean, abstract is a much shorter thing, right? So it only generally says only good things about the paper. So the content that also comes out of such a tool is generally like, oh, okay, these are the good things that have happened with the paper. And the tool really helps them create the tone for multiple different kind of people. You can say that, hey, I want it for like a 20-year-old, and then create it in a language that 20-year-olds would relate with. These tools can work really well on text-based content, but it cannot quantify. And that's a problem for scientific papers because you really need to understand the graphs that they have put up there. Many journalists also cannot understand those, but what they do is then they access experts who can help them understand those or tell what is the shortcoming in the way the experiments have been conducted. So the AI tool either needs to learn how to quantify or know how to reach out to these experts. Then I'll come to the image generation part. In scientific, for scientific academic papers, image generation today with the accuracy that we need is still very, very blotchy. And that needs to improve, and that probably is just a matter of time though. So today, the tools are such that, it can help you do many things, but definitely under the supervision of a human who is trained very well in science. Plus, content generation, because I'm talking of communication, content generation raises significant ethical concerns today. For example, image generation. A lot of art that you probably saw earlier in my talk, those were humans who made those art for India context, India-specific contexts. And the amount that they got paid for those were not commensurate with a certain AI tool, which is now going to train itself on these work and earn much more. So from the science communicators, especially those who work with visuals, they definitely want to be a part of the community which thinks about how to ethically use these images for training your models. Coming to the second question, can AI help disseminate content better? And by disseminating better, can it also target misinformation better? In short, can it be a better social media influencer, a more responsible social media influencer? So today, there are already algorithms, right, which can sense people's mood, what they like, what they don't like, and give content accordingly. But all these algorithms are shaped by businesses, not by the intention of giving the right information to people. So this, I think, is just a matter of finding a way for you to integrate the ethics of communication with the financial, economical feasibility of doing something like this. But at the same time, I know examples from the medical community where they have already been working on things like this. So there's an app, for example, for sickle cell anemia patients. And now patients who are detected with sickle cell anemia, their doctor themselves, if they ask that, okay, you download this app will guide you to what you should be doing. It is just an enormous amount of help to the patient because now they're empowered with something that they can ask. The same thing that Dr. Pratik Desai also spoke about, the farmers having access to information that helps them take more informed decisions about agriculture. So, and these number of questions, they're numerous, and we all know these questions based on which community we are part of. So we really need, what we probably lack here is diversity of science communicators who come from different communities, are able to identify what kinds of content that their communities would want to know more about for whatever reason. It could be for better livelihood to just debunking age-old superstitions that they have. But if we can have that diversity of science communicators, we can then think about what questions and how we should go about them. The third one, which is probably the most difficult one, is how do we build a community of people who are empowered with tools of science so that they become problem solvers and rationalists? So today in India, science is looked at as something that you need to do just to get employment. It's just a degree-giving endeavor for most people. Hence, most people don't think of science as something that gives you the tools of thinking. It is only the tools of passing an exam. So building community on this really requires a cultural change. And as of today, I really don't know of any AI platform which brings about cultural changes. Any example of this that I have seen, I mean, by humans also, bringing about cultural changes are extremely difficult. Whatever examples I know of are driven by very handful number of highly driven human individuals. So now this is probably the ultimate frontier that we as society want to think about, is that can AI help any of those? Like, what is the current status now? Probably is that we have chatbots that can answer my questions. From there to really making those chatbots, if at all, really connect with me as another human is really a question that I do not have an answer to. But AI sector, not the AI sector, the education sector has been playing with such tools because they want to have AI tools which can help the teachers. Some might even call them replacements for teachers, which has a different problem, but that's how the sector is moving at, and I would probably be keeping an eye on that, on how they are able to move and what advances they can actually enable. I mean, what advances AI can enable them to do. So yeah, those are the 3 questions, and for me as a science communicator, I really wish to see if AI can help democratize access to reliable information to people based on their needs, not their biases. Giving content based on biases is what we are already able to do. The second is, if there's like, I'm a lot on social media and I see a lot of social media wars happening and based on misinformation. So I think this is fairly easy if AI tools can actually alert a diverse set of experts when it senses that something's gone viral, and now Twitter, for example, gives you the option of adding context to a certain tweet and say that, hey, this looks like problematic. So which means that this already has kind of started happening. Can AI take it further? Can you bring in a bigger community of people who have actually tools to understand the question better and put more context to it? And third is, which is related to that, is can you detect information and misinformation and targetedly send them more informed pieces? And for everyone in the room who want to be science communicators, I think you need to identify what really you want to use science communication for whom you want to do it, and why you want to do it. Accordingly, design your plan of action, the kind of content you want to make for them, how do you want the content to reach them? Is it going to be social media? Is it going to be internet-based? Is it going to be physical-based? All of those decisions you need to make. And definitely use AI tools to make your work easier and find inspirations. But remember that science communication today still is a very human-connected endeavor and requires a human to be able to do it. With that, I'll end my talk and happy to take questions. Thank you.
Yeah. So, thank you so much, ma'am.
I'm not able to figure out who's speaking.
Yeah, any questions from the audience?
Okay.
Yeah.
Sorry.
Any questions from the audience, or you can also have like, yeah. I'm really sorry, couldn't come down.
Thank you for the wonderful lecture.
Thank you.
When you communicate, for example, if I communicate in one language to my patient, a Dadan Didi can understand it in Bengali, a Bhaiya can understand it in Bihari, etc. So, what is the current status of such communication now?
Yeah. So, like I mentioned, that this kind of in-person communication is largely done only in English. And that also means that any of these in-person communications, when they happen, they're limited to a very elite set of audience who come in for this. And what we are trying to do, which has nothing to do with AI, is basically encourage more scientists to engage themselves in science communication. And in the scientific community, there's anyway a huge movement, if I may call it a movement, on increasing the diversity of scientists themselves. Like, it should grow beyond these certain specific states. I mean, Bengal, for example, creates a lot of scientists in India for whatever reasons. Then South India probably also has some. But then we don't have as many scientists coming from most of the states of India. So that's a different endeavor in itself, like how do you increase diversity of scientists? The second is, how do you incentivize science communication for these scientists. Many of these, especially in places where I have studied or now where I work, most scientists do this out of their goodwill. They really think that this is their way to give back to society. But at the same time, a lot of scientists have also started becoming more vocal about it, that this requires a lot of investment from their side, and they need to see more tangible outcomes for them. But nevertheless, coming to your question is that at this moment, it is really limited to the abilities of the scientist who is doing it, or the science communicator who is facilitating it or leading it. And hence, doing science communication in different Indian languages is a huge focus for the science communication community.
So we'll have one last question if there is any question here from the audience, else I think we'll close.
And maybe, until any other question comes.
You can take offline during lunch or
No, I just wanted to add a little more context to your question. So unlike, let's say, a chatbot answering what medicine one needs to take, and that already is a complex question though, but it can be probably pre-fed. But in science, especially things which are at cutting edge, a lot of it is also how that specific scientist looks at that field, the kinds of opportunities, the shortcomings. And that makes it really complex to train a chatbot to give those kinds of responses. But a chatbot, on the other hand, can be trained to give more generic answers, which probably is useful to a certain extent.
So if there are no questions, you have a question? Anyone, any questions? Okay. So yeah, I think you can also connect offline with ma'am as well. So thank you so much, ma'am. Thank you for the wonderful session. And of course, even Swecha also focuses on inculcating scientific temper among the students, and can be a lot being done, especially through the projects which I've said. Projects like which can really communicate science. We do also one project called Swecha, where we include a lot of science experiments virtually, and we do a lot of stuff in that, where even from the young age we also train them. Our efforts are towards increasing scientific temper among the kids as well, from the young age, so that they'll be capable of more science can be communicated, as we are in the AI era. So using AI tools, so that we can experiment more, learn more, and be more science and technology progress, so that which leads to the progress of the society. So thank you so much, ma'am, for the insights, and I think everyone here, online users who are already watching live have a lot of insights from this seminar. Thank you so much. So yeah, so let's break for the lunch right now, and we can come back after 30 minutes to 40 minutes. We have another round of things happening. So let's break for the lunch. Thank you so much, everyone.
AI Days is the largest conference on artificial intelligence in India that is being held on the 30th and 31st in our Hyderabad at JNTU. The significance of this conference lies from the very fact that the people-centric approach of AI is going to be visibly made clear in this conference. There have been many misnomers, misunderstandings, misrepresentations on the very understanding of the AI itself. AI is being vilified, construed as an enemy of work, or maybe it says that people are going to be rendered unemployed, etc., etc., etc. But the stage in which we have evolved into, AI becomes inevitable to solve the problems which people are facing. One important aspect is that it is through AI, a product that we're going to release in this conference, that a Telugu language assistant, calling it as a language assistant is basically might decrease the effectiveness of the solution that we have made. But essentially, any farmer, any agricultural laborer, or anyone who doesn't even know to read or write will be able to figure out, search anything that is available on the internet. He could ask anything on this AI assistant, and the AI assistant is going to communicate back in their own mother tongue. And this is something that we call about people-centric aspect of AI. AI is supposed to solve problems of the commons, and we are going to discuss on building tools and solutions. How do we make life better for the agricultural laborers, farmers, to the Safai Karmacharis, to all the commons, and AI has a vital role and a very significant role to play. In this conference, we're going to have 70 plus speakers from different industries. We have got speakers from Meta, Amazon, Microsoft, from IITs, and all the premium institutions like IIIT and other places too. I invite you all to be there for the conference, and stay tuned for more exciting days. To know more about the conference, just get on to aidays.io. AI Days is the largest conference on artificial intelligence in India that is being held on the 30th and 31st in our Hyderabad at JNTU. The significance of this conference lies from the very fact that the people-centric approach of AI is going to be visibly made clear in this conference. There have been many misnomers, misunderstandings, misrepresentations on the very understanding of the AI itself. AI is being vilified, construed as an enemy of work, or maybe it says that people are going to be rendered unemployed, etc., etc., etc. But the stage in which we have evolved into, AI becomes inevitable to solve the problems which people are facing. One important aspect is that it is through AI, a product that we're going to release in this conference, that a Telugu language assistant, calling it as a language assistant is basically might decrease the effectiveness of the solution that we have made. But essentially, any farmer, any agricultural laborer, or anyone who doesn't even know to read or write will be able to figure out, search anything that is available on the internet. He could ask anything on this AI assistant, and the AI assistant is going to communicate back in their own mother tongue. And this is something that we call about people-centric aspect of AI. AI is supposed to solve problems of the commons, and we are going to discuss on building tools and solutions. How do we make life better for the agricultural laborers, farmers, to the Safai Karmacharis, to all the commons, and AI has a vital role and a very significant role to play. In this conference, we're going to have 70 plus speakers from different industries. We have got speakers from Meta, Amazon, Microsoft, from IITs, and all the premium institutions like IIIT and other places too. I invite you all to be there for the conference, and stay tuned for more exciting days. To know more about the conference, just get on to aidays.io. AI Days is the largest conference on artificial intelligence in India that is being held on the 30th and 31st in our Hyderabad at JNTU. The significance of this conference lies from the very fact that the people-centric approach of AI is going to be visibly made clear in this conference. There have been many misnomers, misunderstandings, misrepresentations on the very understanding of the AI itself. AI is being vilified, construed as an enemy of work, or maybe it says that people are going to be rendered unemployed, etc., etc., etc. But the stage in which we have evolved into, AI becomes inevitable to solve the problems which people are facing. One important aspect is that it is through AI, a product that we're going to release in this conference, that a Telugu language assistant, calling it as a language assistant is basically might decrease the effectiveness of the solution that we have made. But essentially, any farmer, any agricultural labor, or anyone who doesn't even know to read or write will be able to figure out, search anything that is available on the internet. You could ask anything on this AI assistant, and the AI assistant is going to communicate back in their own mother tongue. And this is something that we call about people-centric aspect of AI. AI is supposed to solve problems of the commons, and we are going to discuss on building tools and solutions. How do we make life better for the agricultural laborers, farmers, to the Safai Karmacharis, to all the commons, and AI has a vital role and a very significant role to play. In this conference, we're going to have 70 plus speakers from different industries. We have got speakers from Meta, Amazon, Microsoft, from IITs, and all the premium institutions like IIIT and other places too. I invite you all to be there for the conference, and stay tuned for more exciting days. To know more about the conference, just get on to aidays.io. AI Days is the largest conference on artificial intelligence in India that is being held on the 30th and 31st in our Hyderabad at JNTU. The significance of this conference lies from the very fact that the people-centric approach of AI is going to be visibly made clear in this conference. There have been many misnomers, misunderstandings, misrepresentations on the very understanding of the AI itself. AI is being vilified, construed as an enemy of work, or maybe it says that people are going to be rendered unemployed, etc., etc., etc. But the stage in which we have evolved into, AI becomes inevitable to solve the problems which people are facing. One important aspect is that it is through AI, a product that we're going to release in this conference, that a Telugu language assistant, calling it as a language assistant is basically might decrease the effectiveness of the solution that we have made. But essentially, any farmer, any agricultural labor, or anyone who doesn't even know to read or write will be able to figure out, search anything that is available on the internet. You could ask anything on this AI assistant, and the AI assistant is going to communicate back in their own mother tongue. And this is something that we call about people-centric aspect of AI. AI is supposed to solve problems of the commons, and we are going to discuss on building tools and solutions. How do we make life better for the agricultural laborers, farmers, to the Safai Karmacharis, to all the commons, and AI has a vital role and a very significant role to play. In this conference, we're going to have 70 plus speakers from different industries. We have got speakers from Meta, Amazon, Microsoft, from IITs and all the premium institutions like IIIT and other places too. I invite you all to be there for the conference and stay tuned for more exciting days. To know more about the conference, just get on to aidays.io. AI Days is the largest conference on artificial intelligence in India that is being held on the 30th and 31st in our Hyderabad at JNTU. The significance of this conference lies from the very fact that the people-centric approach of AI is going to be visibly made clear in this conference. There have been many misnomers, misunderstandings, misrepresentations on the very understanding of the AI itself. AI is being vilified, construed as an enemy of work, or maybe it says that people are going to be rendered unemployed, etc., etc., etc. But the stage in which we have evolved into, AI becomes inevitable to solve the problems which people are facing. One important aspect is that it is through AI, a product that we're going to release in this conference, that a Telugu language assistant. Calling it as a language assistant is basically might decrease the effectiveness of the solution that we have made. But essentially, any farmer, any agricultural labor, or anyone who doesn't even know to read or write will be able to figure out, search anything that is available on the internet. You could ask anything on this AI assistant, and the AI assistant is going to communicate back in their own mother tongue. And this is something that we call about people-centric aspect of AI. AI is supposed to solve problems of the commons, and we are going to discuss on building tools and solutions. How do we make life better for the agricultural laborers, farmers, to the Safai Karmacharis, to all the commons, and AI has a vital role and a very significant role to play. In this conference, we're going to have 70 plus speakers from different industries. We have got speakers from Meta, Amazon, Microsoft, from IITs and all the premium institutions like IIIT and other places too. I invite you all to be there for the conference and stay tuned for more exciting days. To know more about the conference, just get on to aidays.io. AI Days is the largest conference on artificial intelligence in India that is being held on the 30th and 31st in our Hyderabad at JNTU. The significance of this conference lies from the very fact that the people-centric approach of AI is going to be visibly made clear in this conference. There have been many misnomers, misunderstandings, misrepresentations on the very understanding of the AI itself. AI is being vilified, construed as an enemy of work, or maybe it says that people are going to be rendered unemployed, etc., etc., etc. But the stage in which we have evolved into, AI becomes inevitable to solve the problems which people are facing. One important aspect is that it is through AI, a product that we're going to release in this conference, that a Telugu language assistant. Calling it as a language assistant is basically might decrease the effectiveness of the solution that we have made. But essentially, any farmer, any agricultural labor, or anyone who doesn't even know to read or write will be able to figure out, search anything that is available on the internet. You could ask anything on this AI assistant, and the AI assistant is going to communicate back in their own mother tongue. And this is something that we call about people-centric aspect of AI. AI is supposed to solve problems of the commons, and we are going to discuss on building tools and solutions. How do we make life better for the agricultural laborers, farmers, to the Safai Karmacharis, to all the commons, and AI has a vital role and a very significant role to play. In this conference, we're going to have 70 plus speakers from different industries. We have got speakers from Meta, Amazon, Microsoft, from IITs, and all the premium institutions like IIIT and other places too. I invite you all to be there for the conference and stay tuned for more exciting days. To know more about the conference, just get on to aidays.io. AI Days is the largest conference on artificial intelligence in India that is being held on the 30th and 31st in our Hyderabad at JNTU. The significance of this conference lies from the very fact that the people-centric approach of AI is going to be visibly made clear in this conference. There have been many misnomers, misunderstandings, misrepresentations on the very understanding of the AI itself. AI is being vilified, construed as an enemy of work, or maybe it says that people are going to be rendered unemployed, etc., etc., etc. But the stage in which we have evolved into, AI becomes inevitable to solve the problems which people are facing. One important aspect is that it is through AI, a product that we're going to release in this conference, that a Telugu language assistant. Calling it as a language assistant is basically might decrease the effectiveness of the solution that we have made. But essentially, any farmer, any agricultural laborer, or anyone who doesn't even know to read or write will be able to figure out, search anything that is available on the internet. You could ask anything on this AI assistant, and the AI assistant is going to communicate back in their own mother tongue. And this is something that we call about people-centric aspect of AI. AI is supposed to solve problems of the commons, and we are going to discuss on building tools and solutions. How do we make life better for the agricultural laborers, farmers, to the Safai Karmacharis, to all the commons, and AI has a vital role and a very significant role to play. In this conference, we're going to have 70 plus speakers from different industries. We have got speakers from Meta, Amazon, Microsoft, from IITs, and all the premium institutions like IIIT and other places too. I invite you all to be there for the conference and stay tuned for more exciting days. To know more about the conference, just get on to aidays.io. AI Days is the largest conference on artificial intelligence in India that is being held on the 30th and 31st in our Hyderabad at JNTU. The significance of this conference lies from the very fact that the people-centric approach of AI is going to be visibly made clear in this conference. There have been many misnomers, misunderstandings, misrepresentations on the very understanding of the AI itself. AI is being vilified, construed as an enemy of work, or maybe it says that people are going to be rendered unemployed, etc., etc., etc. But the stage in which we have evolved into, AI becomes inevitable to solve the problems which people are facing. One important aspect is that it is through AI, a product that we're going to release in this conference, that a Telugu language assistant. Calling it as a language assistant is basically might decrease the effectiveness of the solution that we have made. But essentially, any farmer, any agricultural labor, or anyone who doesn't even know to read or write will be able to figure out, search anything that is available on the internet. You could ask anything on this AI assistant, and the AI assistant is going to communicate back in their own mother tongue. And this is something that we call about people-centric aspect of AI. AI is supposed to solve problems of the commons, and we are going to discuss on building tools and solutions. How do we make life better for the agricultural laborers, farmers, to the Safai Karmacharis, to all the commons, and AI has a vital role and a very significant role to play. In this conference, we're going to have 70 plus speakers from different industries. We have got speakers from Meta, Amazon, Microsoft, from IITs, and all the premium institutions like IIIT and other places too. I invite you all to be there for the conference, and stay tuned for more exciting days. To know more about the conference, just get on to aidays.io. AI Days is the largest conference on artificial intelligence in India that is being held on the 30th and 31st in our Hyderabad at JNTU. The significance of this conference lies from the very fact that the people-centric approach of AI is going to be visibly made clear in this conference. There have been many misnomers, misunderstandings, misrepresentations on the very understanding of the AI itself. AI is being vilified, construed as an enemy of work, or maybe it says that people are going to be rendered unemployed, etc., etc., etc. But the stage in which we have evolved into, AI becomes inevitable to solve the problems which people are facing. One important aspect is that it is through AI, a product that we're going to release in this conference, that a Telugu language assistant. Calling it as a language assistant is basically might decrease the effectiveness of the solution that we have made. But essentially, any farmer, any agricultural labor, or anyone who doesn't even know to read or write will be able to figure out, search anything that is available on the internet. You could ask anything on this AI assistant, and the AI assistant is going to communicate back in their own mother tongue. And this is something that we call about people-centric aspect of AI. AI is supposed to solve problems of the commons, and we are going to discuss on building tools and solutions. How do we make life better for the agricultural laborers, farmers, to the Safai Karmacharis, to all the commons, and AI has a vital role and a very significant role to play. In this conference, we're going to have 70 plus speakers from different industries. We have got speakers from Meta, Amazon, Microsoft, from IITs, and all the premium institutions like IIIT and other places too. I invite you all to be there for the conference, and stay tuned for more exciting days. To know more about the conference, just get on to aidays.io. AI Days is the largest conference on artificial intelligence in India that is being held on the 30th and 31st in our Hyderabad at JNTU. The significance of this conference lies from the very fact that the people-centric approach of AI is going to be visibly made clear in this conference. There have been many misnomers, misunderstandings, misrepresentations on the very understanding of the AI itself. AI is being vilified, construed as an enemy of work, or maybe it says that people are going to be rendered unemployed, etc., etc., etc. But the stage in which we have evolved into, AI becomes inevitable to solve the problems which people are facing. one important aspect is that it is through AI, a product that we're going to release in this conference, that a Telugu language assistant. Calling it as a language assistant is basically might decrease the effectiveness of the solution that we have made. But essentially, any farmer, any agricultural labor, or anyone who doesn't even know to read or write will be able to figure out, search anything that is available on the internet. You could ask anything on this AI assistant, and the AI assistant is going to communicate back in their own mother tongue. And this is something that we call about people-centric aspect of AI. AI is
నేను ఒక ఐటీ ఎంప్లాయీ అండి. నేను ఐటీ కంపెనీలో పనిచేస్తూనే స్వేచ్ఛలో కూడా ఎగ్జిక్యూటివ్ కమిటీ మెంబర్ని, వన్ ఆఫ్ ద మెయిన్ ఆర్గనైజర్స్ అనమాట. సో బేసిక్గా రేపు పెద్ద ఎత్తున జరిగే ఈ AI డేస్ కాన్ఫరెన్స్ ఏదైతే ఉందో, ఈ 2 రోజులకు సంబంధించిన వర్క్స్, ప్రిపరేటరీ వర్క్స్ అన్నీ చేయడానికి వాలంటీర్స్ సుమారు 150 పైన వాలంటీర్స్ వచ్చారు, యాక్చువల్ స్టూడెంట్ వాలంటీర్స్. దాంతోపాటు మనకి మన ఎగ్జిక్యూటివ్ కమిటీ మెంబర్స్ అవ్వచ్చు, డిఫరెంట్ కంపెనీ హెడ్స్ అవ్వచ్చు, వీళ్ళందరూ కూడా వచ్చి దీనిలో భాగస్వాములు అయ్యి వాళ్ళందరూ కూడా రేపు జరగబోయే ప్యానల్ డిస్కషన్స్, ట్రాక్స్ ఎట్లా సెట్ చేసుకోవాలి ఏంటి ఇవన్నీ కూడా చూసుకుంటున్నారు. సో ఇది భారతదేశంలోనే బిగ్గెస్ట్ కాన్ఫరెన్స్ కాబట్టి సో పెద్ద ఎత్తున ప్రిపరేషన్స్ అయితే జరుగుతున్నాయి. అందరూ జాయిన్ అవ్వాలని కోరుకుంటున్నాము.
So this is the location where we will be holding our conference, and this is going to the main auditorium. The Jawaharlal Nehru Auditorium at the JNTU is getting ready for the largest ever AI conference in India. And I think there is a series of luminaries who would be coming, and there are close to 70 speakers, 60 sessions, and hundreds of people who would be attending it. And it ranges from CEOs to CXOs to researchers, academia, IT professionals and students. So from 101 sessions to a deep dive into AI, Hyderabad is pacing ahead itself, bracing ahead itself, and I want everyone to come and see and participate and enjoy how the AI is going to shape up in India for society.
సో బేసిక్గా మనము రేపు బిగ్గెస్ట్ AI కాన్ఫరెన్స్ ఇన్ ఇండియాకి ప్రిపరేషన్స్ నడుస్తూ ఉంది. చూస్తూ ఉన్నారు కదా, మనము ఒక మోడల్ని తయారు చేస్తున్నాము. ఇక్కడ మన రైతులు వచ్చేసి మోటార్ని వాళ్ళ వాయిస్తో ఆన్ చేస్తారు. సో అదొక యాక్షన్. కిరణ్ చంద్ర గారు మనకి గైడ్ చేస్తున్నారు మొత్తం టీమ్ని అంతా ఎలా చేయాలా. డ్రై రన్ ఒకసారి చేసుకుంటే LED స్క్రీన్స్ అన్నీ కూడా సెటప్ అయిపోయినాయి. మొత్తానికి చాలా బాగా వచ్చింది అంతా. ఆల్మోస్ట్ 1000 మందిని ఎక్స్పెక్ట్ చేస్తున్నాం రేపు మనం. సో ఇవంతా మనం మేనేజ్ చేసేసి రేపు సక్సెస్ అవ్వాలని కోరుకుంటున్నాం.
My name is Amulya Gandhi. I am from GIOE, studying from Cloud Computing and Big Data branch. Basically, రేపు AI Days eventకి టెక్ సపోర్ట్ లాగా వాలంటీర్ చేస్తున్నా. Very nervous and excited.
So we are here as volunteers. రేపు అయ్యే వర్క్షాప్స్లో we are going to help them by technically. My branch is CCB, Cloud Computing and Big Data. Actually, as a volunteers, we are first time here in Swecha. We are so excited to teach them, as well as we are also seeking to learn something new and creative.
ఏంటంటే ఏఐ అంటే మనమే చెప్తున్నాం, డిఫైన్ చేస్తున్నాం లిటరలీ. ఎందుకంటే ఏఐ అంటే చాలా ఏదో బ్రహ్మ పదార్థంలాగా, ఏఐ అంటే మన వల్ల అవుతుందా, అసలు ఏఐ అంటే ఏంటి, చాలామందికి కన్ఫ్యూజన్లు ఇవన్నీ కూడా ఉన్నాయి. I think this particular conference is the beginning where we are going to set an example, and only పెద్ద పెద్ద కార్పొరేట్ కంపెనీలనే కాదు, గూగుల్, మైక్రోసాఫ్ట్ వాళ్ళే బిల్డ్ చేయటం అని కాదు, మనలాంటి సామాన్య ప్రజలు కూడా మన కోసం. అబ్దుల్ కలాం గారు వెన్ హీ వాజ్ ఎ ప్రెసిడెంట్, అబ్దుల్ కలాం గారు చెప్పారు ఏంటంటే ఒక కాన్ఫరెన్స్లో 2005లో, పీపుల్ క్రియేట్ నాలెడ్జ్ ఫర్ పీపుల్. ఐ థింక్ దట్ ఈస్ really successful, and that is happening every day, and we are creating knowledge for people again back. I think as we are in AI era, we are creating localized AI and democratizing the technology to make it accessible to the people.
Awesome 2 days. AI Days 2024. If you're not here, you're missing something great. All of you be here without fail.
I'm happy to be here because the AI 2024 is one of the biggest conference on artificial intelligence. Since it's going to invite, or other participations are coming from academicians, students, researchers, and also from industry, it's going to be a good gathering, and I'm sure 70 speakers from different cross-section of areas. I think they'll definitely provide lot of information to all of us. Be here, make it a big success.
I welcome everyone here. We are happy to be here at AI Days.
See, the event AI Days started. I'm really happy to be part of the whole event. I found that the large number of participants are really, they express their happiness, especially in the inaugural session. It's quite interesting that everybody appreciated the inauguration, and the starting point is really good. I'm sure the next 2 days will be great for everyone.
So I'm Prabhat. I am currently doing my masters in C-Minds IIT Bombay. So it's great to be here, and it's such a large forum for discussing AI and getting to know more. So I'm looking forward for the experience. So AI technology has come very far over the last few years, but now I think it's time for India to take it forward and make it localize it. And I think India AI particularly has a lot of potential for growth in India. So thank you.
It's a great concept to celebrate AI Day. In the recent past, in every field, if you take
there are a lot of data, particularly in genomics. We are sequencing huge number of genome which produce huge amount of data. But making sense out of the data is very, very important. By looking at every single data manually, it's going to take large number of years, and getting information quickly and particularly to use for the society, we need artificial intelligence. Therefore, having conference like this is going to help not only for those who are working in the field of genomics or any big data, it's also useful for the younger generation. They will come to know more about how one can make use of artificial intelligence in analyzing a huge amount of data. Thank you.
I'm here and my friends here as part of Super Bloom Studios. We are working on, building inclusive products, or we're incubators for inclusive products. And AI in that sense is the future, and we know that inclusion is also the future and AI is the future, so we are looking at inclusive AI. That's our message, and that's why we are also here today. I'm from Tamil Nadu. We are three women from IIT Madras, and we have been meaning to work.
I welcome everyone here. We are happy to be here at AI Days.
See, the event AI Days started. I'm really happy to be part of the whole event. I found that the large number of participants are really, they express their happiness, especially in the inaugural session. It's quite interesting that everybody appreciated the inauguration, and the starting point is really good. I'm sure the next 2 days will be great for everyone.
So I'm Prabhat. I am currently doing my masters in C-Minds IIT Bombay. So it's great to be here, and it's such a large forum for discussing AI and getting to know more. So I'm looking forward for the experience. So AI technology has come very far over the last few years, but now I think it's time for India to take it forward and make it localize it. And I think AI particularly has a lot of potential for growth in India. So thank you.
It's a great concept to celebrate AI Day. In the recent past, in every field, if you take, there are a lot of data, particularly in genomics. We are sequencing huge number of genome which produce huge amount of data. But making sense out of the data is very, very important. By looking at every single data manually, it's going to take large number of years and getting information quickly, and particularly to use for the society, we need artificial intelligence. Therefore, having conference like this is going to help not only for those who are working in the field of genomics or any big data, it's also useful for the younger generation. They will come to know more about how one can make use of artificial intelligence in analyzing a huge amount of data. Thank you.
I'm here and my friends here as part of Superbloom Studios. We are working on, building inclusive products, or we're incubators for inclusive products. And AI, in that sense, is the future. And we know that inclusion is also the future, and AI is the future. So we are looking at inclusive AI. That's our message, and that's why we are also here today. I'm from Tamil Nadu. We are three women from IIT Madras, and we have been meaning to work.
I welcome everyone here. We are happy to be here at AI Days.
See, the event AI Days started. I'm really happy to be part of the whole event. I found that the large number of participants are really, they express their happiness, especially in the inaugural session. It's quite interesting that everybody appreciated the inauguration, and the starting point is really good. I'm sure the next 2 days will be great for everyone.
So I'm Prabhat. I am currently doing my masters in C-Minds IIT Bombay. So it's great to be here, and it's such a large forum for discussing AI and getting to know more. So I'm looking forward for the experience. So AI technology has come very far over the last few years, but now I think it's time for India to take it forward and make it localize it. And I think AI particularly has a lot of potential for growth in India. So thank you.
It's a great concept to celebrate AI Day. In the recent past, in every field, if you take, there are a lot of data, particularly in genomics. We are sequencing huge number of genome, which produce huge amount of data. But making sense out of the data is very, very important. By looking at every single data manually, it's going to take large number of years, and getting information quickly, and particularly to use for the society, we need artificial intelligence. Therefore, having conference like this is going to help not only for those who are working in the field of genomics or any big data. It's also useful for the younger generation. They will come to know more about how one can make use of artificial intelligence in analyzing a huge amount of data. Thank you.
I'm here and my friends here as part of Superbloom Studios. We are working on, building inclusive products, or we're incubators for inclusive products. And AI, in that sense, is the future. And we know that inclusion is also the future, and AI is the future. So we are looking at inclusive AI. That's our message, and that's why we are also here today. I'm from Tamil Nadu. We are three women from IIT Madras, and we have been meaning to work.
I welcome everyone here. We are happy to be here at AI Days.
See, the event AI Days started. I'm really happy to be part of the whole event. I found that the large number of participants are really, they express their happiness, especially in the inaugural session. It's quite interesting that everybody appreciated the inauguration, and the starting point is really good. I'm sure the next 2 days will be great for everyone.
So I'm Prabhat. I am currently doing my masters in C-Minds IIT Bombay. So it's great to be here, and it's such a large forum for discussing AI and getting to know more. So I'm looking forward for the experience. So AI technology has come very far over the last few years, but now I think it's time for India to take it forward and make it, localize it. And I think AI particularly has a lot of potential for growth in India. So thank you.
It's a great concept to celebrate AI Day. In the recent past, in every field, if you take, there are a lot of data, particularly in genomics. We are sequencing huge number of genome, which produce huge amount of data. But making sense out of the data is very, very important. By looking at every single data manually, it's going to take large number of years, and getting information quickly and particularly to use for the society, we need artificial intelligence. Therefore, having conference like this is going to help not only for those who are working in the field of genomics or any big data, it's also useful for the younger generation. They will come to know more about how one can make use of artificial intelligence in analyzing a huge amount of data. Thank you.
I'm here and my friends here as part of Superbloom Studios. We are working on, building inclusive products, or we're incubators for inclusive products. And AI in that sense is the future, and we know that inclusion is also the future and AI is the future, so we are looking at inclusive AI. That's our message, and that's why we are also here today. I'm from Tamil Nadu. We are three women from IIT Madras, and we have been meaning to work.
More advantage so that we can do something in realizing it in a better way. Next please. Right. So what is the impact of this on the society? 20% of the elderly people, that is 1 in 5, have some chronic ailment, and almost half of them have more than one, and these diseases kill 41 million patients per annum. That's almost 74% of the all deaths. So almost 3/4 of the deaths are because of the chronic diseases. So what it does is it is going to diminish the health and deplete the quality time that we're going to spend. Right? Okay. So the WHO in 2013 decided that they are going to do something to reduce the tobacco use, control the blood pressure, control the obesity, control the sugars and other things, and they miserably failed, not because the planning was wrong, not because the execution is wrong, but the adaptability is wrong, and people couldn't understand how they are going to do and what they are going to do. Right? So, what impact it is having is something different, and how can technology help in reducing this? I call it as a augmented intelligence or assistive intelligence in making the disease predictions come in a better way. We can offer better cures, and we can offer better treatments in these cases. Right? So what to do to achieve this? First, I need to pick up the case where I can make the impact. And that picking up technology is called screening. Most of the people get confused between diagnosis and screening. Screening is just triaging. I'll say you need to focus more here, you need to focus here. That's it. That's the beauty of this screening. And screening definitely requires further tests to confirm the disease. Right? Being an oncologist, my first focus was on top 3 cancers: breast, oral. If you look at the red circle, breast, oral and cervical cancers are the number 3, 1, 2, 3 cancers which contribute to half of the cancers. And how can I go? I can just do a blood test. I can give a small card and then just get it up. That is feasible. I can do a liquid biopsies. I can do a mammogram. A lot of conventional mammograms are available. It is screening the breast. But what we did is different. We took a small piece of film, what you are looking into the picture, placed on the breast, and tumors are harder than the normal breast. So if I am compressing it, at the point, this is the point, right? Okay. So let me see. So if you can see the blue one, there is a small pink, the green one, the small pinkish one is where you can see a small dot there. So that's where it is not able to compress. So that's the thing that we are able to empower. So why do I require? I'm a trained oncologist with 25 years of experience. With my hand I can feel it. But a nurse who got training with only 6 months cannot find it. So this mission is going to actually replace Dr. Suresh, and I'm going to make the nurse as probably more experienced than what I can do. So this is what we applied the technology and then we did. It is not a simple thing. Our publication is there in 2022 in European Institute of Medical Oncology. We screened 86,000 patients, and detected 34,000 patients. They have experience for that, and 486 patients they detected with the breast cancer detected, which are otherwise missed. So this is one thing how technology is going to make an impact. We always are trying to explore the image analytics and then try to embrace it, and we try to do it in the cervical cancer. Cervical cancer I can diagnose by looking into the cervix. What we do is, we arrange the camera. This is a machine, it's like a mobile phone, and then take a picture, send it to the cloud, it will tell whether there is a cancer or not. So I am replacing one sense, that is touch sense, with one of the devices. The second sense is visual sense, that is what we call it as a image analytics, we did it. And the third thing is the warmth, temperature. The oral tumors are warmer than the normal looking mouth, and they look also different. So we use this technology called SASCAN, and we screen 1.32 lakh patients and could diagnose 2,826. This is what I am telling, what we are doing. It is not hypothetical. This we have applied in the fields and we got the results. So AI is no more a thing of future. We have been using it for the last 4 years and we have great success with it. We are more comfortable using this. This is another story. Every woman gets a mammogram done to detect the breast cancer. What we found is what we see in the red color. Anyone from the medical background identifies that this looks like a angiogram, right? Because breast cancer and coronary artery diseases share exactly the same features. No big difference. Okay? So we use the new technology and we got, these are the publications that we did it. Total, the International Journal of Community Medicine, the topmost journal called Journal of Clinical Oncology, and ESMO, that is Journals of Oncology Europe. So we found that if you subject the conventional mammogram of a lady to a machine learning process, add on some of the features, you can actually tell how soon the lady is going to develop a heart attack or a coronary artery disease. This is possible. We did it. And to a surprise, the detection rate of cancer is 0.1%, whereas coronary artery disease is 8%. So just one extra layer of analysis, image analysis, will detect and prevent almost 8% of the preventable cardiac deaths. And you are not doing any extra tests. Same mammogram you do for the breast cancer screening can help you to detect heart attacks. We did one more innovation, it's called COPD device. We all know that there is something called average blood sugars, right? So 3 months average sugar, because chronic diseases have a long lifespan, but there is nothing like a chronic asthma score or a chronic anything score. It is always a snapshot. Okay, just to give an example, I am a diabetic patient. Today I control my sugar well and the doctor treats me wrong, but if the HbA1c is wrong, he says, boss, in the last 3 months you are behaving bad. Today you are good doesn't mean that you are good in the last 3 months. Same thing is true with COPD. Most of the under treatment or over treatment are happening because the doctor is clueless what is happening in between the visits. So we collected the breath in silicon pins and developed a prototype. This is hard. I forgot to show the picture. So by looking at this, it gives a COPD score that tells that the average control in last 3 months is good or bad. So this is again using a big data, how we are going to help the physician to make a better decision of enhancing the treatment or curtailing the treatment. One more huge data set, 54 million lab reports have been identified. Classically, this is everyone knows. People have diabetes and hypertension and other things. We did a globulin test and we missed myeloma in most of the cases. When I analyzed it, the 10 years of my follow-up of my patients, all of the people are telling 8 years ago that I'm likely to develop a myeloma today. And this we missed it. And what we found is, this is 400K patients, with almost 5 million data sets, 5.4 million data sets belonging to almost 5 lakh patients. We analyzed, focus on 50 most popular tests, and 233 patients have at least one abnormality. And this is what is the algorithm that we will. This is more of a statistical stuff, which I don't want, 80-20 rule. And what our inference is, the future most troublesome disease in 2040 is NASH, non-alcoholic steatohepatitis. People die of CLDs and liver cancers, not because of cervical cancer, because we have better tools and there is nothing that can prevent it. We are closely working with one of the pharma companies on how to detect it early, at least 8 to 10 years before, and develop a drug to stop this happening. Right? We also did the development of NASH. I can tell in next 5 years a diabetic patient is likely to develop dialysis dependence and renal failure or not. These are all the things that we did with 10 years of data sets belonging to the same patients, 500 patients, 5.4 million lab tests. So this is what actually the frequency of the tests and other things. So if you look at the consensus of the conclusions of what we found is the human senses like the touch, the vision, and other things can be comfortably replicated using the technology. That sort of technology is available now. And using advanced mathematics, what our brain works can be reasonably replicated so that you have expert standing in front of every person to guide them on whether the disease is likely to happen or not. So here we are not replacing anything, we are just augmenting a normally skilled person to a better skilled person. This is where I call as augmented intelligence rather than artificial intelligence in the medical field. So I stop here because I have only 20 minutes time. I have 5 minutes to take your questions if you have, with the permission of the organizers. Yes, sir. I hope it is not too complex. Hello, good afternoon. Good afternoon.
Sir, I'm working in medical healthcare in blockchain technology from last 4-5 years. So, sir, the main problem we are facing the raw data sets. So, sir, in Indian perspective, because every data set is from the US and UK market and it is already 1 decade old. So, for the Indian perspective, from where we can get the raw data sets? Or if we are going through the government repositories, it is already set aside data and it is not more worthy for us actually.
The answer is very difficult. It's easy to write a code rather than getting the data from the government hospital, honestly. So I'll tell you the reason why. Because the medical language is having so many shortcuts. I can put an arrow mark up, that means increased according to me. So it's so much, I can say, synonyms are used in the medical terminology that even if a person is trying to use some technology to put it into the system also, it is very difficult for them. So getting the data is very difficult, but with the current application of electronic data capture, at least in the corporates, which almost 6% of the current corporate data is captured in a structured form. So probably down the line in 1 year or 2 years, you have the luxury of the Indian data available to you.
Sir, in open source directly is it?
Government is making it mandatory. The policy is yet to be out. Once it is there, probably you have the comfort.
Actually, sir, when I asked one professional who is a supplier of the medical data, so for 1,000 number of tuples, he will charge 10,000 USD.
That is curated data. So that is expensive, but I don't think government will allow that to continue in the coming futures because what I'm hearing, if it is right, it's going to be less expensive. Thank you.
Thank you, sir. Yes. My question is slightly unrelated to your presentation. I understand that the use of AI is well defined in identifying healthy in oncology, monitoring, and so on. So, but one question is that has there been these approaches have been used for detecting autism and mental health related disorders?
The answer is yes, sir. Right? The autism is something which is a spectrum. Autism is not a single thing. There are some behavioral changes like the sensory craving, so they require more sensations, they crave for it. The less communication, the mind is hyperactive. These things can be detected both by showing the pictures or videos of the kid to a system and then just trying to figure out what type of specific sensory. Few people listen to loud sounds or bright colors, or deep pressures. So these things, these patterns can be detected. It is visible. Work is being done. Couple of companies, I don't recollect the names readily, but I can give you those names. One is in US, another is in Israel. More importantly, regarding the use of gadgets. So all these are firing of the neurons. There is something like a headband which is available to see where this firing is happening, and you can exactly tell before the acute tantrum of autism is likely to happen. And whether your interventions are calming them down or not, you can actually track it.
So is there also some work on looking at the gut?
Gut microbiome is almost, it's the most complex thing, sir. A lot of attempts have been made. It's like solving the world hunger. Okay, so question itself is framed in a way where you never get an answer. Right? It's too complex, but yes, it is feasible, sir.
Good afternoon, sir. I really like your presentation. Just wanted to ask this question, as in, for example, let's say someone from a DS background wants to go into this field. How much of a medical background they should possess, or someone can just give it a try and probably get some patterns out of it, or is it some medical, background which does affect this?
Honestly speaking, medicine is the easiest thing to learn because everything is predefined in a very simple form, unlike mathematics where you have to apply your logic. If a physician can learn mathematics, a mathematician can definitely learn medicine much better way. Only thing is you need to be very clear what you are going to solve. You need to be very, very critical of accepting that mathematics can throw some nonsense answers, right? So I'm just giving you an example. It says that when your hemoglobin is low, hematocrit is also low, and you feel pain. So they mean same thing to me, right? So you feel that you solved something, but you need to be very open to the idea that, okay, they mean the same thing and it doesn't add anything extra to the doctor other than burdening with 3 more extra informations. So if your question and the target which you are going to solve are very clear, and that's what you need to understand from the practicing physicians, what is the pain points, then it is very easy to solve and it is not difficult to learn at all the medicine. Because the language is not too complex.
Thank you, sir. That was helpful.
Like they say, prevention is better than cure. Our generation, they are majorly affected by the depression or anxiety or stress. So, how can we use AI to, like, there are no symptoms that are seen outside. A person may be calm for the people who are seeing, but inside he might be having many things that he is fighting. So, how can this AI help to treat people like that, or to?
Right. I give a very classical example here, right? So in the COVID time, you must have seen that in the airports, thermal cameras are placed, right? They just trying to segregate or screen the people who probably have high temperature versus not. It is not like a proper medical grade thermometer, right? Medical grade thermometer will take 2 minutes to give you the reading. Whereas thermal screening screens 1 lakh people in 1 second time sort of thing, right? Similarly, when I'm trying to look the mental health problem, solving individual is different, solving at a societal level is different. We're talking about prevention, that comes as secondary part, first is identification. So there is a tool which I came across from one of the professor of AIMS, who is HOD of the psychiatry also. By 10 minutes of, it is 10 seconds of questionnaire, 3 questions are asked, and 25 seconds of voice recording, they can tell whether you are likely to have depression or not. So it is going to triage. Don't say that if it says that you are at risk, you already have depression. No. It tells that you need to go and consult a psychologist. So I always tell, screening is different from diagnosis. Right? It is feasible. 1 minute I think everyone can spend on themselves. I can share the website or the tool, how to use it. It's hardly 1 rupee per use. So they just kept some price for it so that it is not misused. I hope I answer your question, right? Thank you.
Hello, sir. A few years ago, there was a lot of talk about using AI on the genome to predict what diseases a person is likely to have as they go forward. Has this come into the industry yet, or is this something that people are working on?
Right. A super question. And first, I have to congratulate for bringing this particular question to me. I tell it's like building a building. Building a monument sort of thing. You need to start with foundation and other things. So the gene is 10 to the 25 things. It's too complex. A sequence of 3 letters will try to make a sense. It's called a amino acid. Bunch of amino acids will form a peptide. They form a protein. They do a function. That's what it happens. So one missing thing can be corrected in this long place. So one big place here and there doesn't collapse it unless it's a critical point sort of thing. So this is one part. So the corrective mechanisms at the end, our final point, are too difficult to be predicted at the gene level. Because the entire thing. So there is a reason why we move from the genomics to transcriptomics to proteomics to metabolomics to polyomics. So combine everything. So that is the future, not the genomics alone. That's one part. Second part, my most favorite quote, Professor V.P. Singh tells, the genes load the gun, lifestyle pulls the trigger. So unless your lifestyle is bad, your gene is hardly going to harm you. Right? So if you have a good lifestyle, 70% of the things which are chronic are preventable. 70%. 30% tobacco, 34% diet and obesity, and 4% alcohol, remaining all viral vaccines and other things. I'm just splitting that also, so what is that 70%? So, if you look in the larger picture, genes do play a role, but you know how to just cover that up. So, if one person is not there, other people can take over the work sort of thing. It's developing, but don't stop at genome. Have a bigger picture in you before you solve that. Thank you.
Thank you, sir. Thank you for sharing the advancements which have already happened in the AI area. He is a very busy practitioner, conducted almost 500 transplants so far. So with this busy schedule, he is still consistently contributing to the research community so that the patient care can be improvised. So thank you very much for your presentation, sir. So now I would like to invite Rajendran Kaushik Garu. He is a highly experienced healthcare IT leader who is currently a principal solution architect at Amazon Web Services India. He was a deep experience in healthcare and life sciences. He is a strong proponent of Indian Ayushman Bharat digital mission. So I would like to invite you, sir.
I think that was a wonderful session, Dr. Laudit. So I'm here to talk about, okay, how do you do something like what Dr. Suresh have been doing before? When it comes to healthcare, or generally speaking, AI as a practice, there is a sequence to things, right? You need to follow that sequence. And I'm here going to talk mostly about data and how you make your data meaningful for analysis. So then it is something that you can build your artificial intelligence or machine learning model and things on top of it, right? So this is what I'm going to cover today. Just trying to click it 1 second. So I do want to cover why we are doing this, why Amazon or AWS is interested in talking about healthcare. Just to give a small perspective, for close to a decade, I think we at Amazon have been carefully, or I would say, built a dedicated team of healthcare and life sciences specialists globally, and I belong to that team, wherein our mission is to enable healthcare organizations to improve patient outcomes by leveraging data, harnessing the power of data. And at the same time, we also want to help our customers to improve any kind of outcome by leveraging the data, and also to be able to truly digitize the data, right? That's what we work for. And if you really see the pattern that is clearly evident, that the patients themselves, I don't want to call patients anymore, rather consumers of healthcare services, have moved more from traditional sick care model. It's not like, for example, I have fallen sick and then I want to go and take a treatment from the hospital. Nowadays, I am seeing, for example, customers like mine, like from AWS, Healthify Me, Twitterfly, and many others, wherein they actually work on the premises of improving wellness, right? How do you improve metabolic health? How do you maintain your weight? How do you improve your many other parameters, right? So this is where I think we as a consumer of healthcare services are also moving from sick care model to more of a wellness model. And that's exactly what we see as a trend. And plus, we've been running e-commerce business for quite some time, and what we have understood is the same pattern or the expectations of how our consumers have on our e-commerce platform is reflecting very well in healthcare. For example, how many of us are actually searching for a symptom the moment it happens online? Many of us, right? Just go and at least search online. But, I mean, when you go and talk to doctors, fraternity has its own pros and cons. I totally acknowledge that. But the point is, we want the information on fingertips. We want to be able to consume services in a much more seamless fashion, like booking appointment, consulting a doctor, getting the prescription, and even like, taking the consultation and follow-ups and whatnot. How can you create this seamless experience of patient journey throughout the value chain of care, right? That's what is driving the consumerism. And if you really look at it like right from the symptoms search and from ongoing care management, data plays a pivotal role. And thanks for the kind introduction where they mentioned that I'm a proponent of ABDM. I am. The reason being, I can really understand or relate to the value of how that kind of an interoperability can enable the holistic patient data, longitudinal patient data, which in turn can help to build or improve patient outcomes. Now let's look at how to build that. So, for example, if you are entities who are working in healthcare or any kind of business, this is typically a journey. First of all, in healthcare, there are operational or transactional systems like electronic health record, electronic medical record, hospital information systems, and whatnot. Now, first is you have to solve that problem. You should be able to create digital system that can capture the data. Now, after that happened, the next step is eventually to build data lakes, or what I call is like, highly modern data platform that allows different business units to consume the data and interpret the data and also analyze the data in the way they want to. That's the second stage. Then the third stage is all about how do you use it for your building business intelligence. For example, one good use case at government level, what they're trying to do is population health. What if, let's say, population health doesn't have to be always at government level. What if we want to do like a care gap analytics within your hospital for a specific disease condition, right? For example, let's say if you want to analyze your cohort of patients for a specific condition, like for example, the risk of stroke, or what if you want to analyze your diabetic patient, or take any specific disease condition, if you want to work on top of it, then you should be able to build a population health kind of an analytics, and then which is nothing but collection of patient records, which helps you understand why some patients are doing better and why some patients are not doing better. What treatment works for certain patients and what treatment doesn't work, right? This is the pattern that one provider or a doctor or any caregiver would like to understand, so that they can course correct any treatment down the line for other patients. Now that's stage 3. Now then comes, when you have this data, is when the whole artificial intelligence, machine learning, and even the predictive algorithms like what Sarah has shown before, and everything will come into picture. And final outcome of all of this system is where personalized care is going to be there, right? Personalized care is what? What if by combining varieties of data, so for example in healthcare, right, I can broadly tell 3 to 4 different types of data. Again, there are more types, I'm just giving you 3 random. One is clinical data.
clinical data, by what I mean is my family history, allergy history, and present illness, and whole clinical data. The other type of data could be my imaging data. What if I've taken certain X-rays, CT scans, and whatnot? Then the other data could be from genomics data. And what if there is also other data, like for example, I always make this joke of people, definitely in Bangalore especially, if they are going for a BP or any kind of I would say stress or whatever condition, then I'm sure traffic has an impact, and they should be evaluating traffic pattern also in that region, which means air quality. Let's say if there is a patient who is coming for a respiratory problem, maybe air quality index of that region has a greater impact, right? So adding all these environmental and other data will also make sense. So that combination of all of the data will eventually help us paint better picture about why the patient acquired that problem or a condition, and how to approach that issue and create a treatment plan that is far more personalized for them. Okay? So in that context, if you really see, and also our models are evolving, right? I mean, the years before, we have seen models that can simply infer and give an output with just, basically those models were trained on like 20, 30 data points. But I think couple of years ago, we have seen models that were actually giving results for, based on the models, they are trained at like 200, 300,000 data points. But now we are seeing models trained in billions of parameters, or even now we are approaching trillions also very soon, right? Now the models are also rapidly changing. Why? Because the cost of compute has gone down, and the data set availability is there. And at the same time, how you can parallelize your training and simply learn and then put the model into use, like we have seen how LLMs can actually impact in varieties of industries, right? So those are possibilities that unlocks the value of data. Now, if you see, again, I didn't ask this question. Do you know how much of data in healthcare is unused or unusable? Just a random number, anyone? Sorry? Yeah, I mean, 60%, most of it all correct, but 97%. 97% of healthcare data cannot be used directly. The simple reason being, they are all unstructured data. And the reason being, 90% of the healthcare data is medical imaging data, right? So which means, how do I understand image? So you may think that, okay, what data is there in image? It's simply a photo. No, it's not that. There is so much of annotations and the diagnosis that were actually inferred by the practitioners like radiologists and others, which goes simply unused. Those are all added as a metadata to the DICOM image and never used, properly speaking. Now you take other data, like for example, let's say a doctor writes, again, sorry for the vague description, like, okay, Kaushik had fever, I'm just recommending or prescribing a paracetamol 500 mg for the next 3 days. When you type this, it is unstructured data. You cannot actually make use of the data unless you really process the data and convert this one statement where it is unstructured to a structured data set. So that is why I'm saying 97% of the healthcare data is unstructured data, and only through help of medical NLP, which is natural language processing, medical models, and other tools and systems, you can actually extract all this data, convert into structured data, and then finally put it into use. And again, there are 3 stages when it comes to building any kind of healthcare data analytics. Now, the first one is data interoperability. Now, this may sound boring for those who are in healthcare. In fact, Ayushman Bharat exactly is solving this problem. The digital mission solves this problem. Now, how it's going to enable you is, there are so many enterprise systems. If you go and talk to any CIOs of any hospitals, the first problem they say is, most of my team's time gets sucked into solving the API integration problem, payment gateway not working problem, and I'm acquiring new hospital, but their system is different, my system is different. There's absolutely no way I can standardize the data and operations and whatnot. So this is truly an interoperability problem. Now, what if you think about a world where, like, all your systems are actually built on standards? For example, in healthcare, there are different kinds of standards. So, for example, there are syntactic or schematic standards like HL7, FHIR, which is Fast Healthcare Interoperable Resources, or FHIR. And when it comes to semantics, which is the language or the vocabulary, like how doctor, for example, in the previous use case I mentioned, right, Kaushik had fever and prescribed paracetamol. What if you replace that with the ICD-10 code and whatnot, or RX num for the drug and whatnot, right? Now, we cannot put this pressure again back to the provider, but what if there are tools that can help you convert this unstructured data into structured data is where I'm going with. So your first enabler of analysis is interoperability. You build this interoperability among your system and outside your organization, like through ABDM system and all. So you acquire the data, and after you acquire the data is where you can build analytics. For example, you can enable quality-based indicators to be analyzed and cost-based indicators, and finally you will be able to build predictions on top of it. When you have this capability, is when you will be able to do the interventions. Intervention is where you actually build like virtual care. Like for example, even what if I send a reminder, again contextual reminder, not just about medication, reminder about, hey, you know what, after surgery you have to do certain things. What if I send or educate a patient very personalized way to basically like, you know, follow this protocol, clinical protocol. These are things that is possible only when you have interoperability and analytics in place. So, and how, if you look at all the hospitals, and I'm not blaming, it's just how any industry or domain would evolve. If you see, even many technology companies, be it telecom or aviation or any industry, right? When initially we kind of progress, we build data silos. For example, each and every application, like hospital information system, will have its own database. Now, when you're building a data analytics pipeline, then you are actually building a data warehouse with that data only. And there will be another data warehouse for another application, another data warehouse for another application. Now, for a true population health kind of analytics, you should be able to let them talk to each other. It simply doesn't mean that, okay, now I have 10 different data warehouse, I can copy all of them and put into maybe another bigger data warehouse and then query the data. It is a lot of expense for anybody for that matter. That is why if you look at the right side, the modern healthcare data platform advocates lake house or data mesh kind of architecture. Could be data fabric or data mesh kind of architecture, where the data doesn't have to be centralized. The data can still stay in the respective business unit or the application domain cluster, and you build a mechanism of letting your consumers access different data set based on the consent, based on the privacy and whatever policy that you have on top. This is what we've been broadly helping many customers build, this data mesh kind of an architecture. And again, you don't have to, now I'm going towards how Amazon is helping in, or AWS is helping in some of this. For example, we have purpose-built tools. If you look at AWS, we have historically invested a lot into healthcare industry specifically, and we have a bunch of purpose-built services. And I'll talk about only 3 services today. One is HealthLake. By the way, this service is available in India. It is going to enable any customer to build Ayushman Bharat integration. Now, HealthLake is a data repository and more that allows you to store fire-compliant data. Like I told, right, HL7 Fire is a schematic interoperability standards, and it allows you to store the data in fire format, which means you store the data, and it also exposes APIs that are standardized and can connect with any other hospital system or through ABDM also. You don't have to be in the business of creating different API standards and whatnot for your different customers. You are a healthcare startup or a healthcare business that want to connect with ABDM, then HealthLake could be a way. Our customers like EduTech, which is a known patient app company that is also using HealthLake to build some of that. It has a lot of capabilities. Couple of capabilities that I want to highlight is, one, it has medical NLP capability, which means if you send unstructured data in a specific document file, it will automatically run the medical NLP, will understand something like this. For example, in this usage you can see it's totally unstructured data. Like patient is a 62-year-old female with a history of type 2 diabetes and whatnot, right? Now here if you see in the bottom you see I would say graph kind of a relationship build. And this is not an illustration, this actually happens in the tool. There is a console where you can see this, wherein it identifies all kinds of entities. It is a named entity recognition plus NLP kind of a model, where it understands the entities and it also does the ontology linking. Meaning it understands the symptom, the diagnosis, the generic name of the drug, and the time, the duration, route, and everything. And this is exactly how you convert your unstructured data into structured data. Now, HealthLake as a service will allow you to do that by various mechanisms and strategy and add the data back. So when you query the data again to your system, you will simply not get the description but also the structured data, which you can use to build analysis. Now, again, as a concept, there are so many things that we can actually cover, but HealthLake as a service also help you to normalize your patient data. For example, when a patient walks into a hospital, there are like tens of systems that captures the data of the patient, like prescription system, administrative system, financial system, and let's say if they are an inpatient, then the whole lot of administrative tools are all there. Now, this health lake can actually acquire data from all these systems at a different time frame in a different frequency. Now, what if it arranges the patient data chronologically for you automatically and also normalizes the data for you? So that is a big problem today that many people are trying to solve, which is automatically solved in Health Lake for you. So when you put the data, Health Lake does all of it for you. So when you query the data back, it automatically is normalized and indexed for you. And it also has a zero ETL pipeline, which means you don't have to convert the data into again analytics friendly format. It converts into Apache Parquet and exposes iceberg table, which means it handles the upset and whatnot use cases. So you can immediately, in near real time, consume the same data, the transaction data, for analytical purposes too. Moving on, this is exactly what I told. The data could be from clinical data and the data could be from other databases. There are tools and mechanisms in which you can combine all those data, query and truly build dashboards. And yeah, these are some of the demos that we have built, which actually calculates the risk for stroke based on certain algorithms that are open source. And it's easy. I mean, you can do it in a few minutes. Actually, I'm not even talking about hours. And moving on, the next is imaging. And imaging also, like, we have a purpose-built service that automatically extracts the annotations, tags, and all kinds of metadata from DICOM images and builds a data lake for you. And then moving on, we also have something from the genomics or omics world, wherein we have this service that allows fire, DICOM, and any kind of genomics data. And then it creates a normalized data lake for you. This in turn can be queried or analyzed using our like I would say, analytical tools or AML tools for building applications on top of it. Okay? And again, I mean, this is slightly more for enterprise format. How do you actually create like a data mesh architecture? I think today also during open source panel, I talked about how many entities can come together and build like a federated learning architecture, wherein, for example, let's say 2 universities and a government agency want to collaborate along with the pharma company, and if they want to share the data, it's not that easy. There are so much of privacy and other conflicts that might happen. But what if you actually let the models being trained on the data within their environment and simply send the models in the weight? Collectively, you consolidate all of that and you have like a model with better weight and better inferencing capability, and that's federated learning for you. And it also has better security and privacy advantage, and the accuracy could be better and whatnot. So that's like basically the next evolution of what this particular slide is all about. So yeah, so conversion of structured to unstructured data is key in healthcare. First of all, digitizing the data is key. When you have this, then the ability for you to build machine learning models and everything is even a possibility. With that, let me stop and perhaps open it for Q&A. Thank you, sir. Thank you. Sorry, this is like a 2-day talk. I was trying to condense in 20 minutes. I think I shared a slide with 150 slides, and I had to skim it down to maybe 5 or 6. So, anyone, any question before the next session? All right.
Good afternoon.
Sorry? Yes.
Sir, Amazon EHR.
Right.
So is it open source tool or it is?
I think we are talking about Amazon EMR. EMR is Elastic Map Reduce. Basically, it's an analytics platform. It allows open source tools, like for example, the Hoodie and whatnot and Spark clusters to be provisioned on top of EMR. Just think of EMR as like the capacity, like a cluster that you can provision using open source tool for doing like a big data processing and everything on top of your data. So that's what EMR is. Yes.
So the health tech capabilities that you talked about, how transferable are they to clinical trial data? So data that we collect during clinical trials for risk-based monitoring,
right,
all of those things.
So your question is about how transferable, or is it, are you talking about how easy to move the data from health tech?
Basically, how can we use, for example, a program like HealthTech to inform
decision makers during clinical trials. Absolutely. It is actually meant for purposes like that. See, just think of calculate being used in a hospital where all the clinical data are standardized to formats like FHIR and in fact ICD-10 and put everything. Now, then what you do is you cohortize your patients. That's how you do clinical trials, right? Now, on the cohort, if you want to query specific patient's detail or specific symptom or a parameter, HealthLink enables you to do all of that. Now, HealthLink simply relies on the data that you push into it. It doesn't add intelligence on top of it. Of course, it adds through NLP, but that's a different intelligence. Meaning, HealthLink allows you to not only access data for analytical usage, but also transactionally. In near real time, you'll be able to see the data for your analytics. So it's pretty fast when it comes to how quickly you can access the data. And when it comes to standards, it supports semantic and syntactic standards. So pretty much most of everything is possible. Thank you. All right. Thanks everyone. Have a great evening.
Thank you, Kaushik. But we're only letting you go with the promise that you'll actually do the 2-day workshop for all of us over here. Thank you. Thank you on behalf of all of us. Thank you, Kaushik. All right. What we have now is a very, very interesting mix of panel. We are going to be talking about AI, analytics, healthcare. But what we have managed to pull off is a very different mix for the panel. Let me start by inviting each of the panelists. I'll start by first of all introducing the moderator for the panel, Dr. Pavani. Dr. Pavani is a pharmacological researcher at Aurobindo. I'm not going to say anything beyond that because my tongue will never twist to pronounce the words that they're actually speaking. I will allow them to introduce themselves in terms of what they're working on. Dr. Pavani, please. May I invite Vamsi Karatam, founder and CEO of deepfacts.io. Some of you would have listened to his talk. What they're doing is I would say groundbreaking work. Fantastic work that they're doing. I was super impressed by the work that they are doing. Vamsi Karatam, thank you for coming over here. And of course, how would I put it? I would have said the brain behind it, but Vamsi said it's the brains behind it. The person with 6 brains, may I invite Dr. Avius Suresh. I have no idea how to introduce him. He's an oncologist, he's an innovator, he's an entrepreneur, he's a racer. I don't know what else. Dr. Suresh, thank you for coming over here. He's one of those doctors who can actually program, right? And we have engineers here who cannot program. So just so you know, I am one of those engineers who cannot program. And thank you, Dr. Suresh. As I said, it's going to be a mix of different panels, right? So we have Nagendranath Garu. Where are you? Nagendranath Garu is he's a serial entrepreneur, investor, angel investor. He's a senior advisor at Salamander Advisory Services. He wears multiple hats. He's just coming, from running from a panel discussion where he was a co-panelist with Shobhu Yarlagadda and Srinivas Mohan, where he wore a different hat. Now he's wearing the hat of the as an advisor for Mediq Logics. He has his feet wet in almost every domain that we can think of. Thank you, Nagendranath Garu, for coming over here. May I invite Dr. Lakshmikant? Shortly I will probably have to call him Dr. Lakshmikant. He's a veterinarian, trained veterinarian, and hence I'm calling him doctor. And he's also finishing his PhD at the IVRI. He works on, again, some names that I cannot pronounce, some virology research and all. Better that they introduce themselves. Another doctor, Dr. Saket Sriram, may I invite him onto the stage. This is easy for me to say. He works on cancer research. I always say, when I say cancer research, it's not cancer-causing research, but one day he'll help us, cure research. I've known Sriram for a long time now, and he has always maintained that one day he will find a cure for cancer. I've known him for more than 20 years now. He's always maintained that he will work on cancer research. I hope we'll be able to give this. Dr. Pavani, over to you. May I request that we be done by 4 sharp? Okay. Thank you.
Thank you. So we had wonderful sessions talking about AI and integration with the healthcare industry. So you are experts from
different areas. Dr. Lakshmikant is from veterinary, sir is angel investor, then Dr. Suresh is coming from oncology, then Dr. Srinath. And Vanshikaratam was integrating the patient and the healthcare, he was working on the bridging them. So I just want to understand what are the problems which you are observing in your respective areas and how technology or AI can solve or address these problems. So can you please explain about that? Dr. Suresh.
Yeah, so one thing that most of the doctors claim is they don't have time. And that's true also, because most of the doctors overwhelmed. Each patient comes to the bunch of records for last 8 to 10 years. So it's very difficult for us to compile. And one thing that I'm really enjoying nowadays is last 2 years in my hospital is everything is available at a click. We call as an iPlatform, that is healthcare, networking, intelligence, and artificial, whatever is the full form. But still, a graphical and easy representation is making me happy. So I don't call it a very advanced way, but we don't require very advanced tool also for these things. So make it easy for me.
Problems we see more into is the capturing of data. That's where we see day-to-day when we try to capture data. It's not good as Kaushik was talking the last talk. The data is not clean every time. It's going to be a mix of it. Here the cleaning of data is really a challenge, and also it's going to be it needs to be streamlined in a way, in such a way that easily can be modeled, trained, and taken to the clinic and also the challenge. That's where the problem is.
Actually, I have a more, I would say, helicopter view. I think there are, as an outsider looking in, because I use the healthcare industry as a consumer, I think, and also because on the other hand, we were helping startups and others, I'll tell you what I look for. See, there are 5 areas broadly that have got issues. The first area I see is skilling. When I speak to friends in Siemens or all these companies that make medical equipment, even the best of equipment that a hospital can afford, they struggle to find time of the doctors to get trained on it. Forget the other support staff. That's number one. Number two is already raised the point that for improving quality, the basic is to have clean data so that you can have the right metrics to measure. That itself is a challenge. The third one is operations. Most hospitals all over the world, and especially in India, are actually from doctors who turn entrepreneurs. Their skill is patient care and not in running a hospital. So there is a lot of operational inefficiency that is hidden in the operations of the hospital that directly affects patient. Fourth is governance. There's not much of a governance framework that exists. So that is a challenge as well. Like, how do you know hospital A is better than hospital B for somebody to go to? We don't know today. There's no common way to see and there's nobody governing. The last one I see is leadership in this. Most of the leaders we see in this industry are leaders by accident, not by training. They've learned the hard way in life and come up. And now others look upon them as iconic people to lead. But there's no system to generate leaderships. So to me, all these areas, except for leadership, which is a very special trait, can be solved by technology and can be solved by AI. And for a country like India where remote diagnostics, remote healthcare, how do you get patients out of the hospital quicker so that the beds can be used for more critical patients? There's so much that can be done. So I think there is enough opportunity.
Thank you, sir. Dr. Lakshmikant.
Good afternoon, everyone. Being a veterinarian by nature, I am not that well into regarding data and updating and all. But in my view, I see these things in a couple of ways.
One is that when Sir said that there is no time for doctors, for us we are short of doctors itself in the very remote and ground level when I am talking. So the number of animals, the livestock that is exponentially growing, farm animals, and I am just quoting, not the pets, because the economy is majorly driven by livestock, agriculture country in India. So the amount of availability, there are efficient doctors, but whatever changes or whatever the updates that were happening, let's say I was reading about the AI diagnostics, right? The infrastructure is very low on a very village level. But if only all this data, whatever they were taken and they were built, if that can be able to penetrate the very low level places, that would act as a real game changer in the livestock health sector, right? And also on a research front, now I am working and I'm a PhD scholar in the National Institute. I am unaware of the AI tools that can be used, right? So I wish there is more of like what we call as an extension program in agriculture, right? So I wish somebody makes us more aware regarding this can be used, that can be used in particular things. So that would make us really a better researcher.
Yeah, that is the one which is lacking, which need to be, where Swecha also want to intervene there. Dr. Sriram, what is your opinion?
I would want to touch base upon one extra point on whatever talked through here. So we do have a huge amount of data. So it's not like we don't have a lot of data. Sometimes it is organized as well. So for example, we had the human genome project that was completed in 2007. We have like say at least 450,000 patient genome samples that have been analyzed completely, total RNA sequencing that is being done. However, we still see like at least 10 to 20,000 research papers that are being still published every year, having a small part of that data coming again from the human genome project. What it means is that although we do have a huge amount of data, the interpretation of the data and how we look into the data is still in the preliminary stage. That's what I feel. Like we are still just scratching the surface. So we need a little bit more expertise into how to completely deep dive into the data. Again, we need an integration of scientists as well as the data scientists over here. We need a huge amount of integration to get into deep dive into the data, and I feel that is something which is absolutely useful to get out of the smaller issues, whatever we have in the AI, and helping with the
Like good that you have brought up the issue of whole genome sequencing. Yesterday, Dr. Tangaraj was here, who was trying to sequence 10,000 genomes from Indian population. So mostly the sequences which we are talking about are from abroad. So the ethnicity is different. So I just want to ask Dr. Suresh, like, is there any diagnosis possible for Indian population based upon the data which is generated from the different ethnicity, and how much of such kind of work was done already, and what is the research going on there, sir?
So this question was already brought up with one of the people from the audience. So genomics is something very important. You always understand that. Here the gene is very pathogenic, very predictable. I can give good number of examples, but common thing is BRCA and breast cancer, which were shown that after a finite point of time, it is likely to have existence of breast cancer. And prevention is not always stop disease. So there are 4 areas of prevention which I want to draw your attention to the audience. Primary prevention, that means stopping disease to happen. That's what I'm doing. Secondary prevention is stop the big surgery to happen, a big treatment to happen. Tertiary prevention is stop the damage and treatment and disease to happen on the patient. Whatever means disease is gone, the side effects of the treatment is there. So the genomes help in a long way, not only preventing and predicting what cancer is here. Now I'm using the genomic data to see what drug will cause what side effect, because the common genomics. Whether the side effect is reversible or not, whether the drug will act better or not. So, which is very unique, is a combination of the patient, gene, drug, and the environment. So this complexity is humanly impossible to
to be solved with a rule-based algorithm. It requires much beyond a way. Very definitely can help. And the genomes, if it is done specifically addressing each question and looking into them, is definitely going to be game changing. And we are already implementing it in terms of what treatment to choose, what patients have to be screened once in 6 months, once a year, and how to take clinical decision, how aggressive are you going to go. It is a practical.
What is your opinion? So,
in my from last 4 years of my journey into the medical device and the platform, it's an everyday challenge. Yeah. So whenever we go for collection of data, this is we are planning, distribution, everything. So these things we see the data available, the data available is outside the country, not inside the country. And that we trying to that data, but it's not going to be accurate enough for sensitive enough for us to handle it, because our demographic is changed. So if you go towards Andhra, we have a different set of body structure, and the data is not changed. Come towards Telangana, the other side of Telangana, they may make different the body structure, the data is different. Here, the challenge is that so we don't have a particular repository for the data in the country. So we depend on MIT or some other databases. But India doesn't have a standardized repository to handle. We find some, but not much. I think from 100%, I say we have around 3% to 4%.
okay. Thank you.
I'll pass this question. Is on outside my experience.
Yeah. So, the advantage in genomic sequencing is in US, for example, it has been privatized completely. So you have this ancestry.com, 23andMe, which does the sequencing for anyone who wants to get it done. So you can see ancestry, where you are from, how much percentage of black you are, how much percentage of African American you are, Caucasian you are. So when Kamala Harris did that, and she said like I'm this thing, and when other people said that, people laugh at it if you don't have a statistical comparison to exactly get to whatever it is. But then the important thing over here is that because of this privatization, a lot of people have sequenced their thing. We do have a huge amount of data. Maybe it is with a few certain private players. You can bring it to the actual core whenever you wanted to. But then it has been done over there, and people know like what are the issues with the sequences of say Caucasian or African American. But we don't have that in India, so I'm all for having more sequencing in Indian population, and it definitely helps out to unlock future perspectives of what kind of diseases we are more prone to, and what kind of treatments we are actually favorable for or non-favorable for as well. So it helps us out.
Yeah, that's.
Just to add that we are in the process, I'm sure you know, when IGIB is doing a lot of work, it just made it stand. The problem is libraries, against which we are going to compare. Libraries. So the genomic libraries, we don't have any standard libraries available in India so far. So I mean, if the comparison is wrong, the answer is wrong. So that's why we.
I just wanted to leverage Swecha. That's why I wanted to raise this. My cousin who lives in the US is a true blue Godavari girl. When she did this, because she's working in one of those companies, she found some Afghani blood in her ancestry. Right? Right? So the thing is, with organizations like Swecha, if you really want to do this, you know, that the ability to collect, collate, standardize, and get libraries will become like, you know, the speed at which it can be done, I think, is an opportunity for organizations like Swecha. That's all I want to say.
That is rightly said, sir. Like genomic sequencing is involves a huge cost. Where data analytics definitely Swecha and other IT industry where they can pitch in.
So just want to understand other thing like is there any existing AI tools available in healthcare industry and how much they are solving the problems which we have discussed earlier? And can you please throw some light on UHI, which was the initiative taken by the government, and structured data? So, is it possible to bring structured data to implement in all the hospitals? So, I want to start with Dr. Suresh.
I asked 27 questions, right? Which is beyond comprehension. So let me just try to pick up a couple of questions and read the remaining things because I'm losing time also. So question number one, are we using AI tools? Definitely yes. So most of the people, I think I hear with the fascination from Dr. Kaushik that use tools to explain the patient. Okay? You have, say, brain cancer or breast cancer. These are your characters, like estrogen persistent symptom, or maybe a GMP brain cancers. So because you have ABC, E is likely to happen in this frequency. My treatment is going to offer X amount of protection. So we are uncovering them. Okay. If you want to say no to the chemotherapy, you are free. But you know that 15% are compromised and cured. If you want to say yes, then 3% extra side effects you have to weigh. So these tools are free level, like Predict Rest is some tool which we use. Life Math is what we are using it. EURPC calculators we are using, MATLAB we are using. I can just tell at least 40 calculators which are using almost on a daily basis. So can I call it as an AI? Yes, it's like a vehicle. I mean, starting from the bicycle to the aeroplane, everything is a vehicle. So it's a very primitive form that we are using so far. But it definitely is solving a lot of problems. In convincing the patient is also getting more confidence. He feels that we are also. That's one part of the story. Are we using it or not? To what extent it is really helping us? Counseling, definitely yes. Decision making, partially yes. Changing our treatment or throwing new light in the new avenues, still in the infancy, is what I can sum up. The other question that you have asked is regarding standardization. Standardization data. The beauty is like poetry, medicine is like poetry, the beauty is the art and science they call it, right? So the art is we want answers. Then only we are well trained. We don't want any standardization. So that's the reason why we don't have standard data systems most of the times. And scientists want us to build a beautiful and a perfect block, and we make a bizarre brick sort of thing which doesn't fit you, and you need to be really artistic to see and imagine how to just fit it into that particular place. So the difference of whatever is outside this square actually is vital. Okay, that's what makes response or no response, side effect or no side effect, that helps to build a new drug sort of thing. So this is where I think accepting the anomaly as it is and then putting it into the system will help for the better research. So let's not try to standardize the anomalies and then just make them sort of thing. So it is possible, but capture assets. No standardization. That's my opinion. We'll be open for the other comments.
Dr. Ramsey, can you please throw some light on what are the AI tools which are existing other than what Dr. Suresh was discussing?
Dr. Suresh was telling more about the
oncology side, yes.
We come from the medical device side.
Okay.
So there are AI tools available. They're open to tools also available. And yeah, they are there in the last 10 to 20 years. We matured now enough, but they're not from India. They're from outside of India, but they're mature enough. But here, as I said, here we can take that on the inspiration and we can build our own tools on the top of it. But again, the data comes to the picture again. We find our own data here. That's the main part of it. Everywhere, AI is very helpful for the doctors as well as for the patient. But the challenge
talking about something very fundamental, actually. You're going way ahead of where my comprehension is. I think specific to our country, even basic standardization of nomenclature is not there. If you get a medical test in a diagnostic clinic A and go to hospital B, the codes they use will not be the same. So the ability to know what happens. So I think there's a lot of many initiatives across the world. You know, there's ICT, then there is RX norms, so a lot of things are there, right? The national mission, the national health mission that was announced, trying to standardize a lot of things. So to me, I think unless at this basic level, everybody talks the same language and uses the same nomenclature. I'm not talking about force-fitting anomalies into, it's like, cutting the foot to fit the shoe. That is not what I am talking about. I'm talking about some level of consistency across the country so that it becomes easy for people to understand. And I think Dr. Gaurav Raina is working on a health stack for the country. And I think when that happens, if I, as using that app, can decide I want to talk to a doctor in Varanasi because he's good at something, sitting in Udagamandalam, UP or somewhere, and I want to share my reports, it should be in a nomenclature that is easy for them to understand and standardized. So I think that level of at least standardization is what the country needs, and that will significantly improve the quality of healthcare. That's my personal opinion.
So I would deviate from the topic a little bit. I would not talk about the patients and this country, I would say. I would touch base to the pharma industry and drug discovery.
Okay.
So how do we do a lot of AI-related iterations in drug discovery? We can actually structurally have this enzyme pocket where you have the compound combined to have the relation to happen, and so thereby have some effect on whatever it is, and then thereby able to receive for a patient. So we have all those technologies from a long time right now. We can have this active site pocket of an enzyme, can be computationally driven, can be seen on our computer, and then we can design the molecule to fit exactly into the pocket so that it does whatever it is supposed to do. So we have all those technologies before. Now we are using AI-based iterations, machine learning, so that even we don't need to give a lot of input to it to have a proper molecule. You can design a molecule without even having a single manual input to it. You can get a proper molecule that has all those features, whatever you want it to be. You need to have some solubility, you need to have some good absorption, to have, and then you need to have the activity for those molecules. So you have multiple ways you can run AI in a drug discovery setup. That is just one part of it I'm talking about, but since that is the first part of the drug discovery setup, I'm just talking about that. You have multiple places where you can run it. But then how do you improve upon is a completely different science. There is a huge space for improvement. We can improve upon it.
Right, as you said, it is the early phase of drug discovery.
Absolutely.
So there are a lot of gray areas throughout the pharma sector which are still open for AI development to be happened here. Dr. Lakshmi.
Just sort of saying that, I don't know exactly the terminology, this is AI or not, because we have a bunch of softwares. Imagine if I am doing the research, we are designing primers, we are going for cloning, we are going for all the cloning in eukaryotic, prokaryotic things and NDB cutters. So these softwares are there for a very long time. So if this is AI, I'm not sure, but I wish there is the AI comes into play where it helps us more in the interpretation of all these things. As a very young researcher, if you push me back a couple of years, I look at something and I'm not sure what is happening in that particular screen. So imagine someone or AI on any basis, if it is actually suggesting this is what's the direction that you are going. So that would actually push us in a better space.
So just to add what is said, that's what most of the regulators are looking at. So they want AI to be explainable AI. Unless your AI tells why it is telling so, what it is telling, what is the basis of the recommendation or the conclusion, and how far it is accurate and where it can fail. Unless it is very open, it cannot be used in fields. So that level of regulations are in the process of being implemented across the globe, including India. So we are just 18 months away if things go at the pace at which it is going. The target is 2027, but we are ahead of time.
So that is what the question I was about to ask you, like is there any regulatory guidelines, but as per you, it is not still under the process of development?
In US, yes. In India, in US only partly yes, it's not a complete yes.
So whatever the tools which we are using currently, the tools which you have said also, are they validated with the patient data for verifying the outcome results and all?
So, okay. So I'll put it across. AI is very broadly used. Simple Bayesian trees are also called AS. Definitely, I don't want giving the particular methodology of so, but this dichotomy, like you have an age of 40. Okay, you ask the next question, diabetes there or not? Then yes, hypertension there or not? Then you say your cardiac risk is high. That's what the doctor thinks. That's what the AI does. So this is simple. So this doesn't require, because these are all medically validated outcomes. They are just putting it into a user interface which is easy to interpret, easy to understand, and then some nice figures. They are able to convince the patients. So this, if you consider this as AI, they are valid. If you are talking about more complicated things, like a big score at week 32, a pregnant lady is likely to develop hypertension because of low hemoglobin and high sugar. No, they are not validated because it is based upon 1 lakh patients data pool on the behind, and they need to undergo very rigorous implementation checks.
Thank you, sir. Dr. Ramsey.
On the regulatory side towards AI, in India, they're coming up with a policy, but they're not fully regulated. It's the same in the US and the other countries as well.
Who are those regulators who are governing these?
So India is Central Drug Control Side Board, CSO, and if you take US, it's an FDA.
AI is considered as device by definition.
Okay, so I just want to understand, like there are so many problems. So there are a lot of young investors and researchers are present here. So for them to take up some issues, what are the issues which can be readily taken up? So in your area, which are the hardest? So for them to study and generate some tools for them. Dr. Lakshmikant also, like he was working in agricultural industry. So
Yes, ma'am. I got your question. There are a bunch of things that's coming into my head. I just throw them the ideas. So definitely one thing is, the first thing that I said is imaging or the AI diagnosis in veterinary field. That would be really helpful if it goes deep down. And the other thing is the livestock sector is plagued with very frequent outbreaks of diseases. Like there are FMD diseases. Recently we are plagued by a disease called as lumpy skin disease. So whenever the animals are hit by this, there is serious loss of productivity and the economy. So, but there is a lot of epidemiological data. There is a lot of risk factors that we know. So if only we can club them together and we can predict the next outbreak, or at least that's a gentle push forward. So that keeps the health sector ready on a livestock basis. And also, I was thinking on a very remote level, just like now we have quill bots and chat GPTs to write our theses and research articles. No shame in saying that. So we can also have chat bots for a farmer level. We do not suggest treatment exactly, but even a life hack or I'm saying on a health hack for an animal care or a health hack for an agricultural care. I don't know if it is really there. On something on that front would actually access them or empower them in a better direction.
So one thing that is close to my heart is the pathology reading of the slides. I've given the talk on the AI and digital pathology. It's a very wide field and has progressed a lot in the recent years. However, I would still feel like image-based interpretation of, say, cellular-based evaluations is far more developed than what a pathology-based evaluations are.
especially if you increase the complexity by staging more, like not just the HLE slides, but say for example, immunofluorescence based staining on top of HLE or things like that. We do not have a proper setup of a holistic and comprehensive software for evaluating everything. All we do every time is go to an open source, pick a part of the code, and then copy that, and then put it in ChatGPT, and then modify whatever we want it to be, and then try and see if it is working or not. I do it every time, every day of my life I do the same thing. I just go to Google, pick a part of a code, and then try to see if it can be implemented. I can't do it myself. I am no coder for sure. So that's how we do it. I just modify a part of the code. So, however, for mostly in vitro diagnostics and things like that, it is pretty well done. I don't see the same thing for pathology-related slide readings and things like that. There are a few companies that are currently working on it right now, but I would want to see the
keep your mic closer.
I would want to see the field develop a lot more faster, because that is something which is of a tremendous application in terms of patient treatment and survival rates.
So, like you are an angel investor, like there are a lot of IT professionals are over here and researchers. Do you have any suggestion for them to pursue the career in AI, and what is your suggestion for them, sir?
I think there is, first of all, AI is so broad-based. They can work in any industry. This panel is not limiting them to this sector, number one. However, if you are interested in this sector, I think, see, AI is a skill. You have to have passion for that industry also. Otherwise, you know, you'll be an ordinary person in a team of extraordinary people. The skill is cheap. AI is telling us that skill is cheap. Like no more coders are, he doesn't even know to code and he's picking up code and, you know, everything else. So for me, for the people, what I would say is, look for, if you're an entrepreneur, look for interesting problems that are low-hanging. Don't look to, you know, shoot for the stars. There are enough small problems that can help people. He raised a very good point. If there is a hack for a farmer in a local language, even if it's a question answer bot about welfare of their animal, that is a phenomenal advantage for them, and that can be probably created in less than a year if you collect all the data and, you know, you can get it. So there are enough problems to be solved. I would think that if you're an entrepreneur, look for problems that can have immediate return, because that gives you the high. If you're a researcher, of course, you'll do like what he's doing. That's a long-term thing that you would do. If you are just a practitioner of AI, have passion to be here. Otherwise, this is not the place for you. Because success rate here, you know, is 1 in a million finding the right molecular combination and things like that. So it's not an easy thing. So you should have the passion for this industry.
Can you please throw some light here, like what are the tools we can take up? Do you have any suggestions for since you are also one of the entrepreneurs, so
the most important part, of our entrepreneur journey in healthcare or in AI is the patience. That's the most important part. It needs to be there for the founder, because every day is a worst day. It is a good day, it will be a party in the evening, but it's not going to be every day a good day for us. So we have to be more patient in that, because the cycle time for the success in the healthcare or in the medical device platform or in the AI, I'm talking about only on the healthcare side, not on the other side of the industry, but it takes a minimum of 3 to 5 years, depends on the use case. And as entrepreneurs, the first thing we need to keep in mind is what is the worst thing going to be happening with the lab. We need to come from there to see that how we can break that and push it forward.
Okay, yeah, thank you. Sir.
One final word which I like is, you know, the ambition should not kill the common sense when we are doing the research. the best answer is always find is one of the second year student taught us on the fall detection code. I'm still surprised. A lot of equipments are there on how to detect fall in LLP. So if I have to define the fall, you have XYZ axis on the stand up, they become 0. When you fall, it takes 5 to 6 seconds if you want to purposely lie down. But if it happens in 2 seconds, it means you fell down. So till that time is coder's job or a medical device job. But the intelligence comes after that. So most of the vertebrates stand up. When they fall, that's the reflex. If that doesn't happen, that means I prevented one falsana. And if I don't deliberately stand up because there may be slippery floor or dark surroundings, that means my brain sends a signal to my heart and it says, calm down, things are okay, but you don't stand up. That means HR will get sick. And if that is second prevention of the fall detection, then again comes the coder's job. Okay, if it is a significant one, send it to the ambulance and a neighbor and caregiver. So this is all common sense. So this is nothing like a great science behind it. So unless you are very vigilant about what things can commonly be solved rather than trying to develop a very fancy code, then you don't come up with a good product.
Thank you, sir. So I have a question for Nagendra sir. Do we have the scope we have already discussed, and what are the funding opportunities available for AI-based innovations?
I think there is always funding opportunity, in my opinion. So long as you are solving a real problem and you hit the nail on the head, ultimately the patient is God. The patients vote with their feet, whether they vote with their pocket or not. Like, even if you give treatment for free, they will not come to you unless they, so it's nothing to do with voting with their pocket, they vote with their feet. So if you're solving a real problem, enough funding opportunities available. Most of the time, what I found in my experience over the last few years is, entrepreneurs fall in love with their idea and product and lose sight of practicalities. And that, I think, is something that they should be careful about. There are enough people who throw cold water on them every time they go and ask. But I think it's very important to keep that in mind. I would again and again say there are enough easy problems to solve before you take big problems to solve.
That is nice, sir. Thank you everyone for participating in this discussion. So we want to take few questions from the audience.
Please introduce yourself and which panelist has to answer also. That makes our job easy.
Hi, this is Bharat. I work for a software company called Technologies as a project manager. I just wanted to understand, I work in healthcare domain as well, clinical trials and other stuff. So, we know, recently, stem using stem cells, we can create artificial organs and all, in near future. So, as a doctor's view, where do we stand on that? I know that.
I think that is for me. Yeah. So the answer is very simple. Not in the near future, right? Stem cells can create a beautifully functioning cardiac muscle. But if this part of the heart is contracting and this is not, so they are not in sync, then output doesn't come. So creating the organ is easy, making it functional is easy, integrating with the existing system is impossible. Wherever it happened by accident, not by design. So accepting for the organs like blood, where they can function in isolation, no stem cells have worked. So stem cell transplant work only in the organs like bone marrow transplant, where one RBC need not coordinate with other RBC to carry oxygen, or very gross things like bone, where you just have to bear the weight. So accepting that wherever it requires a complex coordination will always fail. So something have to happen, a miracle, for the sensors to come into the real time.
Thank you.
Hello. Yeah, hi. This is Hardik from Sama. So currently we are also working in clinical trials on it. But I want to just check the different side of AI. I have read one article. It's called like behavior change. The doctors were using the AI tools for diagnosis and all. And later they realized like after 2 years they were performing the nuclear scans were reduced from let's say it was around 40 to 50% they reduced the scan because they were predict the AI tool what is predicting. So in that case they have misdiagnosed certain patients. So like how to do like in our regular life also if we see right we can't do like basic multiplication also because we used to calculator and all. So when like all this AI will come, so how like human intelligence will be downgraded and the human touch in the care and all. So how we can deal with that also?
Again to me?
Yes,
I know.
yes.
So thing is, AI according to me is not artificial, but it is augmented intelligence. As long as you try to enhance your decision making for the better patient care, that's okay. If you are trying to replace it, definitely a big no-no so far. So please don't attempt that, and that's what will happen, what you told. If I trust the AI that this patient is unlikely to have a recurrence, and if I stop doing a scan, if the patient comes with a disease bad, then I'm the saddest person, so as the patient's family. So we don't deviate from the conventional wisdom and conventional treatment. At the same time, we try to improve on how to interpret the scan better rather than how to avoid this scan. I hope I answered your question.
Hello sir, I am Banu from Biomedical Engineering. So I want to ask Dr. Suresh sir. Sir, as you mentioned, as per regulated thing, AI is considered as a device. So how we have to look at it? Like, is it good or bad? Like, why not as a tool or something like protocol? Because
tool and protocol doesn't go. See, the problem in India, I'm not an expert, but I definitely would like to see some of the inputs from the patent lawyers. In India, the code is not patentable unless it is in a device. Whereas in US and other countries, it is patentable. So, because the device is patentable, it is regulated, so the code has to sit on a device. So, it is more of a law that is making it to happen rather than why it is a device. It is otherwise. So, the same law controls both device and the code. So, that's what is the logic why it is put under the device stack. So, because more of a regulations in terms of law and enforceability and IP that is making it to happen in this direction. So I don't see any reason, but probably some of the regulators can help you to answer in the right way. But whatever I told, I do attend few of the CDSO meetings, so that's what I gave.
I have one more question, like about the standardization. So if we can look this into two ways, like the practices which would be followed, like the protocols where collecting the data would be like two different ways. As you mentioned, it would not be standardized for all. But can we, if there is a possibility of collecting the data in the standardized method. Like
That's what sir is telling. That's what even, I completely agree.
Right.
I have to measure the speed of a car either in miles per hour or kilometers per hour. Unless I do that particular basic things, I can't keep on modifying my sporty motors or automobiles. Right? So you start with basic standardization and on top of it you modify and then improvise. So basic standardization, no brainer. It has to be done. No choice.
So if we are not standardizing the practices and still we are standardizing the data collection process, so how would it would affect the data quality?
Right. So the practice cannot be standardized. It has to be individualized to the patient. That's why the AI is trying to solve the problem. How can they personalize the AI to you? See, basically, the outcome decides the practice, effectiveness of practice. The moment you have standardized data and you also are able to collect the outcomes, then you will be able to know that this particular set of practices, right, are good or not good. Right? That's why age-old home remedies still work at home. Because of this historical data, we know that if you get cold, you take some turmeric, something will work, right? So practice is different, right? But if you can measure the outcomes, in fact, that's what a lot of people around the world are doing now, whether they're governments or regulatory bodies, to say there is this movement called pay for performance that's happening, right? You doctors know. So this is nothing about practices, and I agree with him totally. Practice is based on experience. It is also based on a moment of inspiration, right? Because, correct, right? So it is so important that you can't take that in.
Yeah. I have a question to Dr. Lakshmikant. I mean, from my side, so we are seeing how AI is really helping the human sciences and how it is treating in a better way or diagnosing in a better way. But coming to the animals, I hope you might have seen in many places, there could be times where it might be hard for you to diagnosis or treatment the animals, right? So is there any day that maybe this technology or this AI could help this diagnosis, could help this in treatment to the animals? Are there any situations that where you have thought maybe this technology or this AI might have helped these animals in diagnosing faster or treatmenting them faster?
I got your question, but to even answer that, I've never used AI to say the AI would have been better here. So that is the area where we are in so far. But to address it in a different dimension, I've given a lecture in the morning where I felt antimicrobial resistance is a serious threat from our particular livestock industry. Many times I had a very small clinical, how would I say, career. So I felt like whenever I am prescribing an antibiotic, there are only a couple of things that are clicking my head. I wish we had AIs where it suggests an alternative, where it can actually bring in data that this particular, your area is actually having more resistance for this organism, better prescribe something else. Or you can actually, let me give it a 3-4 options, like these are all there in the market. The first thing that always clicks into our head is the only thing that we write. So I wish that kind of a support, if it really comes, it would have made a game-changing difference to tackle AMR is what I always felt, and I'm still feeling.
I just want to make a suggestion which is probably not good from my point as what I'm wearing. Let's not think everything is AI solvable or we need AI to solve. Because for a man with a hammer, everything looks like a nail. Right? There are, maybe we need a shoehorn, maybe we need a wrench, maybe we need something. AI is just one of the many things that we have. So I just want to suggest that collectively that, you know, AI is just one of the many things we use, and it definitely has a lot of potential, no doubt.
Hello, good afternoon panel. This is Dr. Santoshi Shugarma from BVIT Nasapur College. I'm assistant professor here. And sir, my question is for that people are working in majority of the students are working in Raspberry Pi and Arduino boards. They are working, work with physical sensors, which is in generally Chinese supply. So we are not getting proper result. And even in my doctorate, when I pursued my PhD, so we are working in that domain also. So we are facing the challenges with the physical hardware sensors. So because that sensor is substandard sensor, so that's why we are not getting the proper result. And if we are compared with the Chinese sensors or the low-cost sensors like BP monitor, which is cost around 1,500, so it is almost more than 20 to 30% of the result sometimes we get. And even in if we are talking about the rural areas, so majority of the practitioners who are they are not basically MBBS, so they are GMP practitioners or some kind of supportive staff. So they are using the same medical devices which cost not more than 2,000 rupees for the diagnosis purpose, and the result is affected more than 20 to 30% around. So for that, in Indian perspective, if you want to try something in hardware perspective. So from where we get, because in generally I try from many of sources, but I can't get a proper sensors which is affiliated from any of the companies like Siemens or Philips, or they are not actually supplied in the Indian market, even in Asian region also. So for that, what we can do?
Let me divide the question into two. One, you're talking about the sensor.
Okay.
Yeah. And the second is you're talking about the result.
Yes.
Right. So sensors, India doesn't have a capability to manufacture or design sensors.
Definitely, it will take almost 1 decade.
Yeah, more than a decade.
Yeah, actually, I agree.
Yeah. So sensors, what you are procuring from maybe from the China or from locally, are more of made in China products.
It is all from the China supply.
So here the selection of sensors is also very important. So we have to see that if they've made it, where the company is from. Okay, if you take a company from US, let me say a maximum integration or analog devices. Yeah, if you call analog devices, they're procuring a sensor from analog devices. They provide what is the standard they are maintaining. If you take the data sheet, you go through each and every point in the data sheet, you'll have a detailed explanation how the sensor works and in which conditions it works. That's also very important for a prototyping or a POC to be tested. Yes, that's one part. And the second part, when you're doing a POC or a prototype, it's almost like a raw development. I don't say it's a finished development. Yeah. So in the scale, I mean, in the percentage of 100, the development is only 15%. If you take a POC or a prototype 1 or prototype 2. Yes. So after MVP, I'm talking about minimum viable product. The MVP reaches by 30%, right? After that, 30% reach 100% as marketable product. That's where you can see the result. It's not going to be easy to say that, okay, I've done a POC or I've done a prototype 1 or 2 and I'm ready with the minimum viable product and I can take it to the market. It's not going to work out like that. It takes lot of time and energy to see that from 30% to 100%, it takes lot of time. Exactly, that's one. And coming to the second part of your question on achieving the accuracies and all the maturity of the product development also is required to get that accuracy level. You have to fine tune the device in such a way that when you're going to one region to collect the data and doing the testing or the validation, you have to fine tune it in a more, the fine tuning is the most important part to get the marketable product.
I just want to add one thing. Don't underestimate the affordability of the, whatever the medical practitioner in the village, because I see this constantly trying to bring the cost of the product down and pay for quality instead. I am sure the incremental cost will more than help the practitioner to get more clients. So I don't see that as an issue. I think he raised the good points. Cost of product is only 20-30% in the overall scheme of things. So I think if you're guiding them, sir, please make sure that they have the first prototypes of the best quality. Then you can choose to do how to do the value versus price and all that. Otherwise, we'll end up building subpar products.
Sir, actually, sometimes we try to communicate with the Philips and Siemens also, but actually, for the starting prototype, our cart size is very limited for the getting the sensor. So that's why they are not interested to winning with a business. That's the main problem I face.
Okay, Thank you for the question.
Okay, fine.
We have one-to-one interaction with the panel speakers. So I thank every one of you. It is a really interesting discussion we had with you. Thank you, sir. Thank you, Praveen, for giving this opportunity for us.
Thank you
all the doctors on stage, and everybody. That was a very informative session. Lots of questions. I know there are more questions, so I would request that the audience please talk to the panelists and speakers after the conclusion. We are now we've had two really wonderful days. We started on a high yesterday. We started. And I remember yesterday what we had 2,500 people filling this hall, hundreds of people standing outside. We had this wonderful anthem that we all sang together. Then we had the keynotes and all. And I now have the privilege, and I'm extremely honored, to be welcoming JS Ranjan Garu. Thank you for honoring our request and coming over here. JS Ranjan Garu is a special chief secretary. He's also been involved with whatever progress we have seen over the last 10 years in IT and all. JS had a huge role to play in all of this stuff. He has been a huge support of what we've been doing. Thank you, sir. Thank you for obliging our request and coming over here. May I now request JS Garu to deliver the closing keynote, and then we will proceed to the valedictory after JS Garu's closing keynote. Thank you, sir. Thank you for coming. Thank you very much. Very good afternoon, ladies and gentlemen. First of all, I would like to convey my appreciation for the organizers of AI Days, Swecha team in particular, and everyone else who have supported them in organizing this wonderful event. Even though I was not here yesterday, but I heard many good things about the day-long deliberations, also the interactions that happened today. And I feel very happy that the ecosystem in Hyderabad, in Telangana, supporting AI is maturing very rapidly. We are already thinking of developing local language models, Telugu language models, Telugu language products, solutions, etc. So some of the things that we are doing here in Hyderabad, I particularly feel very happy and very proud about it. Some of you would be aware that while the world over AI has been in existence for decades, but the real thrust came in just about 7 to 8 years ago. And gradually when people in India started taking note of AI, Telangana was amongst the first few states to decide a very focused strategy on how AI has to be developed, AI has to be used. Some of you will recall that in the year 2020, we decided to celebrate that year, commemorate that year rather, as the year of AI. And 2020, all of us go back and recall, was a very tough year. We had COVID, lockdowns, all kinds of emergencies. And obviously, if you have planned something, not knowing that these kind of calamities are going to befall you, your plans do get derailed in some ways. But again, I feel very proud that almost 80% of what we had planned for that year, we were able to accomplish. Partly virtually, partly through in-person activities, but nevertheless, the beginning was very good. And of course, when we started something on 1st of January 2020, lots of preparatory work happened in the preceding months in 2019. And one of the good things, something which we have been recognized, national government has commended us for that particular activity. We brought out a framework to support AI. What is the responsibility of the government to promote AI? What is the responsibility of other stakeholders? How do we bring all the stakeholders together? And I would encourage all of you I'm sure have deep interest in AI, to go to our website and read this framework. While it was prepared in 2019, later have 4 years approximately have gone by, but it is still very, very relevant. And I don't think there is anything that we have missed. Possibly generative AI was not that relevant at that point in time. But other than that, everything else that one needs to do to promote AI, to adopt AI very, very rapidly, all these features are provided
in that framework. So just to give a very quick overview of that framework, the most important thing, and I briefly overheard some of the panelists of the earlier session. I came a little late, unfortunately. One of the key things about doing anything related to AI relates to training your algorithm. And of course, writing the algorithm, developing the algorithm for sure. But you require lots of data, even prepare that algorithm, train that algorithm. So as a government, one of the first decisions that we took is that we will take upon ourselves as a key responsibility to make data available. And I think lots of efforts have happened in that direction. I feel very proud and satisfied to share with you. We have decided as a government that our priority for AI will be agriculture. Agriculture is one domain. I'm sure all of you know this, that it supports the largest number of rural livelihoods. And I'm very happy that you are also choosing to focus on AI for society, because this is exactly something which is our priority also. That AI should work for everyone. Just as you use the thing AI for society, the similar thing that we use is AI for everyone. Making AI work for everyone. That is the thing that we work on. So obviously, everyone is the society, and if you look at which sector, which livelihood supports the largest percentage of that society, it is agriculture today. And to facilitate development of AI-enabled solutions for agriculture, we have set up, and as I said, we are the first state in the country. Now we are showing the way to the national government also. We have set up an agriculture data exchange. So all possible data sets that one would require to develop a solution related to agriculture is available on that exchange. But like any other exchange, like the stock exchange or any other kind of data exchange, there are norms on how do you participate in that exchange. So sometimes we have heard, and we have seen also, these are very true kind of episodes, in which large-scale misuse of data has happened. Lots of even reputed tech companies have allowed the huge access to data that they have to be passed on for commercial interests to third parties have misused it. A few years ago when the elections in the US were happening, so the huge debate and investigation on how personal data has been misused to kind of motivate or nudge people to vote in the favor of a particular party by reputed technology platforms, etc. So there is always that risk and always that concern that the more access you provide to data, some element of misuse will happen, some element of extracting commercial benefit without passing any benefit to the people whose data you are using. That kind of scenario will happen. So we have created an agriculture data exchange, keeping in mind all these possibilities and creating very robust internal systems of checks and balances. It is not just commercial misuse, it is also privacy, it is confidentiality, it is consent. So that is one very important responsibility. And as I said, while we have created data exchange for agriculture, we are absolutely open to provide or make accessible other data sets also, which people will be using in other domains. So as I just found out, we are panel was focused on healthcare. So again, lots of data is available. Lots of mobility data is available with the government and so on and so forth. So making data available is a very big responsibility that we have taken, and many of the startups who are connected with us, who participate in our programs, they know how easy it is in Telangana to access any of these data. Along with providing access to data is a related issue or a related question of high performance computing. See, when you are given billions and billions of bits of data, many times we feel that the compute capacity that we have access to in our simple PCs, etc., that is not enough. And that is a big barrier that we face, because high performance compute also comes at a very high cost. And again, for young innovators, young entrepreneurs, startups, students, it literally becomes impossible. Even if you have a bright idea, you will be thwarted because you won't have compute access. So again, this is something which we have done for our kind of ecosystem partners. We have been able to access high performance compute facility, more than 15,000 GPUs at literally throwaway prices. And we are now in discussions with another provider, a company called Jota,
they have decided to initially set it up in Delhi, but we are convincing them to set it up in Hyderabad as well. So once these facilities are available, already as I said, the CDAC and NVIDIA facility is already available. Many of our startups to the, I don't have precise information, but recently when I had checked out this, I was told that more than 20 startups in Hyderabad have used that facility, the low-cost compute facility that we have arranged for them specially. And once the Swecha facility is also developed in Hyderabad, that will be an additional method of having access to high-performance compute. So this again is something which is very vital. People overlook it, thinking that AI algorithms fall from the sky, some miracle happens, lots of work goes behind it. And these are some of the challenges which people face to actually write algorithms. These are the challenges that they face. Accessibility to data, clean data, interoperable data, access to high performance compute facilities. So as a government, we are making these kind of things available. Another very important thing, of course, as we notice now, AI is becoming more and more and more pervasive. Literally, there is no sphere of our lives which cannot potentially be improved or made more efficient using AI. But where are the people who have that talent to run AI kind of programs? So again, skilling is a very important responsibility, and it's a nice coincidence that we are having this conference in an academic institution, a premier academic institution like the JNTU, which is of course offering high quality courses on AI, ML, etc. But again, many of you would be aware, since I see that many of you are students, there are a range of courses available. In fact, AI is not just PhD level skills, writing very logical algorithms. AI skills start from absolutely low end, even to clean the data, data cleansing, data organizing, data annotation, making the data interoperable. Even that is a task which has to be done before PhD kind of people take over that data. So again, who does that kind of work? For that, you don't require very high skills. In fact, I have seen that people with as low as a 10th pass qualifications or a 12th pass qualifications can do that job. And to do that kind of a job, you don't have to be in an expensive office building in Hyderabad. You can be somewhere else and do this work. So again, we have been very successful in motivating some companies to set up basic AI level of skills in smaller towns. So again, I'm happy to share with you that some of this kind of work is going on in Warangal, some of this kind of work is going on in Nizamabad, something in even smaller towns, etc. So we have made a good beginning to show that the basic skill sets which are required to organize the data, that is also something which can be done very easily, and Telangana government arranges for those kind of skills to be made available to people. Of course, the higher level skills, there are many. JNTU and many of the colleges under JNTU were the first to introduce options, engineering options in AI ML. IIT in Hyderabad again was one of the first to introduce a full-fledged BTech in AI. But there are lots of short-term courses also, few months courses, few week courses, very fundamental courses, etc. So there is no dearth of content which is available today for skilling, but how to put it together, how to make it easy to use, how to provide credits for it, and how to introduce an element of practical learning. While you learn theory, while you learn the coding languages, how do you actually test the experience or the learning that you are getting on live situations. So that is again something that we have decided to focus on. So from this coming academic year, which will start maybe from June or so, we will be on our, we have an institution, students will be possibly aware, which is called TASK, Telangana Academy for Skills and Knowledge. And on the TASK portal, lots of practical use cases will be demonstrated, will be displayed. So if you have done some course and you want to try out whether you have learned something which is worth replicating, which is worth applying, opportunities will be there. And once you enroll that, okay, I will work on this particular problem, data sets will be made available, you will be encouraged to develop your solution, the POC will be tried out. So, and an additional certificate will be given to you that apart from learning a particular content, your theoretical means, you have also been able to demonstrate that you know how to use it. So again, this is something which is
in my opinion, very progressive because to the best of my knowledge, not too many governments are doing these kind of things. Possibly no other government is thinking of these lines, that the skilling that you are developing, the skill manpower pool that you are developing must also have a practical orientation. Just knowing the language is good, but how do you apply it in real situations is the real test. So again, that is something that we are working on. Of course, we have seen the world over that large number of AI solutions today are coming from not just big technology companies or niche AI companies. Many young innovators, young entrepreneurs, they are also providing these solutions. And to encourage that to happen here in Hyderabad, here in Telangana, we have set up very useful and a very kind of comprehensive programs to promote entrepreneurship, to promote innovation. In the government, we have set up a center of excellence on data sciences and AI along with NASCOM. And we run AI accelerator programs, which is called RevUp. And so far we have completed 3 cohorts, more than 60 AI startups have been supported through those cohorts. And many of them have done very well. The solution that we have developed is in use now. Their valuation have gone up. Some of them have received subsequent funding also. That is happening on a very satisfactory level. The T-Hub also has been recently given a sanction of a focused AI/ML incubator, which is called MAP, which has been funded by the Department of Science and Technology. Their cohort has just started, just about 10 days ago we inaugurated it. So they also, given the proven track record of T-Hub, they also I'm sure will do well. So the Center of Excellence, T-Hub, and many others who are doing similar kind of things at their level, the synergy, the collaboration that is possible, all that will be facilitated by the government. And I'm very sure that Hyderabad eventually will develop into a very potent center for innovation and entrepreneurship related to AI. The government also is very serious about AI, and we want to walk the talk. Instead of just saying that I'll give data, I'll give compute facility, I will set up some innovation spaces. How do we actually bring AI into our own processes is again something which we need to show through example. And again, I feel very proud to share with you that in the last 4 years, since 2020 when we began the year of AI campaign, we have onboarded 25 plus solutions, AI-enabled solutions within the government itself. And one solution about which I feel very proud about, because a few months ago, there was a national conference on AI, and we were asked to present that solution before the Honorable Prime Minister himself. This is a solution which relates to poaching. Many of you will be aware that in the forests, animals are killed in a very brutal manner to retrieve their skin or their body parts and all that, and it's all very tragic. There are organized gangs of poachers who go to a forest area, they wait when no one is there, they attack the animals, and there is a very big traffic. The parts go to China, to other countries, and it's all very tragic. Animals obviously can't defend themselves, and all this is going on. So we have been able to support the development of a picture recognition based solution enabled with AI, which alerts the forest officials whenever any such image is seen, which is not of a regular animal which is found in that forest area or in that wildlife sanctuary. And it is running for the last few months, more than 1 year I would imagine. And the initial results are very, very encouraging. We have created another AI-based solution along with IIIT and Intel, which is called iRaste. Someone might have spoken about it earlier to you, which alerts drivers at the locations where accidents typically happen. So accident-prone zones, and the algorithm also takes in account the driver's own behavior of what kind of quality of driving he is providing. So we have installed this solution in 2 national highways in RTC buses, and the data shows that there is a reduction by 40% in the accidents which typically used to happen in those roads. So many such examples are there. As I said, 25 plus examples are there, and we are always on the lookout for more and more use cases, so that instead of just preaching, we will also be walking that talk. One third example which I can share very briefly, again I feel very proud about that solution. This potentially is a global solution. Across the world this can be adopted. This relates to remote voting. See, all of us know, and coincidentally this is the election season. On the 13th of May, we will all be required to go and vote. Now, it's of course a very important part of democracy. It is our duty. We all have to go and vote. But many people find the whole experience of going out and voting to be a very cumbersome experience. And many times it is also very user unfriendly. You go somewhere, you stand in the queue, and at the end it is found that your name is not there or someone has voted in your place. So it also creates a big hassle. So we have been able to develop a solution which allows you to vote sitting in your home, using your phone. And as you know, voting is a very contentious process in our country. People keep complaining, people keep challenging. Typically after every elections, electronic voting machines are blamed that they were faulty. I pressed this button, but all the votes went to someone else. But so even in this kind of an environment, we were able to successfully demonstrate in a live scenario. There is a town called Khammam, about 350 kilometers from here. In a municipal election, we were able to demonstrate with about 3,000 voters that without stepping out of your home, you can cast your vote completely successfully, without even 1% of any doubt or any error, etc. And the AI played a very important role in creating that solution. So it's an image recognition solution, but how is your image evaluated? There are lots of AI behind it. So as I said, many such solutions have been created. The other important responsibility which the government takes is to work towards ethical use of AI, have a proper governance system, have a system which is promoting responsible usage of AI. So we have created an institution in the government which is called Telangana Artificial Intelligence Mission, and it is headed by the India head of NVIDIA. NVIDIA, as you know, is today one of the champion companies when it comes to AI. So their India heads our team. And there are members of other private companies, there are members of NASCOM, members of academic institutions. As the government representative, I am there. So this institution looks after all the governance issues, data sets, responsible AI, what will be the ethical usage, which use cases will take up, how will we allow some startup to develop their solution. So this is a very robust mechanism. Again, very few governments, very few states have done something of this kind, which we have done. We are also very keen that we play an important role in popularizing AI usage through frequent activities, events, meetups. There is a strong AI community here. The present event that we are all participating in, AI Days, is one such example where we have been able to bring together all the stakeholders. I'm happy to share with you that 2 months from now, in July on 8th and 9th, one of the largest AI summits which have ever happened in our country is going to take place here in Hyderabad, the Global AI Summit. And again, the focus of that summit is, while we are still working on it, I can share this very briefly, that the focus of that summit will be to show, I mean, we have spoken enough about theory, we are now speaking quite a lot about Gen AI, we are speaking about responsible AI, ethics in AI, but where are the use cases? So we want to show that literally in every field of life, AI has a use case, someone somewhere is using it and benefiting from it. So how do you get exposed to all these amazing use cases? How do you decide to use some of them yourself? Or how do you tweak it? Or when you hear about some use case in some field, does it give new ideas to you on how it can be used? So it's a very practical kind of focused event on July 8th and 9th, as I said. So I'll invite all of you also to register for it, participate in that. Registration will be opening possibly in the middle of April. So look forward to these kind of events that are happening again and again and again. So once again, I feel very happy that the 2 days conference here, AI Days, has been a resounding success. I particularly appreciate the initiative of developing Telugu LLM, and of course, this is an opportunity which will help the next billion users of internet. Most of the next billion users of internet will be using it in their own language. They will not be knowing English, they will not be having any kind of advanced college degrees, they will be living in rural areas. So language should not become the barrier, and therefore the effort to collectively work on large-scale local language models is very noteworthy. We are also making similar efforts, and I'll be happy to kind of collaborate and synergize. We have got permission, so it has not yet been officially announced. We have got permission to access the database of a huge Telugu newspaper group. This newspaper group has millions of articles, millions of publications, and the entire archive has been made available to us. So this again is a very good kind of resource for us to train our model and make it more and more accurate. Eventually, accuracy is what will push the needle. This voting solution that I spoke about, we have not been able to kind of scale it up or convince the election authorities or the Election Commission of India, because it is still not 100% accurate. So it is, I mean, the accuracy levels are very good, 87% or something like that. But till it becomes much more accurate, no one will really be able to give 100% confident kind of acceptance to it. So this is again something which we need to do collaboratively, we need to pool our resources. And as I said, I'll be very happy, as a government, we will be very happy to support any such initiative which is going on. So once again, good wishes to all of you, and thank you very much for inviting.
One small announcement, my request, Kiran Chandra, founder Swecha, Professor Pratap, President Swecha, Chaitanya, co-founder, CTO, Ozotel, Nagendranath Garu, Senior Advisor, Salamander Advisor Services, to Honorable Katta Narasimha Reddy Garu. So if you can also please join us on stage for 1 minute. Nag Malladi, Vice President, Tech Mahindra, Srinivas Mohan Garu, again, there is no introduction. We've all seen Bahubali, RRR, Kurato. He's the person behind all of that stuff. Right? We just want to make a small announcement. As we have done this huge conference, over the 2 days, we had more than 2,000 delegates participating in all of this stuff. Just want to announce this one announcement. Kiran, Chaitanya, and Nag.
So we're going to set up a center here called as the Center for People-Centric AI. The spirit with which the conference has begun, solving problems for the commons. Thank you, JHRU, saying that he will be supporting us all through. He has been always supportive of it. And I think this center is going to look at solving problems for the commons. And I think all the scientific community that has been sitting here has listed close to 200 problems or odd problems since all the speeches were going on yesterday. So I think we'll start solving some of them, and hopefully we'll be able to present in the conference that is going to be there, that in these 3 months we have solved X number of problems.
We've already a few institutes, including IIIT, a few companies, which are also represented over here, signing up, universities and all. There are a few companies which have signed up to be founding members of this center as well. There's an open call. I know there are a lot of companies, startups, research institutes, including the likes of CCMB and others who are a part of this. We're also proud to announce that the Cyber Cell, they were there yesterday, the institute in Chicago was there. They wanted to partner in the center that we are setting up as well. So if you're interested, please do reach out. This center over the next 1 year, we will be working towards Vision AI for Society. No, sir, this will be located in IIIT Hyderabad to begin with, and then the center will look to have its own space as well. Hubs will also be there across the India. This will be centered in Hyderabad. We are opening up hubs in Madras, Bombay, Chennai, Mumbai, Bangalore, other places as well. This is going to be a huge initiative where we are going to be working on use cases. If you're wondering why we have this, we have demonstrated farming and agriculture use cases yesterday. This will actually be, we will be releasing lots of use cases as we go forward. This is an open invite. If you're representing your company, industry, startup, whatever it is, if you're interested,
in building people-centric AI solutions, please do reach out to us. We're going to be actually launching the center in a month's time frame, and we look forward to collaborating with you. Jayesh Garu has also said they're happy to collaborate with us on all of these things, and we'll be more than happy to work with the government and other organizations which are working with the vision of people-centric AI and AI in the society. Thank you, thank you. Thank you. Some words of wisdom from We've begun the conference, if you remember, where we started our journey with UPI, which has actually got no relation directly to AI, and then we have spoken about how AI is going to take over, right? We started to say something that we had built, executed with a vision towards AI. The AI vision was 2017, when we held the DevCon 2017, we spoken about AI vision. 7 years later, why don't we, do a future perspective? Where do we think we'll be? I am quite sure we will be entering the era of quantum computing. So with that note, now I think we should conclude the conference with Dr. Krishna Palam Garu, the founding CEO of Accelerquant. He's going to be talking about the intersection of AI, ML, and quantum computing. Sir, I think you should please join us. And 7 years, 5 years down the line when we are here, that should be the current, that should be the present. Because 7 years ago we started talking about AI, ML taking over, and here we are today. Probably 5 years later we will be calling it AI quantum days or something like that. But nobody better than Dr. Krishna Palam Garu to talk about the intersection of AI, ML, and quantum computing. I know it's a very curious topic for all of us. Nothing better than you speaking to close this out. So thank you so much for obliging and joining us over here.
This is on? Yeah. Okay. So I make you one promise. I will let you go in 25 minutes. You don't ask me any questions. And that's at the end of a long 2 days. But this topic actually would have been done better than like early in the morning, because it can be quite confusing, and I'll show you why. I'll start out by giving you a 5 to 10 minute overview of what quantum means. Then we'll talk about what it really is used for and potentially in the AI space as well. So I'm right now running that company, so I don't want to go into the company specific things too much. So the spirit of what I do is just an overview of what's happening in the field. So this doesn't work. Should I point it or something? Oh, it's working? The down button, is it? Okay, so let's start with what is quantum computing. And if you look at what quantum computing is, you see those words on the left. I'll walk you through those. Those are terms used very freely, quite often without attribution of what it really means. So I'll start trying to give you a feel for the basic vocabulary of what quantum anything is. And then we'll move from there to trying to see how we can use it. So these are cartoons which are very, very approximate. So you can easily misinterpret them, but I deliberately watered them down so that you can understand what the real meaning is. So normally we all know that there are things called bits that you compute with. Quantum lives in the world of something called qubits. So a bit is simply a 0 or a 1. And typically when you build these ICs, integrated circuits, out of semiconductor material, there is a high voltage or a low voltage. And this voltage can be thought of as encoding a 0 or a 1. Qubits are done in a much more complicated and even somewhat bizarre way. So, and this is where things could get inaccurate. You actually manipulate and encode information not at the level of charge, which is about, 10,000 to 100,000 electrons, which is called bulk charge, but you can start manipulating individual electrons. So a single electron, when you start moving it around, it really doesn't want to move around the way you want it to. So the way you can think about this conceptually, there's a lot of mathematics and physics behind it, is that black dot, if you want to encode the information on it, depending on its energy level,
you use a tiny laser tweezer and actually move the electron to where you want it to be. And this now lives in a super cooled bath, which is held at a very, very cold temperature, and hopefully it will live there for some time. And that encodes your information. So the mechanism through which, and there are lots of different ways of doing this, there's light-based quantum qubits, this is superconducting material-based qubits, but there are different ways of building them. But they're all manipulating extremely fine-grained phenomenon, because I'm sure all of you have seen, whether you like it or not, at some point, the concept of quantum in the physics world. So quantization really is quite old. What it really builds on is, by virtue of doing what we just said, you can stack these qubits and they can encode states that are much more complex than bits. That's the basic idea. And so if you think about classical bits, each bit is a 0 or a 1. Depending on the number of dots, you take that many times 2 as the total number of possible combinations. In a strange way, because you're manipulating these electrons that can live in many states at the same time through this physics phenomenon called superposition, these internal states of these entities can simultaneously encode, you can imagine, many, many such strings. So many red strings can sit inside one green string. And that's the strangeness of quantum. So simultaneously, you're taking a stack and taking a red string, another red string on top, another, and you build a stack of it. Those all live in a single green string. And now you cleverly take the green string and compute by moving it forward to create another shade of green. That means you move the entire stack of reds simultaneously in some meaningful way, so that the result is what you want. So you can imagine why that's not easy. And the way you do this, if you're a programmer, is you write this down as some sort of a matrix operation on another matrix. But if you're building the system, it's much, much more challenging. We'll talk about that in a second. So, and this is where it gets really interesting, and that's sort of where it stops getting really interesting. After that, it's basically exploiting what I'm about to tell you. These quantum systems obey something which is, and now confirmed by science, a phenomenon which is somewhat strange called entanglement. So a very crude and inaccurate way of describing this, but it gets the idea across, is if you have two electrons and they're entangled, one is pointing up, one is pointing down. The theory said that if you send one of these two electrons that are entangled to the moon, and then it sits on the moon, and then you change the electron that's pointing up to pointing down, the other electron will change its spin instantaneously. And this is so bizarre that obviously it raised objections. So I'll get to that in a second, but let me walk through why this phenomenon builds on something that's actually very, very significant, and it took a long time. So if you don't get it in day one, that's really no one's fault except that it's hard. So the initial model of the atom, we all know, which my kids in 8th grade study, is called Bohr's atomic model. So Niels Bohr, the famous physicist, proposed this model where there are these electrons sitting in orbits, and there is a nucleus which is protons and electrons. So the time scale you can see for yourself. But the person who really triggered a very, very important break in this and led to what became the modern view of quantum mechanics is Schrödinger. So he postulated, and it's hard to explain this in 1 minute, but I give you the idea. What he postulated was that at the level of an electron, when you take a magnifying glass and zoom into the atom, it is no longer thought of as a particle. It simultaneously lives as a particle and a wave, an electromagnetic wave. And it can have both interpretations. So he wrote this extremely famous, I think it's one of those things where he had this leap of intuition, where he could write down the mathematics, because there was not enough scientific evidence at the time to justify it. It's one of those just a flash of insight kind of phenomenon. And just to, I know we all talk a lot in India about prices. So each one of those I'm tracking were recipients of a Nobel Prize in Physics for that work. So now, moving forward with this formalism of a wave equation, entanglement was postulated. And then, I'm sure you recognize the gentleman at the left. Everybody knows him. So he took objection to the fact that this phenomenon where mysteriously this equation says you flip something here and something else will flip far away, simply doesn't make physical sense. There's no intuition that justifies it. So he said there must be variables that are hidden that you don't know in the model, that are coupling these two things. So he got together with two of his friends, Brodke and Rosen, and they wrote, in fact, a popular paper, because of the first author, attacking this theory, saying that he called it, and at the time if he spoke loudly, people took serious notice, said this is spooky action at a distance. And this is called the hidden variable theory, which in the 60s got debunked actually. But the bottom line, this is not an easy thing to propose, nor is it an easy thing to verify. But lo and behold, many, many years later, work done from 64 to 1998 led these three people who did really brilliant experiments, because this sort of thing is very hard to verify, to receive the Nobel Prize in 2022, 3 years ago. So it's only 3 years ago that entanglement is accepted as a verifiable scientific fact. Through experiment, it was postulated, all sorts of indirect proof was there, but a direct proof is recent. So now, not to intimidate you, but quantum computers take all these things except for Einstein's objection and exploit it through a programming interface. So I can actually manipulate all these things through a quantum computer. And that's the brilliance of the engineering that happened in the last 20 years, which led to machines where you can actually set superpositions up through software, entangle things, and then if you are clever enough to write the right program, let the stack of entangled bits be processed, where when you touch the answer and read it out, you get what you want. So, and we'll see what happened there. So, an algorithm, a quantum algorithm exploits these features. Okay? And this is what everybody is after. Now, somebody in the opening of this session said that in 5 years we'll be looking at a quantum summit like this. It's happening now. There are summits around the world, the equivalent of this, maybe not 1,500 people, I don't know, but they are able to, and a year, our little startup could actually show how you have a problem that can be solved at scale. And therefore, it's sooner than you think, and that's the name of the company, AccelerQuant. We're accelerating the time to which these quantum technologies will be used. And it's purely, we live in the software space, all the big giants, they build the hardware. And so, what is happening out there? The next two slides are largely due to McKinsey, the consulting company, and the Boston Consulting Group. They build these projections. So, you have, these are the areas where it's supposed to have impact. It's a long list. I'll get to that a little bit more towards the end of the talk in 10 minutes or so. But the opportunities are many. But how significant are they? So the scale on the y-axis is billions of dollars. So if you look at a modest projection, and this was done 2-3 years before generative AI, the AI piece of that was supposed to grow to $100 billion. And that's the quantum piece. Okay? And now there are all other normal things like drug discovery, pharmaceuticals, I'll talk about that, and other areas as well. So if you add it all up, that's close to a $250 billion at that time. But today, or yesterday I heard, I haven't verified, that ChatGPT's market cap, people are talking about to be $1 trillion. And I don't know if it's verified yet, but I heard. Now, that's a trillion, and this was when ChatGPT didn't exist. The quantum AI could be much, much bigger. So these are areas that are just rising extremely quickly. So, is any of this real? Are people taking it seriously? That's a list of companies. Each column is a different type of hardware, technology, physics, who are investing in this area. So you can see, so the names you don't know are startups, but when I say startup, they're spent anywhere from $100 to $250 million building this hardware. And the big ones, of course, you know, right? So we ourselves are partnering already commercially with IBM to validate what we do on their machines, and I'll mention that briefly in a minute, and also talking to other companies. IonQ is a very interesting startup out of Maryland in the US who are doing a different technology than IBM, and Google is invested in this. I didn't list it here, but Amazon also, but they're not as loud about it in the public domain. They're quite much more quiet. That amount of money, and this is old information from 2023, that has already been invested in startups in quantum. So there is over $100 billion invested worldwide in quantum computing startups. The number is a little big because the hardware companies soak up a lot of this. The hardware companies take up $600-700 million of this. And so the leftover for smaller companies like ours is in the $10s to $50 million, but we don't need more than that at the moment, right? So, because it takes a lot of effort and people and cost to build these things, right? So, different companies have roadmaps on where this hardware is going. This is IBM's, one of the companies we use actively. So if you see from left to right, basically you just see those names, Falcon, Hummingbird, Eagle, Osprey, Condor, etc. Those are increasingly big quantum machines. And they're rolling them out as like every year and a half. And as they get bigger, you have more of these things, as I said, called qubits. So you can use more of them, you can solve bigger problems. That's the whole idea. Okay? They touch something. That's what I thought. Okay, so everybody who's been building hardware, therefore, has a roadmap, and they're all projecting that by 2028, roughly, you'll have a machine big enough to really do whatever you want, in a sense, something at large scale. And so that's Google's roadmap. And so this sort of the march goes on. Everybody has a roadmap now. So it's a pretty predictable pattern. So just as Mike did just now, qubits do the same thing. After a short while, in the middle of a competition, they kind of fade away in that. So what we just saw was a demonstration of a qubit in real time through the mic. So what happens with these qubits is because these electrons, let's say, are held so delicately in place, a change in an energy infusion to the electron causes it to go to a different state. But that can come from a tiny bump, the famous newspaper article that said a truck driving in New York 50 miles away from IBM's facility can send a vibration that can destabilize an electron. So these things are very, very delicate, is a short answer. And that creates a problem. So the fact that when they say I'll have 2,000 qubits in 2028 means that's when I'll have 1,000 good qubits that will stay around with us for a while, and hopefully like this might last till the end of the competition, right? So that's the way a typical computation can be thought about. It's evolving in time, because wire-like things are entanglements. The grayness means the qubit is fading away, and that's very common. So what we do in the company is, instead of investing $200, $300, $800 million to make qubits better, we ask the following question, and that gives you an idea of how to approach this problem from different angles. We ask the question, how much does your algorithm really need to survive and compete? And so you look at the number of qubits it really needs through some mathematics, you understand the need, and what we show is you can typically live on a small fraction of the total qubits you think you need. So that's sort of like Archimedes' river, where you use the leverage of the algorithm's need to live on a much smaller machine. So the name Axelecon comes from the fact that we can take a problem you thought you needed 1,000 qubits and show that you can live on, say, 200. This is a made-up number. And therefore, 200 you can get now. Therefore, you can deploy your commercial application 2 years before you thought you could. So you're accelerating time to deployment. And for a company, time to revenue. That's the idea. So now I want to close in 5 minutes with the idea of machine learning and where the opportunities are. And broadly, I categorize this into 2 areas. Let's call it synthetic chemistry and generative AI. Okay? It's a very broad area. I'll allude to some in some detail, some of them, not all, because you get the idea. So these are topics within synthetic chemistry where the quantum computer is programmed to simulate a chemical reaction, for example, at scale. So you don't actually go to a lab with a person and mix things in a test tube and test, do extractions. You actually run a model of this in quantum software and conclude. That's the idea. So protein folding is very popular because none less than the Google arm that does AI in the UK released something which is called AlphaFold, a protein folding scheme. It's all machine learning. Now we're talking about classical, not quantum solutions. Similarly, we have another aspect which manipulates genes, not proteins. And you also have molecular simulation, which is straight chemistry. And this has multiple applications. And then you have this big giant that has just emerged, generative AI. So in synthetic chemistry, I'll touch upon just one of them. And this is the AlphaFold success story. Over time, they could look at a staggering number and train them on 100,000 proteins, and they could find close to 3 billion folding patterns in these proteins that make sense. And this is classical AI. But then they hit a bottleneck. And similar things are happening elsewhere in molecular simulation and battery design, where in the battery design area, in order to optimize, mostly motivated by EVs, electrical vehicles, the quality and the efficiency of the battery, you can do a lot of chemistry. But that can get very ugly in terms of environmental impact, all sorts of things. So what people do is they do AI-based modeling in order to understand these things. But all of them have a problem, And that problem, which is summarized here in the context of generative AI that all of you know well, or at least use it in some capacity, is there you have on the y-axis the amount of global CO2 that the electrical consumption of these giants consume, and those are the power numbers that these things use. And as you go, you're right now just talking about 170, less than 200 billion parameter models. Now we're talking about a trillion parameter models, and the growth is very non-linear, right? So, roughly speaking, numbers I've seen informally, they say that it takes about 2 months to train a model at that scale on a complete data center. You lock down the entire data center, train it for 2 months. And then you have a model which will play with for the next 2 months while you train the next model. Now you can't pipeline this on a daily basis because you don't have as many, 60 data centers you can lock down. And that's for one company. Now imagine the number of companies that are doing training on generative AI is small, right? So the opportunity space that we see in a particular form of this generation, and that is synthetic image generation, creating images, which you have seen recently in some successful demos, I'm sure, where it's completely artificially generated with some seed image you get from somewhere. So this sort of synthetic generation is, you can see on that axis, basically a low FID score means that you're doing well. So as the y-axis became high, the Q dense, the red dotted thing, you can see it drops quite well. That's a quantum simulation for the image generator using generative AI. So there are data points like this that are coming about. And what we ourselves do, using our philosophy, is to be able to take a model like that, but show that you can deploy it using our techniques on a smaller quantum machine sooner. So we are not in the business of creating AI models, nor are we in the business of optimizing them in traditional AI. But we are in the business, at least as of a few months ago, in trying to get into taking a model which lives in the quantum world, or we can make it live in the quantum world, but by itself would have required a machine in 2028 or 2027, but you can live on it instead in 2025 or 2026, and you get the advantage that you don't have those very large power and resource requirements, and also eco-friendly situations, right? So that's the general philosophy of our company. And so can we make any of this really happen? So last year we did a study with an optimization problem. An optimization problem is trying to find a minimum or a maximum of something. And those are all names of different IBM machines. They name them after rivers and cities with varying number of qubits. And there is something in a quantum machine because of the fluctuations of these qubits, which is called its fidelity. %100% fidelity is probability 1. So the challenge said try to hit 99% on these machines. And using this method and making the qubit demands less and deploying sooner, we consistently hit 100%. And that's on real quantum hardware. So this is not a simulation. You actually can upload it in the cloud, invoke a machine wherever it is, and run it on IBM hardware. The other side of the story is what are we pushing to do? We're trying to take something that needs, say, 1,000 qubits and say you can live on 200 qubits. 200 is now, 1,000 is 26, 27, right? So so IBM has put out some benchmarks. The greenish blue curve at the bottom is when they will hit on the y-axis something called a certain quantum volume, the size of the problem. And it grows according to their projections along that line. Once you do our transformations to live on pure qubits, you get the purple line. That means you could move that point where you could get a certain volume from, I don't know, roughly 2025 to last year, which is when we did it, right? So the entire philosophy of what we do is that living on other people's hardware, which is any of these, we're agnostic as to who makes the hardware. It's an abstraction that we work with. And last but not least, the domains of applicability that I mentioned to you are real, and we are concretely looking at aspects of machine learning. And that last application you saw, the image generation synthesis application, is at the front of all this. So this is happening now. That's it. Any more questions? I think you need
First of all, compliments to you for attempting such a wonderful session and such a deep topic within 25 minutes. I don't know if anybody could have explained much better than this. At least to me, it's very informative.
Thank you.
So I work as a vice president in Tech Mahindra, headed some business units. My question is predominantly on the market space. Touch base upon the revenue numbers. I completely agree with you on the numbers, and we as a company strongly believe in quantum computing. But when we are explaining to our customers, you have a slide which basically talked about some of the industry use cases. If I pick up the pharma licenses, vertical use cases you mentioned, the clinical trial site optimization is one use case you mentioned, and then the user drug recommendation, personalized medicine. To be frank with you, some of these use cases we are already taking to our customers under the heading of AI or a Gen AI.
Yes.
So, my question is like, how do we position it in terms of commercial angle? Is there any analysis done on, for example, companies spending XYZ dollars right now with AI, and tomorrow when I'm getting into, let's say I'm using quantum, how much of a percentage would I, basically I'm talking about the motivational factors for the enterprises to spend more money on this with a kind of a ROI at an eyesight?
So the question says that can I translate the market size and technology opportunity into some sort of return on investment type estimate for a given enterprise. So first, a high level comment, everything we do is in the enterprise space. It's all what they call B2B. So we don't do B2C because it requires individual customers, right? Now, the numbers that start out in this, let us call it calculation, are speed up and let us say scale, the size of the problem. So I didn't say this here because it's all about AI, but there are non-AI domains which are where this is more obvious because the domains are mature and they already have revenue. So we are looking at a particular supply chain logistics domain which has a TAM, a total accessible market of about 12 billion. And we are now in the process of showing that a problem that they solve can be scaled in size by a factor of 100 and done 10 to 100 times over time faster. So that means they have actionable information which would normally take a few weeks to get to in a day on a much larger global problem. So you can imagine the domains, without going into all the details, airline industry, shipping, correct? All the heavy supply chain kind of industries. The same optimization problem also plays a role in the battery design. But I went into the more future, forward-looking areas because the total TAMs in optimization are set. The accessible market is not well defined. These are emerging TAMs. So for this forum alone, I picked areas, for example, drug discovery is a potential application, but the TAM on one of those tables will show is huge. Till, I would say, September, right, ChatGPT, before pre-ChatGPT, the TAM in that entire space was much smaller. Now, Jattampalli alone has a TAM that is huge, right? So, I picked areas where the markets are being defined for this talk. But there are mature markets where we are in-house working with companies like yours who have a customer base, but their problems are much less exotic and much more well-defined mathematically. So the markets for some of those areas are projections. Like drug discovery is a projection, correct? protein folding, eventually personalized medicine is a projection. So I picked those because those are the more intellectually interesting future forward-looking areas for today's talk. And that's where AI and scale matter. But there we don't solve the problem at the base level. We try to take your AI solution and deploy it sooner. At a larger scale, less cost. Now it's obvious to you that if something is 50 times faster, it's going to be cheaper. And if you solve something 1,000 times larger, also better. The exact dollar value, and that's a bit of a question mark, the more further out you are in the market.
Thank you, Dr. Krishna Palam. In the interest of time, may I request the audience to take any further questions offline? If we are, no? Thank you so much. In fact, I was thinking maybe 7 years. You're saying 2 years we'll have to rename this to AI quantum based, and we'll probably call it quantum machine learning.
We said in 2 years you might have to. We are a bit bullish in our company. Accelerate, we're accelerating. So I wouldn't be surprised if I was sitting with you this December to say let's do it next year. We're optimists. We're optimists.
Thank you so much, sir. Thank you, sir. Thank you so much.
Thanks.
We are now at the end of the conference, but before we end the conference, I would like to call onto the stage a very special person. I think this is already imprinted to all of our minds. May I invite Professor K.K. Babu from the National Institute of Fashion Technology, NIFT. If you are wondering what has NIFT to do with AI days and everything, everywhere you are seeing the logo over here, everywhere you are wearing those shirts, volunteers, everybody, everywhere the logo is there. It was designed by Dr. K.K. Babu. Sir, if you can just please come on to the dais once, just one more. Thank you so much, sir. This is a wonderful thing. In fact, we're thinking we will use the same logo to the center, for the center we have just spoken about as the Center for Research and Development of People-Centric AI. And I think nothing encapsulates this better is what I thought. He said, no, Praveen, I have a better design. You have yet to look at it. Thank you so much, sir. Thank you for doing this. And I'll ask you to stay back. We are at the stage where we're doing vote of thanks. I'll first do the formal ones. First of all, thank you to the Department of CSC, University College of Engineering, JNTU, Supriti ma'am, if you're here, may I request you to come onto the stage. Rajni ma'am, Patnajarani ma'am, any of them, if you're here, please do come onto the dais. And JNTU, to the Vice Chancellor and to the University who have provided us with this thing, with this venue. It's wonderful. Thank you so much. To our supporters, Anurag University, Anurag, if you're here, please do come onto the dais if you're here. Anurag University has been a huge support to this thing. Anurag University. Meta is a supporter of this conference. We have Hitam, Sridevi College, and a lot of JPNC has also been a supporter of this conference. In addition to that, for the supporters and everything, you've seen the partners, you see the AIML partners as TechVedika and DigiQuanta. Thank you, DigiQuanta and TechVedika. CX in AI partner being OzoneTel, our visual media partner, OneClint media partner, Hans India, and lots of others are nightly missing because they're playing with full screen. I typically like to copy some of these things, but that's okay. Using some of this stuff. What made all of this possible is not just the supporters, not just these organizations I spoke. Naveen eating is what actually helped this conference, right? I know that's what they say, right? I just want, Naveen, we will show you on the stage anyway. If you can just please play other behind the scenes as well. I wanted him to play the behind the scenes because, there's a lot of work that has gone into it. We had 2,000 people. It was not just because, Naveen was eating. Good. He doesn't want to show anything else. So what I'll do is I'll call everybody on stage. I'll first start with the person behind all of this stuff. Kiran is the founder of Swecha. Please come on to the dais. We'll start with Kiran, but it's a whole team effort. Might I call all the preparatory committee onto the dais. All the preparatory committee, Pratap sir, Nag, Srinivas Garu, Vamsi, please come on to the dais. And all our speakers who have made this possible. Pradeep, Rajikar sir, come on, please come on to the dais. Suresh Garu. All the speakers, Anand, Saradinkar, please do come on to the dais. Krishna Palamur, might I request you to please join us on stage. Raghavinath Garu, ఏంటి సార్ అటు చూస్తున్నారు? ప్లీజ్ హియర్. Come join us over here. We'll provide dinner for you separately. Where is Rajshekhar? 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 Chaitanya, hello. Hello, please, please. We also have the birthday boy over there. One happy birthday to Ranjit. Happy birthday, Ranjit. Ranjit has turned 45 today. No, 50? 50, yeah? Divya ma'am is saying, no, why are you revealing the real age right now? Sorry, Ranjit, should I say what? Shouldn't say your age. Okay, Ranjit is not 45. Oh, hello, Chaitanya. Hello, please, somebody, please escort Chaitanya onto the... Yeah, thank you. Ramesh, all the... Shashikant, the question that I was asked, everybody was asking, how is, Shashi still alive? I don't think he has slept in the last 1 month. Where is Shashi? Shashikant? Shashikant over there? Okay, Shashikant is over there. Srini, please do join us. Srinivas Andamani, yes. Dr. Srinivas Andamani. That's why he's not coming on to the dais. Who else? The workshops people, Bharat and others, if you are around, I know some of these people are going back to conduct the workshops. Hands in India, Srinivas Garu. Please do join us. iDream Media, if you're there, please. Ideal events, Praveen and Teja from XUG. One Glint I have already called. One Glint if anybody is here. Ravi Garu from One Glint if you're here. Please do join us. My Startup TV, Kiran. Again, I'll be missing out names, so please help me with the names as well. I have a very poor memory power, so please help me with the names. Whoever I have not called, please help me with the names. Swecha is in him, called twice, thrice, but they have... Anila. Please. Yeah. Who else? I know there. Naveen Garu. Run, sir. Run. Sripat is missing today, but... Yeah, I have a lot of stories to tell about Naveen from 17 years ago. Sai Praveen, Shashikant is here, Ranjit is here, but see, we are wearing such a big bash for Ranjit's 45th birthday. 40th birthday. Naveen is, yeah. Anybody else? Bhanu, where is Bhanu? Bhanu Prasad. Swamya sir is not here today. Anybody else? Alright, let's do one thing. In the morning we have tried to hit 100 decibels. I won't be as optimistic. I was told that it's a logarithmic scale and all. That's too much mathematics for me. We will try to do something. We are all here. Can we hit 80 decibels first? I have the mic with me. So that should probably help us. Shashikant, I'm not giving the mic to Shashi. Shashi, some special mentions as well. Rajshekhar, Shashikant, Naveen, Narendra, Siva, Ramesh. All of these people I have no idea. Ajit, come. Ajit also, all of these people. These people would have cussed me in every language they have known. They have probably invented new languages to cuss me because, everything and anything, my first call goes to, these people. Everything, I call all 5 of them. Shashi, I've done this, Shashi was called by at least 200 people. Rajshekhar was telling me, Anna, I was getting 25 calls at the center. Yes. I was getting 25 calls at the same time, somebody developed a technology where I can answer all 25 calls at the same time. And all of these people, there are people who pushed everyone. We have worked as a team. What we have seen, there is a lot of the behind the scenes, not just Naveen having his dinner. There's a lot more to behind the scenes. People have spent sleepless nights for not just the last 2-3 days. This was an effort of months, and I think we are all very happy to have seen the results today. All the speakers coming in, delivering not just the sessions, deliberating in the panels, and then saying that we are going to be associated. What I should tell you what Sunil Abram, Facebook director, He said, Praveen, I'm promising this is only the beginning. We will continue to collaborate with you. In fact, Jayesh Ranjan, who was here, he's mentioned multiple times that they'll be happy to collaborate with us. And we have all of this has been possible purely because of the collaboration and teamwork of everybody over here and hundreds of volunteers. All the white shirt volunteers, can I please ask you to come onto the dais? All the volunteers, have been doing all the work over the last 3 days. All the white shirt volunteers, please come in. Volunteers, oh, now they are wearing red shirts. Shirt color grey shirt, white shirt, maroon shirt, whatever it is. X code volunteers, please come onto the dais. This would not be possible without all of you. Volunteers, please come onto the dais. ఇక్కడికి వస్తే అన్న 80 decibels రీచ్ అవుతుందేమో అని. Volunteers, let's all come together. Now let's try and attempt the 80 decibel challenge. We were at 77. Krishna, you'll correct. You'll tell me. This is a logarithmic scale only. 77 to 80, I don't know. Ready for it? We'll have the mics. I have the mic. If we hit 80, then we'll go to 90. Then we'll see if we can actually hit 100. Doctors over here, Suresh got 100 decibels. Is it safe for the ears for like 2 seconds? Even I do okay, okay. Volunteers, also all the participants, may I request you all to come here closer. We'll see if we can hit 100 decibels over there. Shall we all come here? Shall we all come closer here? Come closer. Come closer. Let's see if we can hit. In the morning we tried to hit 100 decibels. Naveen ensured that we could not hit it because he was hiding the laptop somewhere there. He was hiding the laptop there. Now also we have to shout that side. See if we can hit. This was morning session. Okay, 5 minutes. Everybody, let's come close. Let's come close. Let's come close. Let's see if we can hit 85 to begin with. Should I be ambitious or should I say 80 decibels to start and then? Okay, we'll first try without the mics. What should we say? What should we say? We, us, AI for society. We'll try Swecha. Okay, we'll all try Swecha. Swecha, we'll see if we can hit. Keep it, just start it. Mali stop it. Mali jekala. 1000 okay. Just keep it started. Okay, we are at 70. Hello. Hello. I'm going to turn off the mic. Okay, we'll hit 90. We'll hit 90. Okay, 90 is our target, everybody. On count of 1, 2, 3, we will say Swecha. Count of 1, 2, 3, let's all say Swecha as loud as we can. Let's see if we can hit 90 to begin with. Alright. 1, 2, 3. We're at 78. We're at 78. Come on. Where is stop akkale? No, it's showing magazine. Where is the ekkadunadi laptop? Koncham dekkar teesirannaya. Alright, we'll try once again. We'll hit at least 80 here. We'll hit 80 and we'll go. Okay? Sorry, you're going only after you hit 80. Volunteers, I need you on the stage. We need to hit 80 decibels. Okay? We're trying once again. 1, 2, 3. It has been try with the mics. We'll try with the mics once. Last attempt we'll try. Hello. దగ్గరికి వెళ్ళారు వాళ్ళు. మైక్ ఇక్కడ చెప్పిన మైక్ అక్కడికే చేయండి. అక్కడ స్పీకర్లు మారు. Okay, all right. Once again. Have your mics on. One last attempt. We'll see if we can at least hit 78.5. Mic. Right, everybody please come to the mic. Come closer. All right. Ready. Please have your mic.
అది పనిచేస్తుందా?
One, two, three. I'm sure Naveen has speak this. I'm sure it is because Naveen didn't want us to. But good. Photos. Please stay back for photos. All of you onto the dais. Let's have some photos. Then we can. Then there's tea and samosas available. All right. Once again, let's give a big round of applause to everybody.
ఇక్కడ నేను నడిస్తే అక్కడికి వెళ్తుంది కదండి.
Some photos, please. Snacks are available. Snacks are tea, samosa, and others available.
Come on, now. స్వేచ్ఛతో పయనం, స్వేచ్ఛతో పయనం, స్వేచ్ఛతో పయనం.
మొత్తం ఆగం ఫోటో తీస్తాడు ఎటు అటు చూడాలా రైట్ పట్టుకో బ్యాగ్ నీ బయోగ్రఫీ తెలియదు ర్యాండమ్ ఎందుకురా ఎవరు చెప్పాలి ఏం చెప్పాలి ఏం చెప్పాలి అని చెప్తే అది చాలా
Swecha.